Good evening, everyone. Good evening. Good evening. Good evening. Good evening. Welcome back. Welcome back to your own platform, this amazing platform of PW English. And as you can already see, today we are going to complete part 1 of 11th grade. Hi, good evening, everyone. Good evening. I am all good. How are you all? I'm good. I'm good. Great to see you all. So today we are going to talk about all the concepts that are in the NCERT. So this is very important. Today we are going to talk about NCERT. This is for primarily this is for CBSE students, but all the students who are preparing for NEET, all the students who are preparing for JEE mains, it's going to be beneficial for you as well because the concepts are same and pretty much the course is also same, right? So how long will this lecture be? So I don't know. Well, it will be as long as it might get, right? So quickly write down in the chat box if you're all now ready. Quickly. Just a second. So friends, today we are going to start our lecture with motion in a straight line, right? So the first two chapters are going to be part of kinematics. So first we are going to start our class with kinematics. That means one-dimensional motion, two-dimensional motion, right? And then we are going to talk about laws of motion, work power energy, system of particles and rotational motion. So inside this we are going to talk about both the things, that is center of mass and rotational motion. And the last topic is going to be the sweet and simple, that is units and measurements. All right. Well, the class is going to be in English. I can't speak in Hindi because this is an English medium channel, but ha and na I can use, right? Hopefully everybody knows these two words. So the reason that I have kept the very first chapter at the end is that units and measurements is not that interesting. Well, I am not going to say that it is boring, but there are not going to be many difficult concepts in this chapter. And moreover, the CBSE has even reduced the syllabus. CBSE has deleted many of the topics from the last chapter, from this chapter, that is units and measurement. So we are going to cover this chapter at last, right? Now quickly write down in the chat box if everybody is ready. Shall we start? Shall we start the class? Now my only request from all of you is stay connected throughout the class, because this is going to be very beneficial. I'm not just going to talk about like formulas. We are going to do derivations. Again, derivations is important for both the students who are still in schools. Obviously it's very important for them. Derivations is also important for students who are appearing for NEET as well, right? Or exams like NEET. The reason is that through derivations we are going to understand the concepts of integration, concepts of differentiation, and we are going to talk about drawing free body diagrams of different objects in different situations. So it's not like that you'll be able to get a good marks in physics in any exams without going deep into the derivations, right? So we are going to talk about each and everything that's in NCERT. So this is a disclaimer that we are going to not talk about the parts or the topics which are not in NCERT, right? Obviously we are completing each and everything in our batch, but today's class is supposed to be concentrated on NCERT only, right? So I can see all of you are really excited. Let's start the class. Let's start with the motion in a straight line. And motion in a straight line is also known as rectilinear motion, or also known as one dimensional motion, or also known as, do we have any more names for this? We have got like 3 names: motion in a straight line, rectilinear motion, one dimensional motion, right? Now how we are going to define this thing, one dimensional motion? We are going to say that if let's say body is changing its position, with respect to a frame of reference. So how we are going to start? We are going to say that if let's say body is changing its position with respect to time, and a frame of reference, or I'll just write it as, or a reference frame, in such a way that this positions only one coordinate is changing, only one coordinate is changing. Or we can also say in simple terms that if a body is moving in a straight line, that means it's a rectilinear motion. Easy peasy, right? If it is traveling in a straight line, that's a rectilinear motion or a motion in a straight line. But why I have started with this definition? That this also explains how you are going to distinguish whether a body is in motion or at rest. For example, is right now, am I at rest or am I in motion? So you are going to say, sir, at this particular time, we are not going to see your hands, you are at rest, right? Now rest and motion are relative terms. There's nothing like I'm at absolute rest, or there's nothing like absolute terms. These are not absolute terms. A body cannot be in absolute motion or it cannot be in absolute rest, right? It depends on the reference frame, or also known as frame of reference. Now this thing is very important in physics, right? So although we are starting with from the very basics, but the concepts lie in the basic things. Reference frame is very, very important. You know that we are going to use it again when we are going to talk about Newton's laws of motion, right? You know that Newton's laws of motion are applicable only for those frame of references which are not accelerating, which are known as inertial frame of reference, right? So we are going to say that a body is moving, a body is in motion if it changes its position with respect to time and a reference frame, right? And if this is the motion, along with this, if you are going to say that the body is moving only in a straight line, that means we are talking about a rectilinear motion, right? That means we are talking about a motion in a straight line. Everything's clear with the basic concepts of what do we mean by one dimensional motion. If let's say more than one coordinate is changing, out of, like, if we are talking about position, we know that we are basically talking about x, y and z. These are the 3 points, these are the 3 coordinates of which we are actually talking about. So if only one of them is changing, that means it is moving in a straight line. If two of them is changing, any two of them is changing, that will be called as a two-dimensional motion. If all the 3 are changing, that will be called as a three-dimensional motion. After this, we are going to talk about position vector and displacement vector. Now please understand, all the students who are right now in 11th grade, because right now, because this marathon is planned for specifically for those students who are in 11th grade, right? Although I have said it doesn't matter if you are in 11th grade, 12th grade or in 13th grade, that is the dropper student, it doesn't matter, it's going to be beneficial for every one of you. But for all of those students who are in 11th grade, I know how you are feeling, right? So this is the first time when you must be going through a deep, what we can say, a mixed type of a feeling, or not mixed, a very bad type of a feeling as far as physics is concerned for most of the students. The reason is that up until grade 10th, you are not really, we were not really talking about all of these concepts. We are not really talking about differentiation, integration in physics, right? We were not talking about vectors in physics. Now what has happened? We are talking about physics, but let's say almost like 20 to 30% is mathematics involved in this, right? So I can really feel how you guys are feeling, because I was also, once I was in 11th. So now the thing is how to actually come out of it. So this is the time, this is the correct time, come out of that feeling, don't hate this subject. The only way to get on the better side or get on the good side of this subject is to get through the basic concepts. And what are the basic concepts? The basic concepts is position vector and displacement vector, one of the basic concepts. Why I am saying that? Because you are going to again use these, I like this concept in almost in every chapter. Whether you are in grade 12th, whether you are going to talk about electrostatics, whether you are going to talk about any chapter, we are going to talk about position and displacement vector. So let's, without any, I've said a lot of things. Now let's start. So what do you mean by position or displacement vector? Let's start with some lines that you already know. You guys are quite familiar with these lines, right? X axis, Y axis, I can also draw Z axis also, but let's just stick with these two. And now let me just say that I have got a point and this is point A. Right, I have got a point and it is point A. Now what I want is, I want to have the address of this point. Like for example, is if you will ask me what's my address, how I am going to explain my address to you. First I am going to tell you my house number, then I am going to tell you my name of my colony, then I am going to tell you the area in which I live, then city, then state, and then country, so on, right? So now if I am going to talk about the position of this particular point, so that will be defined by the position vector. And how we are going to write it? The position vector will be written as something like this. All right. So I am going to interact with all of you. Don't think that I am not going to interact or I am not seeing the chat. I am going to interact with you, but let's start moving. And obviously I am going to take all of your doubts. So please write your doubt in the chat box. When I am going to ask you, you can always write it, but I am going to take some time and I am going to answer your doubts. So this is origin. Let's say the position vector is written as RA. Let's say the position vector is written as RA. So how I am going to write RA? So I am going to write RA as that, let's say the coordinates of this point is x1, y1, z1. Let's say these are the three coordinates of this point. So I am going to write x1 I cap plus y1 j cap plus z1 k cap. So this is how we are going to actually write the position vector of this point. Right, it's quite easy. That means that you need to move x1 distance along the x axis, y1 distance along the y axis, and then z1 amount of distance along the z axis. So you are going to get to this point. Now let's talk about any other point as well. Let's talk about any other point. Let's say we are talking about, this is point B, and the coordinates of this point is x2, y2, z2, right? I've got these 2 points. Now what I'm going to tell you is that obviously we can write this vector as RB. So this is the position vector RB. This is position vector RB. I'm going to write as x2 I cap plus y2 j cap plus z2 k cap, right? Now that's what I was saying. This is all maths that we are talking about. When we are going to talk about physics, let's say that we have got a body which is right now at A. So at t equals to 0, the body is at A. So basically A is the initial position. This thing is the initial position of the body. And we want our body to move to this point, that is the final position. That's what we want. We want a body A to move from point, we want our body to move from point A to point B. Point B is your final position. So let's suppose the body has taken some path, something like this, right? So I'm going to say that the length of this actual path in which the body has traveled, the length of this actual path, and I'm going to just name a point C also over here so that I can really define the path in which the body has moved, right? So I'm going to say the length of the actual path. What do you mean by actual path? The path along which the body has actually moved from initial position to the final position. This path will be known as distance. You have learned in grade 9th as well, right? What do you mean by displacement? So displacement is going to be the shortest distance between the initial position and the final position. So this is going to be the displacement that we are going to talk about. And if we really want to write the displacement vector over here, I'm going to write this thing as RAB, right? This will be written as RAB. Everything's okay, everything's fine, right? Quickly write down in the chat box if you have got any doubt. Quickly write down. Everything's fine. Now if you want me to actually write how we are going to write this RAB, so we are going to write RAB as RB vector minus RA vector, and you can just you can write this thing down. So this is going to be your displacement vector, and these were your two position vector. And if somebody wants to know what do you mean by the magnitude of this displacement, what's going to be the magnitude of this displacement, so just find out this magnitude by I'll just write it also for you. So this is going to be x2 minus x1 I cap plus y2 minus y1 j cap and plus z2 minus z1 k cap. Everything's fine. Write down in the chat box quickly, then I'll move to the next topic. So in a way, by just drawing these position vectors and displacement vector, we have also covered what do you really mean by distance and displacement, right? Yes, right now we are talking about motion in a straight line, then we are going to cover all the other topics as well. Quickly write down in the chat box if you have got any doubt. By the way, if you are going to closely see, I mean I've got something here for you. Can you apply the law of triangle over here, the law of triangle that you have done in vectors? By the way, there's also one more video that's already on YouTube. You don't need to look at that video right now, but you can see that afterwards, in which I have covered the vectors as well. The law of vector addition of triangle says RA plus RAB, right? Are you getting it what I'm trying to say? What does law says? Law says that if you have got a vector something like this, right? Let's say this is vector A, and then you join another vector. You join another vector's tail with the head of this vector, and let's say this is vector B. So the third side is going to tell you. The resultant of these two vectors, that is vector C. That means vector C can be written as vector A plus vector B. Is that correct? Right. Done. So you can see that RA plus RAB can be written as RB. So RA plus RAB can be written as RAB. So RAB can be written as RB minus RA. That's it. Right. Got it? Let's move ahead. Let's talk about what do we mean by. Let's summarize all the points. Let me summarize all the points for you. So this is the good part. This is why this class is going to be really important for you, because whatever we are going to do, whatever the concept that I'm going to tell you, I have also got notes. I've got notes for you. I've got important points so that we can summarize each and everything that we have learned. So obviously distance is a scalar quantity. Why? Because it has got just magnitude. I'm not going to go really, I mean there's nothing for the first point. Displacement is a vector quantity. Please remember it. It has got magnitude as well as direction. How are you going to define direction, by the way? Let's just talk about some basic things one more time. How are you going to define directions? You are going to define directions by the unit vector, right? Now what do you mean by unit vector? So if we really want to find out the magnitude of this one, if we want to find out the magnitude of displacement vector, so I'm going to write magnitude we are going to write mod of RAB, right? That's what we write. So we will write something like x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, right? And if you want to find out the direction, then we can write the unit vector as RAB. Unit vector will be written as vector RAB divided by its magnitude. That's how you are going to write it, right? So moving on to our important points. Distance depends on path, while displacement is independent of path. It depends on only the final and initial position. Everything is clear with this point? You tell me that it only depends on the initial and final position. We have already seen it. I mean, for distance there could be like n number of paths. Like for example, if we really want our particle to go from A to B, it's not like there is only one path, there can be any number of paths. But for displacement, the path is definite. The path is going to be the shortest path in a particular direction. So that's why displacement is a vector quantity, because here the direction is also has got importance. For a moving body, distance cannot have a zero or negative values. If a body is really moving, how can it have a zero? It will travel across some path. So if it will travel across some path, we are going to say that distance will be covered, right? Whereas displacement can be positive, negative or zero because of direction. This is easy things. Infinite distances are possible between two fixed points, because infinite paths are possible between two fixed points, where only single value of displacement is possible between those 2 points. That's what we have said, right? Alright, I can see all of my Yaqeen students. Hi, right? So I've not forgot all of you. Stay connected. Let's quickly move through it. We are going to have some time. I'll chat with you. For now, let's move to some serious topics. These are quite easy. Now, some of the more important things, that's what we have said, that if a body is traveling in a straight line, that means the shortest path and the actual path are similar, because straight line is actually the shortest path. So the magnitude of the distance will be actually equals to the magnitude of the displacement. There is nothing like magnitude of distance. Why? Because distance is just magnitude, right? Got it? Alright. Then what about any other cases? For any other cases other than if the particle is moving in a straight line, distance will always be greater than or equal to the magnitude of displacement. At best, please hear me out, at best the magnitude of displacement can be equals to the distance. And what is that case? When the body is traveling in a straight line. Easy things. Let's move to the next topic. Then we are going to talk about quotients as well. Well, quotients are the main thing. So first let's quickly finish up some theory, then we'll move to some quotients as well. Now, when we are going to talk about speed and velocity, we are going to talk about two types of speed and two types of velocity. We are going to talk about average speed . We are going to talk about speed. So average speed will be written as the rate at which body covers some distance, right? So let's say in time t the body covers distance as delta s, right? Or you can just write it as s also. I mean, you don't have to write like delta s, you can just write it as s. That is the distance divided by time. Let me write it like this, that distance divided by time, or total distance divided by total time. You can write it as delta s divided by t, right? And all of those things, that SI unit is meter per second, right? Easy things, that SI unit is going to be meter per second. It is a scalar quantity, right? It is a scalar quantity. But the thing that we actually want to look into is the instantaneous velocity. Sorry, instantaneous speed for now. So when we are going to talk about instantaneous speed, sometimes you might see, now this is where students actually feel a little bit of what we can say, they get demotivated when they actually, what they do is they look it into NCERT and they see something like this. So they see something like that. We have got instantaneous speed, that's written as limit del t tends to 0, and they see something like del s divided by del t. So they actually, that's when they feel that, okay, so this was all good, this was grade 9th, what the hell is this, right? What do you really mean by limit? What do you really mean by delta t, and why we have got an arrow, something like this? Because most of you have not actually studied limits and continuity in grade, I think you will be studying it in grade 11th, all of those math students. For bio, obviously you are not going to learn any of it, right, in the later part of 11th grade. But for now, let me just explain it. So somebody has written in the chat that we are, who are able to write now, because I don't able, so teach. See, you will get these notes, right, you will get these notes, so don't worry about it. For now, just ask, if you have any doubt, ask your notes, and if you want some more times, I'll wait for some time before moving to the other slides. Okay, that I'll do. All right. Yes, this will be more than enough for your midterm exams. This will be more than enough for your midterm exams. Plus, this will be also beneficial, as I've told you. This will be also beneficial for all the JEE mains and NEET students. Now, what do we really mean by this? First of all, let's come back for all of this speed. If I'll draw the graph of, I've got, let's say I've got time over here and I've got distance over here, right? Now I'm hoping that you know a little bit of some things like what do you mean by non-uniform motion, what do you mean by uniform motion. Let's suppose we have got a graph something like this. That is a straight line. Now we know what's special about a straight line, that for a straight line slope is constant all over the straight line, right? That means if you are going to talk about slope at this point, or if you are going to talk about slope at this point, if you are going to talk about slope at this point, slope is same all over. And what is slope? The slope is actually going to be, we can write slope as theta, that is tan theta, right? Tan of theta. So slope is equal at each point. So whatever the what we can say is that whatever the average speed is, the instantaneous speed is going to remain same. So we don't have any problem with this one, right? Because the body is traveling in the straight line. For example, let's say you are moving on a bike or a scooty with 50 km/h of constant speed on a straight road. So if you are going to ask me what's your average speed, I am going to say it's 50 km/h, and what's your average speed, it's 50 km/h, that's for a straight line. But what if we have got something like, this graph, something like this, alright. So in this case, what I am going to say is, if I am going to ask about the average speed between these 2 points, let's say these 2 points are point A and point B. I'm going to ask the distance between these 2 points. So what are you going to do? So you are going to say, sir, let's say one thing, the distance between these 2 points will be given by this line, that is this, that is something looks like a perpendicular. So let's say this is, sir, that's why we were writing it as delta S. So this is our delta S, and the time taken by the particle to go from this point to this point is, let's say this is t. So the average distance is, the average speed is delta S by t, right? Now what I am going to tell you is, for this one, for instantaneous speed, what we are trying to say is that let's say that delta t is actually infinitely small. It is not zero. So here's the difference. T being t equals to 0, and when we are saying that, delta t, and when we are saying that delta t is tending to 0, it means that delta t's value is 0.000000000000000, and then we can finish our class with just saying zeros, right? So delta t is that small. So if delta t is that small, these 2 points are going to come to a single point, and then at that point we are going to make a tangent. So that's what we are writing. Again, please see over here, the instantaneous speed is the distance traveled by the body in the infinitely small time, right? In the infinitely small time. Got it? Everything's clear? After this, what we are going to actually write this thing as, generally we write this thing as V instantaneous is actually equals to dx by dt or ds by dt. This means that this is actually the derivative of V instantaneous, is the derivative of distance time relation. right? So this everybody knows this. Everybody knows this, that if you're going to differentiate distance time relation, you're going to get speed, right? That's what the slope basically means. All right. So again, we are going to just repeat the same thing with when we are going to talk about the average and instantaneous velocity as well. So when we are going to talk about average velocity, it's just that we are going to put a vector sign on it. So we are going to write delta S by delta T, and we are going to write V instantaneous as, again I can write it as limit delta T tends to 0 and delta S, or right now, yeah, delta S, vector delta S divided by delta T, right? So this thing is going to be, again we are going to use this thing quite often, right? Or what you can also write it as ds by dt, ds by dt. Got it? Clear? Everything's clear? And everything else with this one, that means that these two are going to be vector quantity. SI unit is going to be meter per second. Dimensional formula, some of the formalities, M0, L1, T minus 1, right? So this is going to be the dimensional formula for this one. All right. Moving on to some important points, and you can actually you can use these special points in some of the questions as well. And what are these? You must have done this in grade 9th as well. So I'm not going to give you to solve all of these things. By the way, if you have noted everything down, I'm going to give you time when we have got some important points, something like this, right? And now be quick. You can actually hear me, see this, all of these things, and you can also simultaneously you can write these things, because this is actually not that difficult. It is quite easy. 9th grade problem. When a particle travels with different uniform speeds. What do you mean by different uniform speeds? That these speeds are not changing in between. For example, as particle is traveling with v1, v2, v3 and vn in different time intervals t1. So all across t1 time the speed was constant, that is v1. Then for time t2 the particle was moving with v2 velocity, v2 speed. So what is going to be the average speed? Total distance covered divided by total time traveled. So total distance now can be written as distance, if I am going to write it as S1 can be written as speed times time. So v1 into t1, v2 into t2, v2 into 3 and t3 and so on. And if so, this is the formula that we are actually looking for. This is the formula. And now the special case is if time intervals are equal. So this is the case for the equal time interval. This is the case for equal time interval. Equal time interval. Right? So for equal time interval, it will be v1 plus v2 plus v3 vn and divided by n. Why divided by n? Because these are all same. So we'll just say that these are n terms divided by n. And by the way, this is going to be actually vt, 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 v3. So n times v and v1 times t, v2 times t, v3 times t. So we can take out t as common. Here we have got n times t. We can cancel out that t. And this is your formula, arithmetic mean of speeds. You might use it, right? So it's not something like very difficult to understand. You might use it. The another type of case is that the particle is moving with different distances with these speeds. So what is the difference? The difference is in the previous example, and you can also note it down if you haven't right now. In the previous example, the speed was related with time, that in these time intervals the uniform speeds were v1, v2, v3 and so on. Right? Now what they are trying to say is that these speeds are now v1, v2, v3, these speeds are, they have given that in these distances. That means for s1 distance the speed is v1, for s2 distance the speed is v2. Right? Are you getting it? So if now we want to find out the total distance traveled, I won't convert the total distance into speed times velocity, of course. Why? Because I already know that this is s1, s2, s3 and so on. Now what I am going to do is I don't have the relation, I don't have the information about the time. So now I am going to write, instead of time, like for example, if I want to write t1, so I'll write t1 as distance s1 divided by speed v1. So that means this will be written as s1 by v1, s2 by v2, s3 by v3 and so on. Now again, if these are equal, that means s1 equals to s2 equals to s3 and so on, then again these things can be cancelled out. Here I'll get n divided by, and this thing is known as harmonic mean of speeds. So you can remember this term. Alright. Quickly write down in the chat box if this is all good. These two things you have done in grade 9th also, by the way, right? So it's not something that we are seeing it for the first time. Can we move quickly? All good? Now again, some of the important points from here are that again, since velocity is a vector quantity, it can be positive, it can be negative, or it can be 0. Much like any vector quantities, right? Direction of velocity is always in the direction of change in position. This is actually very important, and from this like for example, I'll tell you something. Let's suppose that we have got a particle, and I'm saying that it is moving in this direction. It is moving in this direction, and that's how I have actually I'm explaining it to you that it is moving in this direction. Now if somebody tells you, now questions are going to come from these concepts, so hear me out carefully. If somebody is going to tell you that a particle is moving in this direction, it means that the particle has velocity in this direction. The particle has velocity in this direction, right? And if the particle has velocity in this direction, velocity can be actually written as rate of change of displacement. It can be dx by dt. I don't write x as, because you must not think that we are just talking about the x axis. We are not concerned with the direction, right? It should be a straight line motion, that's all. Right now, although it is applicable for when we are going to talk about two dimensional, the formula is applicable. Now again come back. So if the particle is moving in this direction, it means that particle has velocity in this direction. It also means that particles, if you are going to talk about in which direction body is having its displacement, or displacement is in which direction, same in this direction only. So they both have same direction always, right? So it's never going to happen like, please don't get confused with like body is moving in this direction and you are saying that, sir, I don't know where the displacement is. Obviously the displacement is going to be in this direction only. But when we are going to talk about acceleration, well, just now we are going to talk about acceleration. Acceleration might be in any direction, right? There is no condition that acceleration must only act in these directions. Acceleration can act in any direction possible, right? Are you getting it? So this is very easy. Speedometer measures the instantaneous speed of the vehicle. Nobody is asking this, but still I have written it, right? All right, let's move to the next one. Next topic is of course acceleration. Very important topic. For speed and velocity, things were quite easy. You just need to remember its definition. For acceleration, obviously the definition is easy for this one as well. We are going to write that for acceleration, it is the rate of change. It is the rate of change in velocity. Now again, this rate of change can be we can actually calculate it in two ways. One is we can say that we'll write it as average acceleration that you have done in what we can say in grade 9, and this is final velocity minus initial velocity divided by time t, right? Or change in velocity divided by time t. And if let's say now again I am going to say that if delta t is tending to 0, see, it's not that delta t is equals to 0, it's tending to 0, it's infinitely small. So at that point we can actually talk about instantaneous acceleration, and that will be written as dv by dt. I can also write it as limit delta t tends to 0, and over here I've got like delta v and divided by delta t. And how we read it? This is actually, we are going to say that delta v is the change in velocity in infinitely small time t, right? Got it? Done? Everything's clear? So, surely we are going to do some questions on this, but for now I'll explain that how to find out like the direction of these directions of these acceleration. So, questions, usually questions on this comes something like this, that we have got an initial velocity in this direction, right? Let's suppose we have got initial velocity in this direction, and the velocity is, let's say, 20 meter per second. The velocity is 20 meter per second, and after time t, the velocity change, the body changes its velocity and it becomes in this direction. Please find out the acceleration, find out the average acceleration, right? In time t, you can give your answer in time t. Find it out, just quickly write it down. How you are going to do it? See, we have got a long class. I'll be with you till night, right? We have got a lot of amount of time, so I'll answer all of your doubts. You can find these notes. I'll figure it out how I'll try that we can actually paste some link in the description box for the notes, right? I'll have to ask it. For all the Yakin students, they'll get it. All right. Yes, Harsh, we are going to talk about integration as well. We are going to talk about almost every part of basic mathematics. It's just I'm not going to teach basic mathematics alone, right? We are going to talk about it. All right, let's figure it out quickly. Yeah. So this is the initial velocity, dosto. This is the initial velocity. This is the final velocity. And let's say I'll also give you the time. Let's say in let's say 10 seconds, this change has happened, and now we have to find out the average acceleration, right? So now I'm going to say that average acceleration is final velocity minus initial velocity divided by time. Now when you say this is final velocity, usually what students do is they know that velocity is a vector quantity, but again they take it for granted. They don't really give focus on this vector sign. If you will give focus on this vector sign, you will get to know that okay, so if sir has written it something like this, that average velocity can be written as final velocity minus initial velocity, what I can do is I can write something like this. And this is the final velocity. Okay, I have drawn the final velocity over here. Done. And this is the initial velocity. So what do you mean by negative times of a vector? So if we have got a vector something like this, so negative times of a vector would be something like this. So this is actually minus u vector. Now you have to find out the vector sum of these two vectors. And by the way, I have for my own good, I have taken their magnitude to be same. So this was also 20 meter per second. This is also 20 meter per second, and they are at 90 degree. So because they have got same magnitude, the resultant will be at their angle bisector, that is at 45 degree. And this thing is going to be what we can say is that v minus u vector. Alright dosto, and what is going to be the magnitude of this? So the magnitude of this is going to be 20 root 2. Alright, done. So the answer for this one is going to be the average acceleration's magnitude is going to be 20 root 2 divided by time. That's the answer is 2 root 2 meter per second square. Sorry, meter per second square, and the angle, now you can find out, this is actually 45 degrees. So whatever in whichever direction you want to write it down, right? Everything's clear? Quickly write down in the chat box. So you are going to see problems like this. Along with this, what else do we know about the about acceleration? We know that this is a vector quantity. Obviously, after doing all of the vector addition, this is a vector quantity. Its SI unit is meter per second square. its dimensional formula is m to the power 0, L to the power 1, T to the power minus 2, right? And in which direction will acceleration will be? In the direction of change in velocity, not velocity, right? Sir, velocity is constant, velocity is not constant. Please, is this velocity is constant? Obviously not. Why? If you are saying velocity is constant, all you can see is that velocity has got just magnitude. But the reality is that velocity has got magnitude and direction both, and both of them are equally important, right? Sometimes if students don't get it, I just give a very layman analogy for this. Let's just suppose for any vector quantity, it's like our name. So my name is Subrat Sharma, right? If you don't know me, my name is Subrat Sharma. So my name, my identity is made up of these two things, my first name and my last name. If you are going to change any one of them, or if you are going to change both of them, my identity will get changed. Much similar to this thing. Like every other vector quantities, if you are going to change either the magnitude, or if you are going to change the direction, if you are going to change both of them, then what we are going to say is, we are going to say that we have got a new vector quantity of the same category, of course, like I have got a new velocity. Alright, sufficient. This is all good. Now let's move to some important points. I will give you time to note it down. First point says, when a particle moves with non-uniform speed, then acceleration of the particle must be non-zero, right? The direction of average acceleration vector is the direction of change in velocity vector, as vector A is written as del V by del T. Are you getting it, right? Can you really now sense this formula, that acceleration is not in the direction of velocity. Acceleration can be in the, well, first I said that acceleration can be in any direction. Now since we have actually learnt it, now I am going to say that the direction of acceleration is along the change in velocity. Alright. Rate of change in velocity. What is rate of change in velocity, Kunal? Rate of change in velocity is, let's suppose that I have got a body whose velocity is changing by 2 meter per second in 1 second. That means after every 1 second, its velocity will change by 2 meter per second. Now, whether it will increase or it will decrease, I am not going into that. All I am saying that its velocity is changing. So what is the rate? The rate is 2 meter per second per second. So that is 2 meter per second square. So for each second, 2 meter per second is velocity is changing. That's it. That's quite easy. Acceleration which opposes the motion of the body is called retardation. For this, I am going to just let you know that first of all, now I am going to again quickly now clear this doubt. Many students have got doubt in this one as well. They say that if we have got a negative acceleration, it is the retardation. No, that's not how we are going to talk about it. First of all, usually what we do is, dosto, we say that in this direction we take positive sign. These are the sign conventions. Once and for all, I am going to finish it up. If at all, if you have got any doubt. So in this, if a vector quantity is acting in this direction, we usually write it with positive sign, negative sign, positive sign, negative sign, right? It's not a rule, it's not a concept, it's just a convention. It's a belief, right? Let's suppose that I'm comfortable in solving questions like this. Now please understand what I'm trying to say. Let's suppose a body is moving in this direction. Acha, okay. Alright, so see, I am using Hindi as well. Acha. So if a body is moving in this direction, dosto, that means velocity in this direction. That means acceleration is in this direction. That's for sure. Now let's talk about acceleration. If I am going to say that acceleration is also acting in this direction, then you are going to say, all right, this means that acceleration and velocity are in same direction. So this is the case for what you can call it as a positive acceleration or just acceleration. In this case, the magnitude of v will increase, right? I will also write it for you. So in this particular case, magnitude, well, I will just write it as magnitude of v will increase. And if same case we are talking about, let's say this is velocity and acceleration is acting in this direction, then we are going to say that this is the case for retardation. That in this one, magnitude will decrease, and this is the case for retardation. But it's really not about that writing A with a positive or negative sign, right? Please quickly write down in the chat box if you have any doubt. Sorry. All right, let's move. We have got two more points. By the way, sufficient time. You have wrote it down. Quickly see, we have got some easy points over here, right? Moving on. Sign of velocity, positive or negative, represents the direction of motion, but sign of acceleration indicates the direction of acceleration, right? I think it's the same point, so we have already covered about the direction. Now can we start with the questions? Till now you haven't asked that, sir, when are we going to start questions, right? So now let's start some questions in, let's say, in around approximately 45 minutes we have completed the first part. Let's start some questions. Also I'm going to, in between I'm going to talk about more and more things, so it's not like theory is completed. I'm going to complete theory with some questions as well. Now the question says the displacement of a particle is given by x equals to t minus 2 whole square, where x is in meter and t is in seconds. The distance covered by the particle in first 4 seconds is. Now first of all I'm going to start poll. I will not forget that we have to do poll. I'm going to start poll, but before that, acha chalo, let me explain it. I'm in mood of explaining something. What I am trying to say is that first of all, please understand that this is the displacement of the particle, right? So this is actually a quite, what we can say, a very special type of a problem, in which what happens is that they give you distance, they give you the relation as displacement, right? So this relation is of a displacement relation, and what they ask you is, they ask you about the distance covered. Right, so this is where you can actually commit some of the silly mistakes. How? They are asking about 4 seconds, so you will just put 4 seconds, 4 minus 2 is 2, square of 2 is 4, and we have got an option of 4 over here. So this is a very typical sort of a problem. So this is where you need to actually always, whenever you are forming notes, you also put some stars, you also put that, okay, these are the questions where the displacement time relation is given and they are asking us the distance covered. Having said that, let's start the polls. Where is the poll? This thing is poll, right? So let's start. I'll give you 60 seconds. Start poll. All right. There's something other than YouTube poll. All right. Let's check if the poll will work then. All right. I know that you have got tomorrow test, but I'll revise everything that's coming in test. Now that's a good thing. Don't worry about test. For a body to undergoing UCM, acceleration is non-zero and velocity is variable. Yes, of course, for a UCM, acceleration is definitely non-zero and velocity is definitely variable. All right, let's move. First of all, let me first explain something over here. A little, what you can call it as, it will be a little bit important for you, so please note this. When we are going to talk about displacement time relation, right? How to attend poll? You just write down your answer in the chat box. The poll will catch it. See, if we have got a displacement time relation, like for example, I'll use x as a displacement. If we have got a displacement time relation, xt, and if you are going to differentiate it, this is now for if somebody thinks that we have not done graphs right now, so this is for everyone's, right? So if you have got xt relation and you are going to actually differentiate it, what do you mean by differentiate? By means we mean to say that dx by dt, right? Or what do you mean by dx by dt? We mean to say that slope of xt curve, slope of xt curve. So we are going to get velocity or velocity time relation, right? And if you are going to again differentiate this velocity time relation, this equation, that means if you are going to write it as dv by dt, or it can be also written as the double derivative of displacement time relation. So you are going to get acceleration time relation. Well, acceleration can be, I mean, the equation that we have formed, it can be independent of acceleration or it can has acceleration, nothing else, right? Now this means that we are basically talking about slope of AT curve, slope of AT curve, right? And if you are going to actually integrate, if you are going to integrate the acceleration with respect to time, you are going to get the change in velocity. Or this is also known as area under AT curve, right? I will come back to the problem, just give me some time. Then again, if you are going to actually integrate the velocity with respect to time, then you are going to get the displacement traveled, or this is the area under VT curve. Right? Got it? Now the important thing over here is, dosto, so this is actually something that's important for all of you. So keep this flow chart in your mind, right? I want you to actually have really good grip on this one, right? Quite easy. Xt differentiate velocity, velocity differentiate acceleration. That's why we call it as a rate of change of displacement is known as velocity, rate of change of velocity is known as acceleration. There's really nothing such as, well, actually there is rate of change of acceleration as well, but we usually don't use it. Well, definitely there is nothing as the integral of x with t. There is no physical quantity as such, right? So we are not going to integrate it furthermore over here. We are not going to differentiate it furthermore over here, right? That's it. Now let's come back to this problem, and you have got x and now and they have talked about distance traveled. Why I have kept 2 stars over here? The reason is, if you are going to talk about this x, I have got x written as t minus 2 square of this. Now velocity will be written as, so this is a velocity, right? I'm just talking about the magnitude, not writing the vector sign. I'll write it as dx by dt. So if I'll write it as dx by dt, this 2 will come down. I am using chain rule, so this will be 2t minus 2. You can also expand it or you can differentiate it, but what I've done is I've just kept this 2 over here, then the power becomes 1, and then differentiation of t is just 1, differentiation of minus 2 is 0. So 2 times of t minus 2. Now what's so special about this thing? Whenever you are going to see something like this, please understand that there is a point when the velocity is becoming 0. How do I know that? Because there is a negative sign and I have got t over here. So I can just look at this equation and I can see that these type of problems are of that I call it as turn around problem. What do you mean by turn around? So in Hindi we can say that as these particles, they do something that is called as palti marte hain. In English I am calling it as turn around, right? That's what my sir used to call it, right? So now for this one, what's really special about this thing is that at t, now we can easily see, and if you can't see it, you just do one thing, substitute v equals to 0. That means 2 times of t minus 2 equals to 0. That means at t equals to 2 seconds, the body is actually it is coming at rest. Now what will happen after coming at rest? It will again move in the opposite direction, and I'll explain it how it will be. So at t equals to 0, so please understand, this is all not for solving this problem. This problem is not that big. This problem is quite easy. After this, we have actually successfully solved it. How? I'll solve it, then I'll explain it. Else you will think that, oh, to solve this small problem we need this much amount of time. No, not that. That's not the case. You have got time over here. You have got velocity over here. This is basically 2t minus 4, right? This is basically 2t minus 4. That means at t equals to 2 seconds, the velocity is becoming 0. So t equals to 2 seconds is this point. Done. At t equals to 0 second, the velocity is minus 4 meter per second. So let's say minus 4 is somewhere over here. Let's just join them. So this is the thing, right? So this is actually minus 4, this is 2, and they are asking at 4 seconds. So let's suppose that 4 seconds is somewhere over here. So at 4 seconds, the velocity is also 4. So this is 4. Now they are asking about the distance. Distance is actually the area under the curve. So find out the area of this thing and find out the area of this thing quickly. These two areas, these two triangles. So half base into height, that means this is actually 4 meter. Half base into height, are you getting it? Half base into height 4 meter. This is also half base into height 4 meter. So the answer is 8 meter. There are more ways to solve this problem. It's not something like you can only solve it using the graph. You can also solve it orally, literally orally. I'll tell you how. Now this is the explanation part. At t equals to 0, the body has got minus 4 meter per second of velocity, and at t equals to 0, the particle was at x equals to 4 meter. Now please see here. At t equals to 0, so let's say this is origin, this is x equals to 4 meter. So at t equals to 0, first of all, the body is at 4 meter and it is moving towards the origin with the speed of what? With the speed of 4 meter per second. Are you getting it now? And at 2 seconds, if you are going to talk about, just put 2 over here. So at 2 seconds, the body comes at origin. So this is at 2 seconds. So at this point, the particle's velocity becomes 0. So it stops. Then after again, it starts moving in this direction. So that is why we just can't put the value over here, and we just can't find the value, right? Because this is displacement. If you are going to find out, the displacement will be 0. Why? Because again after 2 seconds, the body will again come back to this point only. So initial and final position are same. Easy peasy. Now let's move ahead. So let's find out the result of the poll. So the correct answer was B. Well, only one student answered it correctly. Well, that's not good, but please write down in the comment section now if you have got it. Write down in the comment section. I don't know why you have opted for 12 meters, but let's quickly check it. If everything's clear, quickly write down in the chat box. Ads are breaking the flow. All right. Got it? Everything's clear. Can we move to the next question? Let's move. This is also very important, by the way. This is also very important. Let's move to the next question quickly. This is the next question. A lift is coming from 8th floor and it is just about to reach the 4th floor, taking ground floor as origin and positive direction upwards for all quantities. Which one of the following is correct? All right. Quickly, let's solve it. 60 seconds. More than sufficient. Forget about the last one. If you have got it, let's move to the next one. Please comment in, please write down your answer in the chat box. That's how the poll is going to work. Just write A, B, C, whatever the option is, that's it. 8th floor and 4th floor. So the lift is coming down, is just about to reach this one, right? So if it is just about to reach, that means what they are trying to say is that it is going to come at rest at this point. So if it is coming down, so if it is coming down, that means velocity is in this direction, right? Along with velocity, displacement is in this direction. So taking upward direction as positive. So they have already told you the sign convention, right? So velocity and displacement are going to be less than 0. That means there will be written with a negative sign. And it is coming to at rest. It means that acceleration must act in the opposite direction, else it will never come to rest. Are you getting it? It is about to reach at the 4th floor. About to reach at the 4th floor means that acceleration will act upward. So acceleration will be positive, right? So acceleration is positive and both of them are negative, which makes A as the correct option, right? Got it? So this is not a recorded class. I can see that you're spamming, right? This is not a recorded class. All right. So correct answer is A. Everybody is satisfied. Let's quickly check the poll result. All right. That's what I like to see. Good. Done. Let's move to the next one. All right, a particle executes the SHM. So because we are talking about some midterm, we are preparing for midterm exams. I've got some purely theoretical questions as well. Although those questions are also, they are going to help you in your exams as well. But this is a pure theoretical question. A particle executes SHM described by x of t equals to. So x of t is actually equals to x naught times 1 minus e to the power gamma times t, right? t is greater than 0 and x naught is a positive constant. Where does the particle start and with what velocity? So they are talking about where does the particle starts and with what velocity, right? So if they are really asking us that where will the particle start, so we are going to say that we will first put t equals to 0, right? For t equals to 0, that means x of 0 will be x naught times 1 minus e to the power gamma times 0, right? And this will basically become e raised to the power 0. Anything raised to the power 0 is 1. So this will be x naught times 1 minus 1. So this is at origin. So it is starting its journey from origin. Everything's okay? Now they are saying that for this one there is no pole, obviously, right? I've got many more questions for pole, don't worry about it. Come back. So it's starting from origin. E raised to the power gamma times 0, gamma is a constant, 0 times anything is 0, e raised to the power 0 is 1, right? So 1 minus 1 will be 0. Everything's okay. Now they are saying that where does the particle start and with what velocity, right? So with what velocity basically means that we need to find out dx by dt. So let's differentiate this equation. So if you are going to differentiate it, first what I am going to do is I am going to write it something like this. Differentiation of, let's first write it as x naught minus x naught times of e raised to the power minus gamma t. Everything's okay till here? I have just multiplied x naught with 1, x naught with minus e to the power gamma times t. Then differentiation of x naught with respect to time, because differentiation we can distribute differentiation over addition. Then again x naught and differentiation of e to the power minus gamma times t divided by dt, right? X naught is a constant, right? That's what we can actually see, that it is a positive constant. So x naught, the differentiation of x naught will be 0. For this one, I'll write it as x naught differentiation of e raised to the power f of x. it is just e raised to the power f of x, and we also apply the chain rule. So this is x minus sign x naught e raised to the power minus gamma t, and then in differentiation of gamma minus gamma t. So that will be minus gamma, minus and minus plus, and I have got one gamma also over here. So I have sorry, this is just 0. So this is my answer. So this is going to be x naught times gamma, x naught times gamma e to the power minus gamma t. Now they are saying that find out the velocity when the particle starts. So particle starts at x equals to 0, also we can write it as t equals to 0. So at t equals to 0, v of 0 will be x naught times gamma e raised to the power 0 will be 1. So this is what the velocity is. Cheen dabak dum dum. All right. Quickly write down in the chat box if this is all good. This is the reason that I haven't taken this in the poll. Quick, and I'll tell you one more interesting thing. Interesting thing is, and if you will remember it for always. Yes, I read everything. I sometimes I ignore some of the thing, but I read everything. Please understand. If you will remember it, it will actually give you a lot of benefit. And the thing is, and obviously for those students who have not opted maths, that means bio students, can you see something over here? This is, I think, which is going to give you this is what it's going to make you feel sad or make you feel hate physics, right? E raised to the power minus gamma times t. What the hell is this? Where's physics? Where's physics in this? So this is just an equation. It's very easy. I'll tell you something. Whenever you see something like this, na, e raised to the power, this is actually very sweet and innocent kind of a function, right? E raised to the power f of x. Whatever we have got over here is, right, this should be dimensionless. Please understand, this should be dimensionless. All right, this should be dimensionless. E to the power of f of x should be dimensionless. It means that I have got something over here as e raised to the power minus gamma times t. I know that time, the unit of time is seconds. I know that, right? At least I know this thing, that SI unit of time is seconds. It means that if e raised to the power f of x should be dimensionless, then gamma should have the dimensions of per second. Are you getting it what I am trying to say? That gamma should have dimensions of per second, so that these two things can cancel out and the final output can become dimensionless, and it makes complete sense. Can you please see V0? What is V0? This is not V0, this is velocity at origin. Velocity at origin is written as x naught times gamma. Velocity at origin is written as x naught times gamma. X naught is position, definitely meter. Gamma, I told you that this is per second, which you might think that okay, the sir is telling, but how can we actually believe him? Now can you believe me that it is meter per second, right? So question might come something like this, that please tell us the unit of gamma. What is the unit of gamma? So it is per second. All right, quickly write down in the chat box. Quick. So we don't have poll for this one. Let's move to the next one. Now quickly let's start solving the equations of motions. From this thing, if you are going to see, these are all the equations of motion we have got over here. If you are going to see that we have got something like, we have written it as acceleration equals to the rate of change in velocity, dv by dt, right? for all of those students who still want that. We want actually, we are going to complete each and everything, don't worry. We want to have derivations for these things, right? So how we can do actually, we can write dv as a dt in vector form, and now let's say let's integrate it. How to put lower limits over here? We have got time over here, so we usually say that we start judging the motion at t equals to 0. Let's say at t equals to 0 the body has got initial velocity u. After time t we say that velocity is v. We are integrating 1 with respect to velocity, so we will get v, right? Initial velocity is u, final velocity is v, equals to we have got a. And by the way, this is now very important, that all of these equations are only applicable only for acceleration equals to constant, that is uniformly accelerated motion. Are you getting it? So if you don't, if the acceleration is not constant, you are not going to use all of these equation. Any which way you can't use it, right? How you're going to put one single value of acceleration on these equations, right? Coming back to the derivation, so this will become actually a times t, and this will be from 0 to t, right? So this is a variable, don't get confused. So putting upper limit instead of the variable we'll get v, putting lower limit instead of the variable we'll get u, putting the upper limit instead of the variable t we'll get a t, and we don't have to put 0 for the lower limit because it will be 0. So that's how, and by the way these are all vector quantities, that's how you're going to get v equals to u plus at, right? It's nothing really something to worry about. After this, so this was the first equation derivation. This for the second part. For the second part, what you can do is you can actually you can write velocity as dx by dt, right? And you can find out, you can write dx as v times dt, and instead of writing v you can write it as u plus at into t, right? And then you can again integrate it, and then again the same thing. So that's nothing to actually worry about. So in short, the relation that we are going to use is v equals to u plus at, this t over here, s equals to ut plus half at square, v square minus u square equals to 2as. Now this is something important, this is the displacement travelled in the nth position. So this is important, right? This is initial velocity plus acceleration divided by 2 times 2n minus 1. What is displacement travelled in nth time? Everything's clear? Everything's clear? Let's move on. What is displacement travelled in nth time? So displacement travelled in nth time is, let's suppose we are saying that the particle has travelled, and this is the t equals to n second. This is t equals to n second. This time is t equals to n second, right? So I'm going to write something like this, that this is the displacement covered in nth second. Sorry, n second. Displacement covered in n seconds. Now I'm going to write displacement covered in n minus 1 second. So displacement covered in n minus 1 second is, let's say this. This is, let's say, n minus 1 second. So this is going to be s n minus 1. So this is what we are talking about, that is the nth second, right? So this is the nth second. So displacement travelled in nth second will be actually equals to displacement travelled in n second minus displacement travelled in n minus 1 second, alright? And displacement is actually equals to ut plus half at square. So just put the values of, instead of t put t equals to n, instead of t put n minus 1, right? After solving it, you are going to get u plus a by 2 into 2n minus 1. Everything's okay? Quickly write down in the chat box. Alright. Moving on. Let's move to some more questions. Quickly. A ball is thrown vertically upwards with a velocity of 20 meter per second from a top of a multi-story building. The height of the point from which where the ball is thrown is 25 meters from the ground. How high will the ball rise from the ground? How long will it be before the ball hits the ground? Can I give this question in homework? Can we give this question in homework, or shall we do it? Quickly write down in the chat box. Quickly write down the answer in the chat box. Homework? Alright. So let's do this one in homework. Alright. This one is quite easy. I'll explain it. This one is quite easy. So we have got a multi-story building, and they have told us that height of this multi-story building is, the height of the point from where the ball is thrown is 20 meter from the ground. So this is 25 meters. This is 25 meters, right? And then they have said that it is thrown vertically upwards with 20 meter per second of velocity. So 20 meter per second of velocity. Alright, so it's quite easy. So if you want to find out the time, see first what will happen. It will go up to a certain height, the velocity will become 0, and if we are taking g to be 10, in 2 seconds it will become 0, because acceleration due to gravity always acts downwards. This is also a type of a doubt students sometimes have, that where does acceleration acts, right? I mean, they obviously don't have doubt that where does acceleration act, but what they do is they actually sometimes they mess up with that sign of the g. So if you are assuming that acceleration due to gravity is acting downward and the sign is negative, always keep this as negative. Don't have these kinds of doubts in grade 11th. Alright. So if g is 10, this is 20. So in 2 seconds it will come to rest. So this t1 is actually 2 seconds. After this, again it will take 2 seconds of the time to again fall back to the same point. That's not how you're going to do in school. In school you're going to say that, let's say this is point A, this is point B, right? So from point A to B, you're going to use the equation v equals to u plus at, and v is actually 0, u is actually 20, acceleration is minus 10. So t1, I'm just putting this as t1, so t1 will come out to be 2 seconds, right? After this, you can actually just write it down, that means that it will take again 2 seconds to come back to point A. This much you can write it down. This is applicable in school as well, right? After this is also applicable, that if it has got 20 meter per second of speed at this level, it will have 20 meter per second of speed at this level as well, right? So 20 meter per second, and you have got 25 meters. So again you can find out the time. Whereas if you want to have quickly, you have to find out the you have to quickly find out the time. What you can actually do is you can directly use the second equation, s equals to ut plus half at square. So instead of s, write minus 25. Why minus 25? Because I am assuming this to be origin, this is the positive direction, this is the negative direction. So the displacement that will be covered from this point, it will go up, it will come down, then so displacement is this, right? So displacement is minus 25, initial velocity was plus 20 times t minus half g t square. Everything's okay now? So this is 5, this is 4, this is 5. So this is actually something that we can write for this one as t square minus 4t and minus 5. Is that correct? So I can see that this is going to be actually 5 minus 1, right? So 5 minus 1, that means This is going to be 5 seconds. Of course, 5 seconds more than 1 second. So this is 5 seconds is the answer. So 5 seconds is the answer. And if you want to find out the height, for finding out the height, you can just use this third equation. So third equation is v square equals to u square minus 2a. I'll just write it over here, that v square equals to u square minus 2a into h, right? You can find out h from this one. Everything's clear? Clear, clear, clear? Quickly write down in the chat box. So that's what I was giving it in homework, but okay, we have done it. There's no problem with this, right? Now let me give some of the questions in the homework. Let me give 2 questions from at least from this in homework, right? This one is in your homework, and for everyone else, please write down the answer in the comment section, right? Whenever you're going to solve it, write down the answer in the comment section. Leave your answer in the comment section. Although for this one, what do we have over here? The variation of quantity A and B plotted over here. So if you're going to talk about graphs, right? If you are going to talk about graphs, just have a clarity about graphs. What do you mean by clarity? I mean to say that, let's suppose we have got something like, I'm drawing a different types of graphs over here for you. And usually we have got time over here, right? Usually we have got time over here, but I'm just explaining you this as for a maths perspective, from a maths perspective. This is y-axis. We have got a physical quantity over here. We have got a physical quantity over here. If we draw a graph something like this, what does it means? It means that y is proportional to x. This is a straight line graph. This means that y is proportional to x, right? So the thing is, if you have got something like a graph like this, so it means that with increase in x, which is usually time, so time always increases, right? The whichever quantity we have got over here, the change of that quantity with respect to time is actually constant. How I can say that? Because it is a straight line, so it means its slope is going to be constant. So what can be the graphs, what types of graph can we have over here? So we can have a uniform motion over here for this one. Please see, that's what I have not written a specific. I can have uniform motion for this one. Why? Because for uniform motion, and by the way, for uniform motion for what? Uniform motion, and this graph for uniform motion, it is going to be displacement time graph. Why is that? Because for a uniform motion, velocity is constant and velocity is slope of displacement time graph. Or what you can have for the same graph, you can have a velocity time graph for A to be constant. So if acceleration is constant, what is acceleration? Acceleration is dv by dt. So if acceleration is constant, it means that dv by dt will be constant. That means slope will be constant of what? Vt curve. Are you getting it? Quickly tell me. Is it good? Can we draw anything else? Yes. One more thing, that if acceleration is not constant, we can have a graph something like, I'm just talking about this graph, right? So this is something that is important to actually underline, that we are just talking about this one. So we can also have it as an acceleration time curve when acceleration actually depends on time. Acceleration is increasing with time at a constant rate. Got it? Done. Everything's clear for this graph. So for a single graph, you have these many graphs are possible. Now let's suppose I can have one graph something like this, right? Something like this. I'm not going to write it all for you, but I'll explain it. So this is a graph for a case when whatever the physical quantity we have got over here is not changing with respect to this physical quantity, which is obviously time. So if we have got time over here and this is not changing, then first type of graph, if you are going to tell me, sir, sir, comment on a if we have got a displacement time graph, something like this, comment on it. So if you have got a displacement time graph or position time graph, that means the body is at rest. The body is at rest, right? Because it is not changing its position. The position is not changing. So the body is at rest. Then next, if you are going to tell me, let's suppose this is a velocity time graph, comment on it. It means that velocity is constant with respect to time. So whichever quantity we have got here, that is constant. So if velocity is constant, that means it is a uniform motion. So this graph is actually for a uniform motion. But uniform motion and velocity time, are you getting it what I am trying to say? So first you need to understand the graphs, understand the maths behind it, and then come back to physics, right? Again, if we are going to talk about acceleration time graphs, I am going to say it is a case for a uniformly accelerated motion. That means acceleration is constant over here, right? Do you want me to write it? I'll write it quickly. I'll write it. So for the second one, it could be a velocity time graph for uniform motion. I'll just write and it could be a displacement time graph for a body at rest. It could be a acceleration time graph for acceleration to be constant. That means uniformly accelerated motion, right? Got it? Then let's draw another graph, something like this. Let's draw another graph. So again, we have got a quantity over here, we have got another quantity over here. What can you say about this? We can see that the slope is increasing. Please understand, the slope is increasing. Now I don't have to say slope is increasing with respect to x. Slope itself means that dy by dx is increasing, right? The slope was over here was, we can say that we can draw the tangent like this. Then we can draw the tangent at this point like this. So you can see that the slope is increasing. So we have got a graph something like this, which is actually this physical quantity is actually increasing with respect to this physical quantity at an increasing rate, right? So we can write for this one, I'm going to write it is a accelerated motion, or I'll write it as, this can be a displacement time graph for an accelerated motion. Or if you are going to ask me that please comment for a velocity time graph, let's say this is a velocity time graph. So I am going to say now this is a non-uniformly accelerated motion. I'll tell you why. Why non-uniformly accelerated motion? Non-uniformly accelerated motion because the slope is increasing, and if we are talking about velocity time graph, what is the slope of velocity time graph? It is acceleration. So that means acceleration is increasing. Velocity time graph for increasing acceleration. That means non-uniformly accelerated motion. Somebody has written as a graph, one is constant, second is at rest, third is accelerating upward. Am I correct? No. First you have to talk about what type of graph are you talking. Then you will have to comment, right? This is very important. Chalo. So this is in your homework. Just figure it out. Now I have actually explained everything from this graph, right? Or shall we do it? Let's do it because it will be a practice. Cancelling homework. Let's solve it quickly. Starting poll, 60 seconds. Quick. The variation of quantity A with quantity B is plotted something like this. Quantity B may represent time, Well, yes, it may. Quantity option A or quantity A is velocity if motion is uniform. So if motion is uniform, how it can be velocity, right? That's not correct, because for a uniform velocity, it should, for a uniform motion, its velocity should be constant. Velocity should be constant. So that's not correct. Quantity A is displacement if motion is uniform. Absolutely correct, right? So A is correct and C is correct as for now, right? We can have a, oh sorry, this was have I done it as multiple choice? Can I stop it by any means? I think I cannot. Okay, so I forgot to actually plug multiple choice option over here. Quantity is A is velocity if motion is uniformly accelerated. This is also correct, right? So obviously because of me, your one question you will get it wrong, but what I'll do, I'll just put it as A, right? Most of them is D, so no worries, that was my mistake, right? It is A, C and D. It's a multiple choice question. Got it? Chalo, let's move to the next one. This one I'll give it in homework. A particle is moving eastwards with 5 and 10 seconds. Average, you have to find out the average acceleration. Got it? You have to find out the average acceleration. This is in homework. Last one. Alright, now let's talk about motion in a plane. So I have actually explained almost everything from the first chapter. There is one thing I want you to actually know, and that is actually from the first chapter I want you to know that we know that acceleration can be written as dv by dt, right? And for now let me not use vector signs, although we know that we are talking about vectors, but acceleration can be written as dv by dt. What we can actually do is we can actually multiply dx and dx over here. So we'll get acceleration equals to, now what I'll do is I'll club dv by dx together and I'll write dx by dt together. So it means that now acceleration can be written as dv by dt is actually velocity times dv by dx. So this is also something that you can actually note it down, although it's not used in schools a lot in NCERT, but yeah. So this you're going to use it when acceleration is given as a function of displacement, right? You can use it then. dv by dx. Everything's clear? Moving on to the next chapter, that is motion in a plane. Now let's start this chapter. Differentiation, chain rule. All right, if I think most probably we'll use chain rule somewhere or the other in future. So I'll explain it again. For now, let's talk about motion in a plane or projectile motion or two-dimensional motion, right? So if the body is actually changing its position and two of its coordinates were changing, do you remember? So we call it as a two-dimensional motion. Other than that, we can also call a projectile motion something like, if let's suppose that body has got velocity in two directions, so that means the body is going to change its position in two directions, and we are going to call it as a projectile motion, right? Now for projectile motion, the first case that we are going to talk about is from ground to ground. Now what really I am talking about, I'll tell you. See, if let's say we have got a Cartesian plane over here, and let's say I've got a particle at this point. If it has got velocity along this direction, then it's going to be a one-dimensional motion, right? This body is, the motion is called as a one-dimensional motion because the body is going to just move along this direction, that is x. If the body has got velocity along this direction, only this direction I'll say, then again this is a case for a one-dimensional case, for a one-dimensional motion, right? But if I'll say that the body has got velocity in both the directions, that is, it has got velocity in x direction and it has got velocity in y direction, then this will be called as a case for projectile motion or two-dimensional motion. and these are going to be called as the components of the velocity, right. That means this will be known as, it will be known as the horizontal component of the net velocity or u, and this will be known as the vertical component of u, right. Now see, most of students who face trouble in two-dimensional motion, they actually face one difficulty, and the difficulty is, the problem with them is they actually think that this is a new chapter. This is not a new chapter, this is just a one-dimensional concept, but the only difference is now we are going to apply one-dimensional concept simultaneously in each problem 2 times. One time we are going to talk about just ux. So whenever you are going to talk about anything that is related with the x-axis, now please again come back, give all of your concentration over here. Whatever is happening on the chat box, if somebody is spamming, you don't have to worry about it, right. I don't have my moderator right now, but I'll ask him, right. Got it? So if anything is happening across x-axis, let's suppose somebody is asking you what was the displacement traveled in x-axis, what is the velocity is in the x-axis. So you are going to just worry about this velocity, you are just going to look for the things that are along the x-axis. You are not going to worry about what's happening over here. You are going to say, okay, we are discussing about the x-axis, what is the acceleration along x-axis, what is the velocity along the x-axis, and we don't have to worry about the time because time is same on both the axes, right. So we don't have to worry about it. Other than that, you don't have to say that, oh, what is this ux, what is this uy, nothing, right. If we are talking about ux, just let's talk about x-axis, right. Other than that, there is nothing in two-dimensional motion. I think in projectile motion, then we are going to talk about the case 1, that is case 1, we are going to actually talk about this case, that is ground to ground, ground to ground. By the way, the particle that we actually throw or the particle that we talk about is known, sometimes it is known as projectile. We can call it as an object, we can call it as projectile, we can call it as a body, anything, right. Got it? So what do you mean by ground to ground? Again, that the projectile is projected from ground and it falls back to the ground. So it looks something like this. So this is ground and the projectile is this, right, and let's say the path of the projectile looks something like this. How do we know that? Let's understand this. At this particular point, the velocity, the initial velocity is at this thing, it is something like this. Let's say this is the initial velocity u. The angle that this velocity is making with the x-axis or the horizontal is theta. So the horizontal component is going to be, we are going to write it as ux and I am going to write it as u cos theta. And the vertical component that I am going to write will be written as u sin theta or uy. It will be written as u sin theta. Alright, done, everything's clear. After this, why do we have a path something like this? Why don't we have a path something like this? Why don't a particle goes like this? What's stopping the particle to go something like this? Because initially the velocity vector was in this direction, right? But soon after we realized, or if you don't realize, just throw something in the air at an angle which is not 0 degree, which is not 90 degree, but something in between of that, and ask your friend to shoot a video of it, right? If you are really free. So you are going to find it out that the path of the particle will look something like this. The reason is that the particle doesn't move in a straight line, that we have got gravity on earth and the gravity acts downward, and the magnitude, we know that the magnitude is actually g, and there is no acceleration along x axis. So this is the most important thing that we are going to talk about in projectile motion, right? All right. So acceleration due to gravity is acting in downward direction, that is g. There is no acceleration in x direction. What do we mean by that? This is very, very important. If there is no acceleration in x direction, it means that this velocity will never change. It never changes. Never changes as ax is 0. So that means at any point of time, if you are going to find, if you really want to find out what ux is, its magnitude will remain same. Not ux, vx is, its magnitude will remain same. What about this thing, uy? So for uy, it will definitely get changed because acceleration due to gravity is there. Please understand, the velocity is acting in this direction, acceleration due to gravity is acting in this direction, right? So this acceleration will cause retardation. That means it will decrease the speed of the particle. So, and this particle is making this velocity is making this particle to go in x direction. So after a point, and that will happen at somewhere over here, that is the topmost point. At this particular point, we are going to say that the vertical component of velocity, becomes 0. That is Vy, it becomes 0. Why that? Why only at that particular point it becomes 0? The reason is that if it was not 0 at the highest, at this particular point, then that means this is not the maximum height. It means that the particle would have gone a little bit higher, right? So this is the point where the Vy will become 0, and this is the height that we called as h max, right? All after this distance will be called as, if you are going to talk about this distance, will be called as range. This distance will be called as range, right? And what about the x component, the velocity of the component along x axis? So we are going to write it as Vx, but it will remain as u cos theta. It will remain as u cos theta. Quickly write down in the chat box if everything's clear till now, and ask me if you have any doubt. Quickly. Well, differentiation, we are not talking about the basic mathematics over here, because we have already covered basic mathematics, right? And then it will take too long to complete the entire the first part of physics. So it will take too long. So we are not talking about that, right? Acha, okay. So instead of system of particles, you have got gravitation. Well, sorry for that, but I had to choose the 7 chapters because that makes the half of it, right? So I have gone to the according to the order. Why it remains u cos theta? Why it remains u cos theta? Easiest things, it remains u cos theta because there is no acceleration along x direction, right? So it doesn't, I mean, it's not only about this particular point. If you're going to just find out at any point, if you're going to, let's say you want to find out the velocity at this point, dosto, right? You want to find out the velocity at this point. So what you are going to do is, you are going to say, okay, so at this point I've got a Vy over here, and because I'm just writing Vy all the way, I'll just write it as Vy dash. I'll write it as Vy dash. Let's say this is Vy dash. All right, and this is, you're going to write, sir, this is Vx dash. I'll say there it will not change, so just write it as u cos theta. So Vx dash will be just u cos theta. Is that correct? Is that correct clearly? Quickly tell me in the chat box. Alright, after this, let's find out the 2 or the 3 things that we have got over here. So first let's find the time of flight. What do you mean by time of flight? So the thing that we are going to find over here is the time taken by the particle to come back to the ground. time of flight. Particle was thrown at this point. We consider this point to be origin at t equals to 0. So it falls back and we say that at this particular point, when the particles falls back, the time was capital T. This capital T is time of flight. Done? This capital T is time of flight. That's what we need to know. Now please understand, this is nothing but this is actually the combination of two rectilinear motion, right? In one part says that the particle is moving ahead by u cos theta constant velocity, and in one case the another part says that the body is moving up with v sin theta and then it comes back, right? And then if you are going to combine it, something like this will happen. Because of this velocity the particle is moving up, because of this velocity it is going up, and then it is also coming back because there is acceleration due to gravity. That's why you have got a parabolic path. It means that the time taken by the particle to reach the maximum height will be same as the time taken by the particle to go back from the maximum height to the ground. Are you getting it? Just similar to that, the time taken by the particle to reach the maximum height and to fall back is same, right? If the body takes time t to go up, it takes time t to come down, right? Similarly, time taken by the particle to go from this point to this point will be equal to the time taken by the particle to go from this point to this point. That means let's find out the time taken by the particle to reach maximum height. So I am going to write, let's say t is the time taken to reach maximum height, right? So after this what we are going to do is, now here comes the thing that you need to understand to actually solve two-dimensional motion. I am going to actually say we are talking about the time taken by the particle to reach the maximum height, right? What is maximum height? This is maximum height. Along which axis is maximum height? You tell me in the chat box. I will not move. First tell me along which axis is maximum height. Is it along y axis or is it along x axis? Very easy thing I am asking. Along which axis we have got maximum height? Along x axis or along y axis? Along y axis. Everybody is comfortable with this, right? So if it is along y axis, just talk about y axis. That means let's write Vy equals to Uy plus Ay times t, and these are our vector quantities. So at maximum height Vy is 0. So we will put 0 over here. For Uy it is u sin theta. For Ay it is minus g because we take downward direction as negative times t. So t comes out to be u sin theta by g. So that means this implies that the time of flight will be written as 2u sin theta by g. This is the case for time of flight. Alright, this is the case for time of flight. Also you can write time of flight as 2uy by g. Everything's okay? You have noted it down? Quickly check everything over here. We have found out what time of flight is. Again, it is going to be twice of the time taken by the particle to go from this point to this point. Now let's find out range. First of all, let's define what range is. I have already, if somebody is going to ask you that what do you really mean by time of flight, how you are going to define time of flight. So we are going to say that it is the time taken by the particle to come back to ground. Alright, moving on, let's talk about range. What do you mean by range? Range is the maximum displacement along x axis. Maximum displacement along x axis maximum displacement along x axis, right? So if we are talking about maximum displacement along x axis, that is what range is, right? I just told what range is maximum displacement along x axis. How can we find projectile motion for it is thrown upwards at some height h? Please rephrase your doubt, buddy. Madhusudan, please rephrase your doubt. I can't really understand what you are asking. Okay, all right. I think you are talking about the second case. We'll figure it out. First of all, let's talk about the range. For range, since it is along the x axis, I am going to say that I am going to use Sx equals to ux into t plus half ax into t square. Please see, these are all vector quantities. Displacement in x direction is equals to s equals to ut. T is what? Range was when the particle has come to this point, right? At this point the time was time of flight. That's why we first calculated time of flight, right? Got it? So Sx equals to ux into t plus half ax into t square. All right. So for instead of writing Sx, let me write range. Ux is actually u cos theta, and time of flight we have just find it out, it is 2u sin theta by g. And what is ax? There is no acceleration in x direction. Acceleration in x direction is 0. So it's a simple formula that range is equals to ux into time of flight. So we are going to write range as 2u square sin theta cos theta divided by g. All right. Or what we can do is, instead of writing 2 sin theta cos theta, you can write it as r equals to u square sin 2 theta by g. This is also a formula that we can use. Please write down in the comments chat box if you have any doubt. Quickly write down in the chat box if everything's clear till here. After this, if you are going to closely see this formula, there is an important note. We are going to say that if u is constant, let's suppose I'm throwing a particle and the velocity with which I can throw a particle is constant. I can only throw at u meter per second. All I can do is I can change the angle at which I can throw. So at which angle the range will be maximum? This is the question. So you can just you can easily see that range will be maximum at, if we'll see over here, we'll say that range will be maximum at theta equals to 45 degree, right? And that maximum range will be u square by g. All right. Clear? Moving on, can we move on? Everything's clear with the range, right? After this, we have talked about range, we have talked about the time of flight. Now let's talk about Hmax. Again, now can you do it by yourself? Hmax is along y-axis, so we are going to be only concerned with y-axis. We are not going to worry about x-axis. So we are going to write Vy square, and by the way we are talking about Hmax, that is maximum height, we are going to write Vy square equals to Uy square plus 2Ay into Sy. So Vy is 0, Uy is u square sin square theta plus 2Ay, Ay is minus g into Sy. Instead of Sy, I'll write it as Hmax. So Hmax will be u square sin square theta by 2g, or Hmax can be written as uy square by 2g. So this is also, same thing. 3 formulas, and we have actually derived each thing, right? Everything's okay after this. So see, now I'll again explain something to you. Right now we actually talked about the relations. What were the relations? This was the relation with velocity, acceleration and displacement. All right. Also, if I want to find out the velocity at any point of time, let's suppose I am saying that I want to find out, by the way, I've copied it down, so you don't worry about it. See here what I am trying to say. Let's suppose that we have same case for ground to ground, and I say to you that find out the velocity at time t. So this is time t. This is actually time t, and the initial velocity is u, the angle is theta, everything is same, acceleration due to gravity is same, right? Find out the velocity at this particular time t, I say to you. So what you are going to do? You are going to say that, okay, at this particular point, let's say this is velocity vy, this is velocity vy. We don't have to worry about this thing that is known as ux, which is known, vx will be just equals to ux. We don't have to worry about it, right? We don't have to worry about it. So if I want to find out the net velocity at this point, this is the net velocity. Acha, this actually brings another topic, that if you want to find out the velocity at any point, just draw a tangent at this point. Just draw a tangent at the path. You will get to know in what direction we have got velocity, right? So I've drawn a tangent at this point. So this is the net velocity. This is the x direction velocity. We never have to worry about this. This is always equals to u cos theta. This is always equals to u cos theta, right? The only velocity that is going to change is this vy. So how we can find out vy? So I'm going to just write that vy will be equals to uy minus g into t. That's it. This is my vy. Everything's clear. And what is vx? So vx is just equals to ux, and that is equals to u cos theta. So I can find out the net velocity at this point by just squaring them and taking the root of them. Are you getting it? Right? Clear? So if you just want to find out the velocity at any point, can we do it? Right? Now what I am going to say is, let's suppose that we are talking about, this is a new topic, that is equation of trajectory. First of all, what do you mean by equation of trajectory? Equation of trajectory basically means that I want to have an equation. I want to have an equation in which if I put x, if I substitute x, I should get y. That is what equation of trajectory means. Trajectory, this word trajectory means path. This word trajectory means path. So basically we are talking about equation of path. That means we are talking about a relation between, x and y. We are talking about a relation between x and y, right? Now how to find out the relation between x and y? We already know that at any point of time t, let's say we are talking about this, at any point t, we already know the relation between, we already know what vx and ux is. This is nothing but this is relation between velocity and time. Is that correct? Is that correct? This is nothing but relation between velocity and time. Now what do I want? I want relation between y and x. Is that correct? Clear? So if you are going to closely see, I am going to write something like x equals to x, or instead of x I will write it as y equals to uy times t minus g times t square. You can ask me, how did you get it? What I have done is, this is nothing but this is the position of the particle at time t. So let's say at time t the particle is at here. The particle is at here. So this is y dosto. This distance is y. Are you getting it? So how can I write y? Y will be written as uy into t minus half gt square, right? Okay. What I can write, what I want is, I actually want instead of t, I want instead of t, what I want is, I want time, right? So let's do one thing. If it is applicable for this point, it will be applicable for any point. It will be applicable for any point. Is that correct? Done. All right. So let's do one thing. Let's say instead of t, I am going to write this distance was, by the way, x. This distance is x. This is x. This is y. So the coordinates of this point is x comma y. So I am going to ask you, can I write instead of x, can I write ux into t? You tell me. Instead of x, can I write ux into t? I have done nothing else. Distance is equals, displacement is equals to velocity times time, right? Just substitute from this. We are going to imply that t can be written as x upon ux or x upon u cos theta. That's it. That's all you need to do, right? And to save some space, I'll just write it over here. This means that t can be written as x upon u cos theta. We are going to use this. How? We are going to substitute this t in this equation. That's it. All right. I'll just tell you. I don't recall it right now. I'll tell you, Kunal. Stay connected. I'll tell you. After this, let's substitute the value of t from here into this equation. What is our objective? You don't have to memorize it. You don't have to feel that, oh, this is going really crazy. It is not. It was very easy to understand that at this particular point the coordinates was x comma y. So this is going to be x, this is going to be y. We can write y with the second equation. We can write x using the normal. This is also the second equation, ax is 0. Now we wanted to have a relation between y and x, right? So to have that, let's say that t can be written as x upon ux and just put the value of t over here. So we are going to get y equals to, and now I am going to just put all the values. Instead of uy, I am going to write u sin theta, and for t I am going to write x upon u cos theta minus half g. Instead of t I am going to write x square upon what do I have over here? X upon u square cos square theta. Quickly write down in the chat box if everything's clear till here. Quickly write down in the. Quickly write down. Everything's clear over here. After this, see. Now we just have to do a little bit of maths. We can cancel out this u, right? And I can write y equals to x, this sin theta cos theta can be written as tan theta, minus I can write it as gx square, or if you want I'll just write like half gx square divided by u square cos square theta. So this is one type of formula, but we are not going to use this form. quite often. We are not going to use this form quite often, right? After this, what I'm going to do is I'm going to just do a little bit of manipulation over here, right? A small mathematical manipulation, and that small mathematical manipulation is that I'm going to write y equals to x tan theta minus gx square divided by 2. Now see, I'll write 2u square over here. Done. I'll write sine theta. Now you're going to ask me how you have wrote sine theta over here. So what I'll do is I'll also multiply sine theta. So basically I have just multiplied 1, isn't it? Got it? I have just multiplied 1. So I have written sine theta over here and I have written sine theta over here. So I have done nothing wrong. Then what I'll do is I have got cos square theta. So I'll write one of the cos theta over here and I'll write another cos theta with this sine theta. Hopefully everything is clear till here, right? There is one more thing that we can do, dosto. I'll take out this g from here. So I'll just write x square and I'll write g at the denominator of this thing. Right? What we can see, 2u square sine theta cos theta by g can be written as r. Sine theta by cos theta can be written as tan. So now I am going to write y equals to x tan theta minus x square by r. This whole thing is written as r. 2u square sine theta cos theta by g. This thing is written as r. This thing is written as again sine theta by cos theta. This thing will be again written as tan theta. This is the relation that we were looking for, and this is now important for your school exams as well. Even for your school exam and even for, let's say, there is nothing like derivation in it, right? After this point we have just substituted it, right? After this point we have just substituted the value of t, and after this it's just maths, nothing else. So the last point over here, can I take x tan theta as common? Yes, I can. So I'll write the final form over here. So I'll write it as y equals to x tan theta 1 minus x upon r. X tan theta times 1 minus x upon r. X tan theta I have taken it as common, 1 minus x upon r. That's it, right? Got it? Everything's clear? Done? Quickly tell me in the chat box if everything's clear. It has been taken care of, don't worry. Quick. All right. Let's talk about this. Clear. Great. All right. So we have completed this thing. Now I've got some important points over here. Now please note these two important points. Angle between velocity and horizontal first decreases to 0 and then again increases in negative direction. Is it all good? Can we see? This is the angle that we are talking about. So it is first, whatever the value we have got over here, it will start decreasing. So it is start decreasing. Let's say this is phi. At this particular point the angles become 0. Then it starts increasing in the negative direction. What do you mean by negative direction? This is the y direction velocity, this is the x direction velocity, this is the net velocity, and this is the angle that we are talking about in the negative direction. Phi dash, I'll say it as phi dash. Done? There is also one more thing. You can ask your doubt, no issues. You can ask your doubt. There is also one more thing. Do you remember we talked about that range formula? Acha, we already discussed that it is at 45 degree, right? Okay. After this, what's the next point? Speed, kinetic energy, momentum of the particle initially decreases. Why we are talking about this? The speed is decreasing because uy or y component of velocity is decreasing. Y component is decreasing. This is the reason. Kinetic energy is decreasing because same speed is decreasing, right? Momentum of the particle initially decreases. Why? Momentum is it is why decreasing, because net velocity is decreasing. And same reason, because y component is decreasing. Are you getting it? 45 degrees is the answer. 45 degrees is the answer for the maximum range. After this, let's again come back to some questions. Let's solve some questions again. We have got one question over here. Find out the relation between UA, UB, UC, where these are the initial velocities of the particles, and we have to find out the order in which they are going to be. We have to find out the order in which they are going to be. Alright, quickly, let's find out the order. Going to start the poles. You can see the diagram, everything's clear in the diagram. I'm going to start the pole. Let's check. Can you describe the range, please? What is range? Range is quite easy. Range is the maximum displacement in the x direction. That's it. Good. Very good. All we can see from this diagram is that one thing is for sure. The maximum height attained by all the particles are same, right? Maximum height attained by all the particles are same. And this part, the first one is A, this one is A, so this is going to be range A, RA. Hopefully you have noticed the order in which they are being written. So this is RA, this is RB, isn't it? This is RB, and the last one is RC. Alright, maximum height is same. It means that if maximum height for A, B and C is same, it means that we can say that Uy of A square of this divided by 2G Uy square of this, which is of, we are talking about B, UC square of this, sorry, Uy square of this of C and divided by 2G, these are same. This, by this we can imply that the vertical component of all three are same. Vertical component of all the three bodies is same. Right? Now let's talk about the range. We can see from this one that range for C is maximum, then comes B, then comes A. That's it, right? And also range is written as 2 times of Ux Uy by G. Now you tell me, if range for C is maximum and out of in the formula for range Uy is same for everybody else, 2 is a constant, G is constant, that means it depends on Ux, right? It means that for particle C, Ux is maximum, then comes UB and then comes UA. Is that correct? Quickly write down in the chat box. So according to this, I am going to say that particle C has got the greatest velocity, then comes B, then comes A. So A is the correct answer. Okay, good, very good. All right, let's move to the next one, dosto. Let's move to the next one quickly. I want your answers. Sir, how can we find out the projectile of a body when thrown from upwards from a some height? I'll answer it. Let's do some questions, then I'll answer it. Don't worry. I'll answer your question, Madhusudan. I have read it. Let's quickly solve this one also. In case of a projectile at an angle equally inclined to the horizontal and vertical with velocity u, the horizontal ranges. Easy peasy, 60 seconds more than sufficient. Let's find it out. Quick, 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 quick. In case of a projectile at an angle equally inclined, very easy. If it is at equally inclined with the horizontal and vertical, it means that it is sine 45 degree. It means that u square sine 90 divided by g, that means u square by g, right? So u square by g, that means this one has also got A as the correct answer. All right. So it's about to get A, right? Why? Why only 38.1% have got it correct? Why are you writing 2 and over here? Please understand, for this one I have just used the formula of u square sine theta by g, right? So this was part of that thing, that this was written as u square sine 2 theta by g. So we don't have to write 2 over here. Is that correct? Is that correct? Quickly tell me. Alright, so one of the question in homework, easy one in homework, and I'll start a more difficult one. So this will be in homework. And please write down the answer in the comment section when you are going to solve it. Come back to this one. Let's solve this question. Take some time, I'll explain it to you. Take some time and then let's solve it. A hill is 500 meter high. Supplies are to be sent across the hill using a cannon that can hurl packets at a speed of 125 meter per second over the hill. The cannon is located at a distance of 800 meter from the foot of the hill. Now let's understand this thing. Let's say this is a ground and we have got a hill over here, right? So instead of drawing a hill, I'm just going to draw it using this thing. So this is a hill, just assume it to be right, and it is at the height of this hill is the height of the hill is 500 meters, right? So this thing is 500 meters. All right. Next, they are asking the cannon is located at a distance of 800 meters from here. So that means, let's suppose the cannon is over somewhere over here. So this is the initial position of cannon from the foot of the hill. This is at 800 meters. Alright, cannon is at 800 meters from the foot of the hill and can be moved on the ground at a speed of 2 meter per second, so that its distance from the hill can be adjusted. What is the shortest time in which a packet can reach on the ground across the hill? I have read whole question for you. I've actually drawn the diagram also. Take time, solve it quickly. Going to start the polls. 120 seconds, going to give you some time for this. Quickly let's solve. Motivation, you want some motivation? All right. So the motivation is this, that if you are having a trouble in solving questions like this, it only means that you are just assuming that this question is quite big, you will not be able to solve it. You are just assuming things in your head. You know physics, right? You know everything that's required to solve this question. That's what the motivation is. Yes, we'll have some break, but let's first quickly solve some of the things over here. See, we have already discussed that from this hill the cannon is at 800 meters, right? We know that. And the thing is, the cannon actually needs to be moved ahead. Why is that? I'll talk about it. First of all, let's say that it is at 500 meters. The height is 500 meters, we know that. And let's suppose that at any point from here, it could be here also, right? I'm not saying that, I'm just saying that let's suppose from any point the particle is being thrown. Let's just assume that from any point the particle has been thrown, and the particle has been thrown with u velocity, and that's what they have given us. This u velocity is actually 125 meter per second. Is that correct? Right? It is 125 meter per second. It is the net velocity with which we can actually throw the cannon. Got it? Now what we are going to do is, we are going to say, all right, so that means this is uy and this is ux, this is uy and this is ux. If we really want this packet to actually reach on the other side of the hill, if we really want this packet to reach on the other side of the hill, what we would want is that at this particular point, this is the only concept that you need to remember. This is the only concept that you need to remember. At this particular point, Vy can be 0. Vy can be 0. What I am trying to say is, if final velocity, if the vertical velocity becomes 0 before this point, then the packet will not reach on the other side. That's what the concept is. If this velocity becomes 0 before this hill, then the particle will not reach the other side. Are you getting it, what I am trying to say? Are you getting it? So it means that let's just find when this Vy will be 0. So Vy will be 0. We are going to write Vy square equals to Uy square plus 2Ay into H. Is that correct? Right? So Vy is 0. So I'm going to find Uy, right? So Uy will become under root of 2H by G. So this will become under root of 2 times of 500 divided by 10. That is, have we done everything correct? Quickly write down in the chat box. Have we done everything correct? They have told us to take G. Quickly write down in the chat box if everything we have done everything correct. Quick. Our Uy is coming out to be 100. Now what the problem is saying is that if, let's say, if Uy is greater than or equal to 100 meter per second, then in this case the particle will reach the other side. If Uy is greater than or equal to 100, then the particle will reach the other side. If it is not equals to 100, then it will not reach. Right? Got it? This is the minimum velocity. So this is the minimum velocity that we are looking for. Now please understand. We know that u is 125. We know what Uy is. Can you find Ux also? Obviously. So we know that u is written as under root of ux square plus uy square, right? So ux square will be written as u square minus uy square, that means square of 125 minus uy square, that is square of 10. Is that correct? Clear? Everything's clear? So ux, can you find out, can you please quickly write down in the comment section what ux are you getting it? Quickly write down in the comment section what ux are you getting? What is square of 125 minus 100? Quickly write down. I'll check what the, is it, sorry, it is 100. Square of this thing is going to be, this thing is going to be square of 100. Is everything correct? We have done everything correct. Let me check. This is actually 500. Yes, we have done it correct. 2gh, sorry, this is actually, this is, just a second. Come back. This was actually, we have done a silly mistake. This is 0, this is uy square, and we are going to write it as 2gh, right? So h will be, I think we have done everything correct. I think the options are not in the correct order. Quickly write down in the comment section if you have done everything correct. Aha, yes. This is going to be 2gh. This is going to be 2gh. That's what the problem was. This is going to be under root 2gh. So that means under root of 2 times of 10 times of 500. That means this is going to be 100 meter per second. So this is 100 meter per second. I have written that correctly over here. I have written wrong. Find out the value of ux according to this. This is going to be 75 meter per second. Now we have found out both the things. We have found out what our ux is and what our uy is. So we have found out what our uy is. Uy is coming out to be 75 meter per second, and we have found out our ux to be 100 meter per second. After solving this, can you share the question? I'll share it. Quickly write down. This is actually 100, square of 125. Quickly solve it. Is it coming out to be 75? Write down in the comment section. Quick. See what I've done. I've done a silly mistake initially. This is vy should be 0. This is uy square minus 2gh, right dosto? So uy square is going to be equals to 2gh. So that means uy will be actually equals to under root of 2gh. So this is the minimum velocity, right? If velocity is greater than this velocity, then it will go back. It will go from top, right? If the velocity is less than this, then the particle will strike the hill. Are you getting it? Everything's clear? Quickly write down in the comment section if everything's clear. We have found out uy, we have found out, I think we have found out everything. So now the time taken by the particle to reach the hill, will be actually 2h by g. That is 2 times of height is actually 500 divided by g. This is actually time of flight, and this is going to be 10 seconds. So 10 seconds is taken by the particle to reach here. So 10 seconds will be taken by the particle to reach at this point also. That is the equal distance. 10 seconds will be taken by the particle to reach here. 10 seconds will be taken by the particle to reach at this point. This is the same time that I used to calculate the time of flight. 10 seconds and 10 seconds. So till now we have got 20 seconds we have got. Now please understand. The thing is, this is ux. Ux was given as 100. So if ux is given as 100, that means in 100 times, I think we have almost solved it. The answer is going to be, it's going to be 20 seconds. I think we have almost find the shortest time they are telling us. So till now the time is, till now the total time that we have got over here is 20 seconds. Sorry, is 20 seconds. Comment me if you have any doubt till here. Then we'll move on. What else do we know? Quickly comment. The x velocity is actually not 10. The x velocity is actually 75. That's what wrong thing that we were doing over here. The x velocity is actually 75. So the direction in which x is going to move is, it's going to be, I'll write it over here. I'll have to use some space. So the distance in x is going to be ux times t. So that's going to be 75 times 10. So that is 750 meters. So this is 750 meters. This means that this distance, I'll remove this thing from here. This means that this distance should be 750 meters. Only then the particle will reach at this point, right? This is actually 750 meters. 10 seconds times ux is going to be this distance, correct? And double of this is going to be the range, right? So if I am going to multiply ux with 20 seconds, I will get range, but I don't want range. I want this distance. So this distance is ux times 10 seconds, that is 750. So what is going to be this distance? So this distance is going to be total, that is 800 meters minus 750, that is 50 meters. So 50 meters the cannon should move. This is what the total time. So total time 20 seconds, we have already got 20 seconds. So 20 seconds, I'll use the next slide. So 20 seconds was the time for the packet to fall, plus let's add the time taken by the cannon to move this 50 meters. So cannon is moving with speed of 2 meter per second, right? So if cannon is moving with 2 meter per second, then 50 divided by 2, that is 25 seconds it will take. So the total time will be actually 45 seconds. I'll again repeat it. It's a big question. But I'll explain each one. Ramya, don't worry, I'll explain each part. First of all, let's check it out. The question is saying that the cannon is at a 800 meter of a distance from the foot of the hill, and the hill is actually of 500 meter high. Then next information that they are giving is that the cannon can actually fire the packet at 125 meter per second. That's all we know. We don't know the angle, we don't know the horizontal velocity, we don't know the vertical velocity, and we also don't know the distance at which this cannon is being placed. Actually, we know that it is at 800 meter, but we can't use that 800 meter just right now. So what we have done is, first concept that we have done, that let's say that at this particular point final velocity becomes 0. So if at this particular point final velocity becomes 0, it will actually it will complete the parabolic path. It will fall back to the next, to the other side of the hill. So if Vy is 0, we solved it down, we found out that Uy should be actually 100 meter per second. Now please understand, we know U, we know Uy, we can find out what Ux is. So Ux is coming out to be 75 meter per second. So now we know all the three things. Alright, after this, what is the time taken by the particle if something is thrown with, if something is actually at 500 meter high, what is going to be the time to cover that? That's going to be around 10 seconds. So 10 seconds over here, 10 seconds over here, the total time is going to be 20 seconds. Right? Got it? So this is 20 seconds. Now, if this is 10 seconds, so what is going to be the distance between these 2 points? So 10 seconds times ux, ux was 75, 75 times 10 is 750. So this is 750. Means cannon should move 50 meters ahead. So 50 meters ahead means this is going to be 50 meters. So time taken by the cannon to cover this 50 meter is going to be 50 divided by speed, that is 2, that is 25 seconds will be taken by the cannon, then plus 10 seconds, final 45 seconds is going to be the answer, right? So D is the answer, final 45. Very good, very good, very good. Hopefully you are doing it by yourself. That's the most important point, right? Chalo, let's move to the next one. We have got an equation of projectile that is given by y equals to root 3x, y equals to root 3x minus gx square by 2. We have got an equation like this and you have to find out the angle of projection. You have to find out the angle of projection. You can find out by other methods also, that's not a problem, right? You can find out by using theta as well. This is the equation, you have to find out the angle of projection. 60 seconds is going to be more than sufficient. Let's solve it quickly, quick. So the only thing that we need to do over here is we need to compare this with our equation, that is x tan theta minus or x times one minus x by tan theta or x tan theta. Right? We have just derived it. If you remember, the equation of trajectory was something like this. Sorry, x tan theta minus x upon r, minus x upon r. So this is x tan theta minus x tan theta minus x upon r. So let's just compare this thing with this thing, right? So we are going to get, obviously you can see that this is the tan theta we have got over here, right? This is the tan theta. So theta is going to be tan inverse root 3, that is going to be 60 degree. You can also find out the range and all from this equation, right? This is the expanded form. That means this is written as x tan theta minus x square tan theta by r. So the correct answer is going to be option B. Good, 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 very good. Let's move to the next one. Question says a ball is projected upwards from the top of a tower with velocity 50 meter per second. This is what you are talking about, Madhusudan. This was what you are talking about, that 50 meter making an angle 30 degree with the horizontal. The height of the tower is 70 meter. After how many seconds from the instant throwing it will fall, the ball will reach the ground. Alright, you start it, you start this one. Then I will also explain this case. 60 seconds. Quickly. A ball is projected from the top of a tower at a speed of 50 meter per second. Everything is in SI units, so you don't have to worry about. We have got a tower which is actually 70 meter high and a projectile is being thrown. Let's say they have said that it is being thrown at an angle of 30 degree, right? So the particle will fall something like this, right? That's what we have been talking about, that if a projectile was thrown from ground to ground, we used to draw the projectile motion, and still it is going to be a projectile motion. Now how to find out the velocity in the quickest way? See, when the particle will fall down, what is the displacement travelled by the particle? when the particle will come back to this point, what is the displacement traveled in y direction? So displacement traveled in y direction is actually 70 meters, and to be precise it is minus 70 meters. Alright, it is minus 70 meters. So if it is minus 70 meter and we know that it was thrown with 50 meter per second of velocity, so this is going to be 50 sine 30, that is 25 meter per second. So initial velocity is actually 25 meter per second, and we have to find out the time in which it will actually fall down. So can I actually use Sy equals to Uy times t minus or plus half Ay into t square? Can I use this directly? I don't have to worry about anything else. Are you getting it? I don't have to do it like first I will find out the time taken by the particle to reach here, then this will be time of flight, then I will find this time. I don't have to do all of those things. The initial velocity of the particle is 50 meter per second, sorry, in the y direction the initial velocity is 25 meter per second, and then the displacement in the y direction is actually minus 70, that's it. So let me just apply it. So minus 70 equals to Uy, so Uy was 25 times t minus half times 10 times t square. So this is going to be 5. Is that correct? Is that correct, dosto? Here I have got minus as well, right? So now I am going to write it as 5 t square minus 25t and minus 70 equals to 0. What answer are you getting from this t? So this was actually 5. So this is 5, this is 5, and this is what? This is 13, 14, right? So I've got over here as 5t square minus t square minus 5t minus 14 equals to 0. That means I am going to get 7 and 2, right? So it's going to be plus 7 and minus 2, so it's going to be plus 7 seconds. Is that correct? Is that correct? C is correct or B is correct? C is correct or B is correct? Quickly write down in the chat box. Quick. Chalo, show some attendance. Quickly write down in the chat box. Is it C or is it B? It's obviously it's not B, I think it could be A or it could be C. And time is positive, so it's C. All right. Okay. So the correct answer is C then, right? C is the correct one. Why is that? Why most of you have opted for B? I think for those students who have opted for B, is your doubt clear now? Or whatever your mistake you have done, is it now cleared? So now we have completed one dimensional, we have completed two dimensional, right? So now before starting laws of motion, I can give you 10 minutes of break, right? After 10 minutes, all the students who are present in this class, are you going to be still present? I am going to start laws of motion. Till now we have completed kinematics. Laws of motion is going to be really important. Going to start from very basics, right? And we are going to cover that as well. All right. Madhusudan, we are going to only talk about the topics that are in NCERT right now. That's it. So we are covering almost everything. Other than that, we have covered in our batch, right? All right. So 10 minutes of break. All right. No issues. We are going to cover it, Kevin. We are going to cover each topic that's going to come tomorrow. So we are going to either ways we are going to cover the test syllabus. Ten minutes is the time. All right. वेलकम बैक, वेलकम बैक, वेलकम बैक, वेलकम बैक दोस्तों. आई एम बैक. Late by 1 second. Late by 1 second. All right. Okay. So let's start laws of motion with more energy with which we have started kinematics. Right? All right. Quickly write down in the chat box if you can see me. Quick, quick, quick. You can see me, but I can't see the chat. Just a second. All right, all right, all right, all right. Let's start. Let's start. So we are going to now talk about laws of motion. You know that it is very, very important chapter, right? In this chapter, we are going to talk about each and everything, right? Starting from free body diagram, from normal reaction, how to understand tension, the concepts regarding, let's say, pulley block system, mass block system, everything, right? All right. Yes, yes, yes. I'm okay. I'm okay. Just got a little. I'm all good. All good. All good. All good. No, 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 no. I didn't fall. I missed a step. All right, all right. Let's start. So let's start by defining what do you mean by force, right? Let's start by defining what do you really mean by force, how you are going to define it. So in the simplest of the terms, force can be defined as it is an effort in the form of push or pull, right, which may or may not have certain changes, which may or may not have certain changes. For example, as it may or may not change the state of the body, like for example, as if a body is at rest, it may or may not change the state of the body, it may change the shape or size of the body, right. So what are the different effects of force? So it might change the state of motion, it might change the direction of a body, direction of motion, then it may change the shape or size of a body, right. Got it? Now after this, if you are going to actually if you are going to read NCERT and all, there are certain things that's written in NCERT. They have started the NCERT with defining what force can be, then they have talked about a fallacy that is associated with Aristotle or Aristotle's fallacy, right, and many students actually still believe in that fallacy. That's the main point, that you must actually, first of all, you must understand that if we are really talking about a body that is moving with constant velocity, and this thing is constant, then we can say that there is no need of force, there is no need of external force for this body to keep moving. Till now we will just leave this to that. We are going to leave this topic till here only. We are going to talk about this in detail when we are going to discuss Newton's second law. Till that we are not going to talk about that what is force, force is mass times acceleration, we are going to come to that. But if you are going to read NCERT, you are going to come across the first topic, that is Aristotle's fallacy. Right. After that, if we are able to understand what do we really mean by force, we are going to actually categorize force in basically four categories, and those are known as the fundamental forces. These are known as fundamental forces. Now, any force that you have ever seen, or you have ever read, or you have ever discussed, you have solved a problem regarding that force comes under these four fundamental forces, right? And these four fundamental forces are, I am going to write in order of their strength. These are strong nuclear force, then we have got weak nuclear force, then we have got gravity, then we have got electromagnetic force, and the last one, and with the least strength, we have got gravitational force. Alright, and out of all of these ones, we are going to majorly discuss electromagnetic force. So this is very, very important. Yes, dosto, I am all good, I just got tripped, I am all good. So everything's fine. Let's start. We have started Newton laws of motion, and this is again going to be very, very important. I will have some notes for you, some very important notes. Keep those in mind, right? Got it? So what I have said, that out of strong nuclear force, weak nuclear force, electromagnetic force and gravitational force, we are going to mostly talk about the electromagnetic force. For example, whenever we talk about like normal reaction, we talk about tension, right? We talk about friction. All of these kinds of force come under this category. So first of all, before starting anything, before talking about tension, before talking about friction, before talking about normal reaction, first of all try to understand in which category does this force lies in, right? So all of these forces lies in electromagnetic force. Got it? Everything's clear? Can we start? Now we are going to start with rather than just talking about the Newton's laws of motion. First let's build our basics. Let's start with the normal reaction so that I can teach you how to draw free body diagrams. Tell me in the chat box how many of you really want to know how to draw a free body diagram, how to draw normal reactions, how to draw components of it, because these are the basic things that we are going to talk about now, right? So starting with this, let's talk about the normal reaction. Now the definition of the normal reaction, we are going to get to it when we'll complete the friction. But for now, I am going to define the normal force as it is the component of contact force. So this is the most important thing. See, the main part is actually you don't get the what we can say, the fundamental forces. There is nothing to get about fundamental forces, buddy. We are going to talk about individual fundamental forces in individual sections. Like for example, a strong nuclear force will be dealt in your what we can say in nuclear physics. We are never going to talk about weak nuclear force. Electromagnetic force, we are going to talk about like whole of class 12th is filled with electromagnetic forces, right? Gravitational force, this is part of I mean your course, you are going to talk about gravitational force. So there is nothing to not understand about the fundamental forces. It's just that you need to know that in this whole universe, as of now, like I mean we are just talking about, I'm not talking about like some dark theory or dark matter or whatsoever. I'm just saying that as of now, up to our level of understanding, there are 4 fundamental forces. So whichever force that you have ever heard about will fall under any one of them. So for us, like normal force falls under electromagnetic force, right? Why? Because it is the force between the intermolecular particles of 2 surfaces. Are you getting it? Now let's come back to the normal reaction. See, the important definition was that it is the component of the contact force perpendicular to the surface, right? What else? It measures how strongly. So this is where the students actually face the most trouble, and this is the reason that they don't really understand the definition. They really don't give much attention to the definitions of these things. This is basically, it means how strongly the surfaces surfaces in contact are pressed against each other. I will give you an example. Let's suppose I've got a diagram. I'll tell you some of the basic diagrams. Let's start with the basic things. We have got a block whose mass is m. Alright, and I'll take your doubt, so don't worry. Stay connected. I'll take your doubt. It has got mass m. We are going to say, sir, we know at least right now also we know this much, that acceleration, because of acceleration due to because of gravity, the earth pulls this block down with a force of mg. Everybody knows na this much. So this is the pressing force. This is the force with which these 2 surfaces are being pressed. I mean this body is being this surface is being pressed by the block of mass m, right? So I am going to draw the normal reaction, and this normal reaction is going to be the perpendicular to this contact surface. Are you getting it, right? What contact surface I am talking about? This is the contact surface and perpendicular to this. So that means normal reaction right now will be drawn something like this. And because this block is not moving in any direction, of course in y direction, there is no force in x direction, that is why the normal reaction is equals to mg, but it is not necessary. Alright, are you getting it? Quickly write down in the chat box if you have got it what I have said. That first of all, normal reaction is a component of contact force. So right now the contact force is just this mg. That is all the contact force is acting over here is just mg. Are you getting it? When we are going to talk about friction, we'll discuss it with more detail, that what do you really mean by that it is a component, right? So now next thing is, if let's suppose I'll say to you that we have got 2 blocks kept like this. I have got 2 blocks. This is block A, this is block B. Alright, everything got it? Very good, very good. Now to answer my question, how many surfaces are there? How many surfaces are there which are in contact with each other? So there are actually 3 surfaces. One is this one. I mean I'm just drawing the force, but the surface that I'm talking about is this one. These 2 pair of surfaces are in contact with each other. So I'm talking about these 2 pair as one, right? These 2 pair of surfaces are in contact with each other. So I'm going to also write, I mean let me just write mg, although there is nothing related with surface and this thing. So this is mag, this is mbg, right? So there is going to be a normal reaction something like this, that is Na, whose value right now is going to be mag, and there is going to be a normal reaction something like this, that is going to be Nb, that is going to be Mb by G. If you are going to ask me, let me just write it for all of you. I am going to just say that this, by the way dosto, that this normal reaction is actually applied by surface on block, right? Shall I also draw the normal reaction on this surface between this one? If you can please see between this one, quickly write down in the comment section if I can actually. Shall I also draw the normal reaction, like B will give normal reaction to A in this direction and A will give normal reaction to B in this direction? Can I write it like this? No, they are not action reaction pair. They are not action reaction pair. This is the another doubt, that it's not a doubt, it's a misconception, right? They are not action reaction pair. Quickly tell me. Shall I draw a normal reaction between these two surfaces also? No. Why? What's the reason? There is no normal reaction because there is no pressing, right? There is going to be no normal reaction between A and B because there is no pressing. This thing is very, very important. This point is very important, that if the blocks are not pressing each other, there is no need for normal reaction to come, right? Alright, I will not use pink color, alright, okay. Are you getting it? But if I will just draw a force something like this, let's suppose I draw a normal, I draw external force like this. This is an external force. Then what I can say is, after this, if you are going to talk about the free body diagram of just A, the free body diagram of the block A will be drawn something like this. For A, there is mg force acting downwards, that is mag. There is a normal reaction acting upwards, that is Na, and there is going to be a normal reaction acting in this direction, which is applied by the B particle. So I will write it as N dash. Now it will come into existence. Are you getting it? Right? And why it is in this direction? Because A is pushing B in this direction, so B will apply normal reaction in opposite direction. And if I am going to talk about B, so for B, I am going to say that there is a normal reaction acting in this direction, so this is actually N dash. There is a normal reaction in this direction, this is NB, and whatever the value of this is actually MBG, and there is a MBG acting downwards. This is something really important for you to understand. Got it? Now hear me out carefully. Well, we haven't discussed Newton's third law right now, but what I can say is that you must know about action reaction pair. Action reaction, every force in the world, every force exists in pairs only. So it's nothing like you are talking about these two, although these two are not action reaction pair, but every force are in action reaction pair, they exist in action reaction pair, right? I will explain it to you. I will explain the doubt. I will explain what do you mean by action reaction pair. See, this is earth, this is the center of the earth, here is that mass of body M is kept, mg is acting downwards. Let's say this is the gravitational force that we are talking about. Let's not write it as mg, it will create confusion. What about F? Sorry Jhansi, and thank you so much. F is also going to be here. What about FC? She has got a good eye. Everybody be very, very attentive. Very good, Jhansi. Let's say that this is earth, this is the force of gravity, this is what Ng is, right? The earth pulls the block with a force F, the block pulls the earth with the force F. These are action reaction pairs. They act on different bodies, they act in different directions. They are of same magnitude. Are you getting it? Right? Are you following what I am trying to say? Whereas this normal reaction, this acts on the body, right? this mg, it's also acts on the body. So how come they are the action reaction pair? Everything's clear? Can we move ahead? Your doubt is cleared now? Oops, something is happening. Just a second. All right. So let's move to this question. Quick. Clear till now? Everything's clear? Two blocks are kept in contact as shown. All right. So you have got two blocks, and if I'll draw the free body diagrams of these ones, find the force exerted by the surfaces, right? So let me draw for this 10 kg block. So for this 10 kg, I have got a force acting on this direction, that is of 100 Newton. I have got a force acting over here, that is the normal reaction. I have got weight acting over here, and I have got normal reaction acting over here. So this is normal reaction, this is actually equals to 100 Newton. This is mg, this is actually equals to 100 Newton, this is mg. This is the normal reaction that we are talking about, and let's say this is n dash, and this is the 100 Newton that we are talking about, right? Right now I am not going to talk about forces which are equal. I am not going to talk about equilibrium. We will discuss it, but not right now. Then let's talk about this 20 kg block. On this 20 kg block, now please don't feel uncomfortable with this angle and all of these things, right? Please don't. I mean, this is very easy. This is so easy that basically what they are trying to say is that, let's suppose this is the vertical axis, and the force is acting something like this, and what they have done is they have actually given you the angle of this. They have given you the angle something like this. See, that's what I have said, that I am going to explain everything from the basic. This is the 30 degree that they are talking about, na? This is the 30 degree. So that means this is also going to be 30 degree, right? Is that correct? Clear? This is also going to be 30 degree. So if this is going to be 30 degree, this is 30. So this is going to be what is this, 50? So this is going to be 50 cos 30, and this is going to be, I mean, on the block, this is on the block, right? So on the block we are going to have a force acting on this direction, which is going to be 50 sin 30. Quickly write down in the chat box if you are getting it what I am trying to say. F external is 200, all right. F external is 100. Why are you saying it is 200? F external is 100, right? Everything's clear with this one? Quickly write down in the chat box. Got it? Now let me rewrite it, because now you have got it, na? So let me rewrite it. So how I am going to rewrite it? I am going to actually, this force was acting on the block, na? So I am going to draw the two components. I am going to say that, okay, so there is mg acting over here, there is mg acting over here, plus there is also 50 cos 30 also acting over here, right? Got it? There's a 50 sin 30 acting over here. I mean, the force will not act on air. Are you getting it? I just showed that to you so that you can easily understand the component thing, right? 50 sin 30 acting over here. There is a normal reaction acting over here, applied by the ground on the block. Let me write it as, this is NA, this is NB. And now I am going to say a very simple thing, not moving too fast. I am going to say, you tell me, dosto, is this block going up or down? No, right? So whatever this force is, this is going to be the normal reaction, right? So this is going to be mg plus 50 cos 30. This is something that we'll again do it when we are going to talk about the equilibrium kind of thing, but still you can get it. And understand something like this. See, this is the normal reaction which you get from a weighing machine. When you stand on a weighing machine, your weighing machine actually tells you the value of the normal reaction. Are you getting it? Converting into mass. I am not going to go into that, but right now it measures your weight. it measures your apparent weight. So that the reason it measures your apparent weight is that it measures the normal reaction. So if you are standing on a weighing machine, and let's suppose that you are just showing off to your friend that your weight is just like the most appropriate weight for you, and then he puts a hand on your shoulder and he tries to push you down. Just assume this. You are standing on a weigh scale and you are out of mischievousness, your friend puts a hand on your shoulder and it tries to push you down, something like this. Is weighing machine going to tell you more weight or less weight? You tell me. Answer me. Is the weighing machine going to tell you the apparent weight will be more than your actual weight, or will it be less? It will be more, right? It will be more. And here's the ad. So that is why it is more. Are you getting it? That's how it is happening. And now there is going to be just one more thing. This is the normal reaction that we are going to talk about. This is the N dash. Good. Let's not use the terms that layman use. Let's not use the term pressure. Right? We use pressure in our day-to-day life like anything. Right? So let's not do that. It's not pressure, it's a force. Yes, pressure can be calculated. Yes, pressure has been exerted. But we are not, right now, we are not concerned with pressure. Pressure has got no direction for us. Pressure is a scalar, at least for us it is a scalar quantity. So it's a force, not pressure, right? So I've done it. I've marked all the forces. I'm not writing the equilibrium conditions. I'm not doing it. We'll do it afterwards. Let's quickly move, dosto. I've got one more question for you. Something like this. Let's suppose that a rod is being kept on the ground like this, and on a ground and on something like this. So a force perpendicular to the surface, right? And a force perpendicular to the surface. So perpendicular to the surface is something like this. Got it? That's it. Right? Can we move to the next one? The basics of normal reaction has been covered. That's what I promised you. The basics of the normal reaction has been covered. Let's complete the basics of the tension. That's why I said this class is not just for an 11th grader or a 12th grader or for somebody who's opting for mains or who's opting for NEET. This is for anyone, because I'm just clearing your basic concepts, right? Got it? And then we are going to also talk about derivations and everything. Now, when we are going to talk about tension, first of all, normal reaction was also an electromagnetic force. Tension is also an electromagnetic force, right? So keep this thing in mind. Tension is also an electromagnetic force. It's an electromagnetic force. It arises when the string is pulled. If a massless string is not pulled, tension it is 0. Finally, we are getting into tomorrow's test prep portion. Absolutely, Kevin. That's why I said stay connected, and I'm going to give you a good revision of tomorrow's test. By the way, if anyone who's not from, well, there are many who are not from Yakin batch. Tomorrow we have got a test. That's what they are talking about. Now let's come back. Let's suppose that we have got a string. Now string or a rope, something like this, right? Something like this. First of all, the rope that usually 95% of the time that we are going to use in physics is going to be massless and inextensible. What do you mean by massless? Obviously, you know what do you mean by massless? That we are going to assume that its mass is so less that we are not going to take that into our account of calculations and whatever we are going to do with masses, right? What do you mean by inextensible? Obviously, we are applying force on it. The length of the string is not going to be changed, right? So there is no potential energy in it. There is no mass in it. There is going to be no kinetic energy in it. We are not going to apply any work energy theorem, anything into a mass, anything for a rope. If rope has got mass, then what will happen? That we are going to talk about it, right? Let's first go step by step. Let's suppose for now we have actually attached this rope at this particular point. So this we have got a support, we have got a, like, let's suppose this is a ceiling or a roof, we have attached a rope into it, right? Got it? And so this end is attached, this end, on this end we are applying a force. On this end we are applying a force, and I am saying that this is an external force. Now this is a new type of a question, going to answer each and everything. First question can come, what do you mean by external force? External force means that whenever we are going to talk about a situation, first of all we are going to talk about our system. In this question the system is, you can consider the system to be this roof, you can consider the system to be this rope, this is the system. Anything outside of this system is going to be considered as external to the system or outside to the system. So this external force is something which is outside of the system. It could be anything, it could be me. If I am pulling this, then the origin of this external force is a muscular force. By the way, muscular force is itself, it is an example of electromagnetic force. If you are not going to actually really understand what type of a force it is going to be an electromagnetic force. Got it? Right? So now the thing is that this is an external force. I have explained what external force is. Just think about the particle above it. I can't really, of course I can't draw it, but just assume that there is one particle on which the force is acting and there is one particle that is just above it, and that above particle is actually trying to pull this particle in upward direction, right? This force is trying to pull this particle downwards, and if this force is like really huge, really above the tensile strength of that rope, then the rope will break. But we are not going to talk about all of those things. We are not concerned with the property of this material, we are just concerned with the what forces are acting on it. So for us this string is not going to break any time. In Newton's laws of motion we are never going to break our string. It sounds really good, huh? Never break strings, right? So we are never going to break string. So for that this particle will actually apply a force in the opposite direction, and that is electromagnetic in nature, and that is what is called as tension. That is what is called as tension. Now you might have heard, you might have actually observed this, that we mark tension in a way, and some of students have a doubt about this. Now I'll explain it. Let's suppose I'm actually removing this external force, and also now what I am trying to do is I am applying a block over here so that you can have an idea. So this is a mass M and this is mg. This is force mg. Sorry, yes, I have to be in Josh now to teach you all. Now sorry, let me take a sip. See, the thing with tension is the direction of tension is going to be in such a way that it will try to reduce the length of the string. It will try to reduce the length of the string. And how you are going to do it? I will give you a shortest trick. Wherever you are going to see a point of contact, the direction of tension is such that it is opposite to point of contact. It is opposite to point of contact. What do you mean by point of contact? I will tell you. This is a point of contact, dosto. Point of contact means when you have got a string, it is attached with another thing, that point is the point of contact. This thing is the point of contact. Got it? So the tension over here is going to be drawn something like this. That's why you see arrows drawn like this. And then this is also a point of contact, na? So the tension at this point will be drawn something like this. So that's why you see arrows like this. Are you getting it? Is everything good for now? Because this is very important to draw that free body diagram. Now understand one thing, that this is the point which is connected to the block. So if you are going to talk about the free body diagram of this block, so you are going to say, sir, mg is acting downward, tension is acting over here. That's it, that's the free body diagram. If you are going to talk about what is this force, the tension T will act So one more thing, because it is massless and it is inextensible, we are going to say that tension will remain same. Tension will remain same throughout a same rope. Obviously, we are going to talk about a same rope. So you have got like this is one single rope. Tension is going to be same all over the place, right? Point of contact and suspension point, same thing, Satakshi, same thing dear, right? All right. Let's move ahead. Let's see what points do we have got over here so that you can write something. Tension always acts along the string and in such a direction that it tries to reduce the length of the string, right? I mean, if you tell me if tension at this particular point was acting in downward direction, so is it reducing the it is trying to reduce the length of the string, or it is trying to increase the length of the string? You tell me. It is trying to increase the length of the string now. So in all over the books you are going to see this point, but the trick is this, that this is the trick, that direction of tension is opposite to the direction of point of contact. That's so easy, right? And the concept behind is this, and what is the another concept which supports this thing, that it's an electromagnetic force. It is the force between the two particles that they want to be together, right? If the string is massless, then the tension will be same along the string, but if the string has got some mass, then the tension will continuously change along the string. All right, we know that. Done, everything's clear. Now let me tell you how to draw free body diagrams for some of the block systems, right? Free body diagram for some of the block systems. Let's suppose that we have got two blocks kept over here. Obviously we can draw more than two blocks, but let's understand for two, and I think then you will have a pretty good idea. And again, I am not going to talk about what is acceleration, what is that, I am not going to talk about all of those things. I'll just, string having mass based question will come, well, in your school exam it will not come. In NEET might come, it might come. It's not something, and by the way, it is also not that difficult. A little bit of integration will help you, right? So right now again my purpose is to explain how to draw free body diagram. Other than that, everything is very easy. So let's say we have got mass m1 over here, we have got mass m2 over here, and the external force is acting on this block, that is F. Right? So find the tension tension will not act on M1, tension will act along rope, but how you are going to draw it? So tension will be drawn something like this. On this, tension will be drawn something like this. So if you are going to talk about the free body diagram of just M1, so on just M1 there are these forces. F is acting in this direction, there is tension acting in this direction, there is M1G acting in this direction, there is normal reaction acting in this direction. And why is that? Point of contact opposite to point of contact, point of contact opposite to point of contact. Alright. So for M2, tension, normal, that's M2G, and this is M2G. For anyone who really wants, sir, please write the equations also just for once. So I am going to just write it for once. If now everything's simple. Let's suppose the whole system is moving in this direction with acceleration A. So F minus T is the net force that we are looking for. F minus T, and why F I have written it over here? Because it is a greater force. How do I know that? Because the system is moving with acceleration in this direction. This is what I have given, right? So this will be equals to the mass of the body times the acceleration of the body. So that's how you write it. If anyone wants more clarity on this, wait for some time, we are coming to it, right? Good. Quickly write down in the chat box, dosto. I also need some motivation. Is this all going into your head or what? Quickly. Then we have got like pulley block system. So now after your concepts are clear, now I mean no matter how complex a problem is, you can able to draw the free body diagrams very easily, right? Now before moving to the pulley block system, so let's suppose that we have got a pulley block something like this. I'll explain what a pulley block system means. By the way, again, this pulley is again going to be it's again going to be massless, right? So there is no mass in the pulley, it is frictionless. So we have got rope attached over here, we have got rope attached over here, we have got two blocks kept something like this, we have got a block kept like this. So let's say this is block M1, this is block M2. Now there is tension acting over here, sorry, there is M1G acting over here, there is M2G acting over here, also no doubt about it, M1G, M2G. At this point tension will act in this direction, at this point tension will act in this direction, at this point, are you getting it? What is this point? This is the point of contact of a pulley and the pulley and the what? Pulley and the rope, right? So the for all of those students who have just joined, we are just clearing the main topics of NCERT, right? Whatever is in NCERT, we are covering those main topics, dear, right? As in that way, we have got lots of many things. We have got like river board problems. We have got many more things. I'll come up with each thing. So I'll going to have a videos on each particular topic. But today's class, the motive of today's class is to clear the basic things that's given in NCERT as of now, right? I'll come up with the new things. If you have got any such request, please, I always tell you, write down your request on the comment section of my video so that I can get to know what topics you guys need, right? I'll get back to those topics as well. All right. Today's, that's why what you can read in the on the title, that it is a midterm marathon. All right. Coming back to it. So this is a point of contact between the pulley and the rope. So how you're going to draw the tension over here? You're going to draw it something like this. Over here you're going to draw it something like this. So don't worry about it, right? It's not like these tensions are cancelling out each other. Don't have doubts like this. After this, although again I have not discussed Newton's second law, but before moving on, I'll have to actually explain this thing, that external force can be written as the net force, sorry, not external force, the net force can be written as mass of a body and the acceleration with which it is moving or anything, right? So net force can be written as mass times acceleration. We'll get back to it, I'll derive it, don't worry. For now, let's just assume that that's the case, right? And now also assume that this system is moving with an acceleration of A downwards. So A is acceleration downwards. On the same, if now please understand, if this block is going with an A acceleration downward, this block will move with A acceleration upwards. If you are going to ask me, sir, is it really necessary that they will have a same acceleration? Yes, they will have same acceleration, they will have same velocity. The reason is that if they don't have same velocity, what you really want to say is that two of the particles of the string are actually moving with different velocity, and that is only possible when the string has actually either it has break or there is a potential energy between the particles. That's how the spring works. Now, for a spring, a particle is moving over here, this particle is at rest. That's not possible for our rope. So we are going to say that if this block is moving down with A acceleration, this is going to move up with an A acceleration. You can ask me, how do you know that this is moving down A? Obviously I have assumed it, right? Obviously I have assumed it. Now I am going to write the free body diagram and I am going to write the equations for you. Let's look for M1. Let's look for M1. On M1, how many forces are acting? There are just two forces acting. One is M1G, one is tension. In which direction M1 is going? In downward direction, that is A is acting downwards. So that means this is the force which has got greater in magnitude, right? So that means I am going to write M1G minus tension equals to, so this is the net force, equals to M1 times A. Do I look tired? Sir, are you tired? Do I look tired? Well, I am not. For M2, I am going to write T minus T minus m2g equals to m2 into A. Alright. After this, let's just add them. If you are going to add them, we are going to get, so this is equation 1, this is equation 2. Let's add them. So we are going to get m1g minus m2g equals to m1a plus m2a. So acceleration will be written as m1g minus m2g divided by m1 plus m2. So this is the acceleration. That this is the most basic formula for this chapter, for this topic, nothing to really worry about, and I am going to also tell you a trick for it, right. After this, just put it in the value of tension and find the tension. So I am going to leave this for you. Find out the value of tension. It's quite easy, by the way, nothing to worry about. Look here. Are you all really watching this? Show some presence on chat box quickly. Show some presence, dosto. Quickly. The trick is that what we can do is we can write, this is the net acceleration. Na? Net acceleration can be written as net force divided by total mass. Net force divided by total mass, right? Got it, got it, got it. So net force, what is net force? Net force is actually m1g acting in this direction, m2g is acting in this direction. Are you getting it? I have said that m1g is greater. So the net force is going to be m1g minus m2g divided by total mass, that is m1 plus m2. So you really don't have to worry about these equations. In exam, if it comes, you can use the equations. If you want to write A net directly, you can also write A net directly, right? All right, dosto. Yes, 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 I can see. Good, 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 good. Great. Moving on to Newton's first law. Newton's first law says that a body will remain at state of rest unless and until an external force has been applied on it, right? So that's what it says. Every body continues its state of rest or uniform motion in a straight line unless compelled by an external force to change its state. And from this, we actually we defined the property of inertia, and we said that inertia is basically a property of mass. So more a body has got mass, more inertia it will have, and more inertia it will have, it means that it is more difficult to change, or we should say that the body will offer more resistance for any change in its state of motion or any change in its direction of motion, right? It will offer more resistance. Got it? That's what Newton's first law of motion is all about. That's what I have written over here as well. Larger the inertia of a body, more will be its mass. Mass of body is quantitative or numerical measure of a body's inertia. Everything's clear? You don't have any doubt? Good, good, good. Everything's clear? Newton's first law is actually quite easy to understand. Now see some important points. Whenever something like this comes, na, you should look with all of your senses towards the board, because I always keep these points such that there's going to be like, these are going to be really important for your exams. The first point says Newton's laws of motion. As of now, we have just talked about one law. Newton's laws of motion are only valid, very important point, it is only valid in a set of frame of references. These frame of references are known as inertial frames. These frames of references are known as inertial frame of references. What do you mean by inertial frame of references? Inertial frame of references are those who have net acceleration 0, who are not accelerating. That's what the inertial frame means. Very easy thing, dosto, very easy. If you're going to get to this thing, those centripetal, centrifugal, pseudo force, everything will be cleared, right? The reason that I'm just giving you a what do you call it as, what comes after teaser, and that I am giving you a little sneak peek from future chapters, from this chapter also. We use pseudo force so that we can apply Newton's laws of motion in a non-inertial frame. Are you getting it? We use actually pseudo force just so that if we don't have an inertial frame and we want to apply Newton's laws of motion, we actually use pseudo forces. Alright, got it? Generally we take earth, the second point basically says that generally we take earth as an inertial frame, but in reality it is a non-inertial frame, because obviously in universe everything is moving with like with a large acceleration and revolving around sun and revolving around its own axis, right? So obviously it is under acceleration, but it is so large that we consider it as a inertial frame. All frames moving uniformly with respect to an inertial frame are themselves inertial. Very easy thing, nothing, this point is very easy. If we have got an inertial frame and another frame is actually moving uniformly with respect to this thing, right? So this thing is also an inertial frame. In short, if a frame of reference is moving with constant velocity, we have got no problem with that, right? If a frame of reference is moving with non-uniform velocity, then we have got a problem. Then we are going to call that as non-inertial frame, right? Got it? Everything's clear? All right. Just a second. So after this we have got momentum. Momentum is quite easy, right? Sir, please take this type of marathon at least once a month. Okay, sure, we will do it. No, I'll definitely will do it. That's what I was saying, that write down your queries, write down everything that you have got, you have any request in the comment section. Momentum is a vector quantity. It is the product of mass and velocity, right? A very important thing. It's a vector quantity. Its SI unit is going to be kg meter per second square. If you want me to write its dimensional formula, the dimensional formula is going to be m to the power 1, L to the power of 1, T to the power of minus 1, right? Meter per second square. I've written it is just meter per second. All right, done. So what is the direction of momentum? Direction of momentum is just same as direction of velocity. That's it, right? We don't have to worry about this any more. After it, then comes Newton's second law, which I was telling you that we are going to actually first understand Newton's second law, then we are going to talk about all the other free body diagrams. Newton's second law of motion says that well, sorry, this is just the momentum. I'll write what Newton's second law says, right? So Newton's second law of motion says that the external force acting on a body, the net external force acting on a body, is actually directly proportional to the rate of change in linear momentum. The rate of change in linear momentum, right? That's what the Newton's second law of motion says, and to be precise, I can just write it as dp by dt. After this, if you are going to just quickly solve this one, this is actually nothing but this is m dp by dt. And by the way, here's a little catch. So this is not for school. That's what I was saying, that from here actually two types of things can happen. From here, one scenario is this, where mass is constant. This is actually something really important. So usually what we do is we only talk about this thing. So this is when mass is constant, and you are going to say me, sir, mass is always constant. When is mass not constant? So there is some cases when mass is not constant, like for example is rocket propulsion, right? So in case of rocket propulsion, mass is actually not constant, and for that a small thing we actually write something like this. Well, P is actually mass times velocity. So we are differentiating product of mass and velocity. So if mass is constant, mass has come out. So it is V. Have you written it as V? Are you guys are sleeping or what? Tell me, dosto. This is V. This is V. Sir, please explain the conservation of momentum. I'll definitely explain conservation of momentum. That's why I am here. Surely I'll explain it. But you first tell me, is that all good? It is dV by dt, right? All right. Now after this, I'm saying that let's suppose I'm writing it again and I'm writing it as net force equals to, now I'm saying that mass is not constant. I'm saying mass is not constant. So if mass is not constant, I am saying velocity is constant, so it will be written as dm by dt, v dm by dt. So this is the case for all the rockets and all in which the mass is actually changing, right? Cases like rockets. Done. Good. So here V is constant. Like for example, as usually the question comes, I'll also explain the question. It's very easy. Question says that, please sir, please explain the inclined plane also. Bilkul ji. Whether it will be like 12 or 1 AM, I'll not go. I'll explain each and everything. You don't worry about it. See, the problem comes something like this. We have got a rocket and the rocket is burning the fuel at a rate of 10 kg per second. So that's how you get to know that they are talking about dm by dt. This, it will have a unit of kg per second. Is that correct? The rocket is burning fuel at a rate of 10 kg per second and velocity of the rocket is like, let's say 500 km per hour, a constant velocity, or let's say 50 meter per second. Got it? Done. So 50 meter per second times 10, that is what the net force acting on the rocket will be. Are you getting it, dosto? Everything's clear? If velocity is constant. If velocity is not constant, then you will have to also apply the upthrust. But hang on, we are not talking about all of those things. Mostly the questions is going to come from here. Alright, everything's okay? Done? Okay sir, end the class whenever you want. Sir, why are you not with your jacket today? Because I got my t-shirt back. Chalo. So after this thing can be written as acceleration, you know it, and this proportionality sign is actually, it is considered to be 1. What's the reason behind it? There is no reason. It's we had the feasibility to choose any constant. We choose it to be 1 because of simplicity, right? So this is what we were looking for, F net equals to ma, and this is what the rocket case is. And there is one more case, but I'm not going to do it because that's not in your course. Okay, any which way I'll do it. So this is actually something like F equals to, if both are not constant, so that will be m times dv by dt plus v times dm by dt. So this is the third case in which both are not constant, right? Nothing to worry about. You're not going to have cases from this. From this also I have already explained what type of rocket questions come, so that is very easy. You are going to just talk about this case 90% of the time. Now let's move ahead. Alright, what important point we have got over here? Force can't change the momentum along the, now see, this is an important point. I have not talked about this point before now, right? Risha, which way to use it? This one? Use it where, dear? Where mass is also not constant and velocity is also not constant. Force cannot change a momentum along a direction normal to it, that is the component of velocity normal to the force doesn't change. It's a very simple thing. You are going to come across it quite often. It basically means that, let's suppose that we have got a body and please remember it, we have got a body like this and it is moving in this direction. So if it is moving in this direction, it means that it has got velocity in this direction, right? And it has got velocity, it has got also velocity in this direction also. So this is Vx This is Vy. And let's suppose on this body there is an external force acting on it, which is acting in this direction. This is the net force. Right? Got it? So if this is the net force, let's say it is F. Let me just write it as F. This is the force F, right? So this force is only going to change the momentum. It has got also mass. So it has got momentum in two directions. The net momentum will be written as, momentum along x-axis plus momentum along y-axis. So momentum along x-axis is written as m times Vx I cap. This thing is written as m times Vy j cap. Everything's clear? What the point is trying to say is that this force will not change this Vx. So this will remain unchanged. This will remain unchanged. And it makes complete sense. It makes complete sense. Do you remember motion under two-dimensional motion, ground to ground or any type of two-dimensional motion? Acceleration due to gravity was acting downwards and there was a velocity which was perpendicular to it, which we called the horizontal component of velocity. Did it change? No. That's the reason, and it makes complete sense. It's not something that you might be hearing it for the first time, or it's not a big surprise for you, but you are going to use it quite often. So remember it, right? You will have to give a little bit of efforts to remember these kinds of points. You are going to use this in your in some of the questions, right? It is very important when we are going to talk about collision and all. So now, and also again when we are going to talk about like circular motion, again in circular motion, we know that centripetal force acts towards the center. This is the centripetal force, and velocity is in this direction, right? So this centripetal force never changes the magnitude of this thing. Are you getting it? Done. Chalo, let's move ahead. After this, Newton's second law is strictly applicable to a single point particle. That means we are actually talking about the particles that we are right now talking about are single point particle. You know what single point particles means? That we are talking about a point mass m. Whatever the block we draw it, we just say that there is a point mass m kept over here, right? In case of rigid bodies or system of particles, what will happen if you have got a rigid body or system of particles? We will consider their center of mass. That's what I just said. If you have got a block, we just consider that it is mass m, mass m at the center of mass of that particular body, right? That's what written in this entire point. The internal forces, if any, in the system are not to be included in F. What do they mean? The internal forces do not change the momentum of the system. The internal forces are not going to, what are they going to do? We are not going to consider the internal forces when we are talking about the external forces, right? It's not, it is going to change the momentum. That's a wrong statement. I'll give you an example. Let's suppose that we have got two charges which are actually, let's say, both are positive charges, right? The net force on this system is 0, right? This is actually conservation. This is part of the conservation of momentum, but just because I said a line, I'll explain it to you. These two are electrostatic force. For now, even if you don't know what electrostatic force are, you know that like charges repel each other. This much everyone knows, right? So on this system, the net force is actually 0. But still, if you are going to actually leave them, they will move, right? But what I was trying to say is that the net momentum will be 0. Their individual momentum can change. This is actually part of conservation of momentum. This we are going to do it in work per energy. But are you able to understand it right now? what I said, the net, these are two internal forces and it is 0 in this particular case on the system, right. The net momentum is also going to be 0. Are you getting it, right? But for the individual particles, it can change. Individual particles are moving, right? Are you getting it? So now I think, what point do we have over here? Acceleration of a particle at any instant and a particular location is determined by the net force acting on the particle at the same instant at the same location, and it is not in any way depending on the history of the motion of the particle. Easy thing. It means that if you have got a body, it has got mass and on it net force is acting, it depends only on these two things. Where the particle has come from, what type of motion it had or what type of motion it has got, it does not depend on it, right. It just depends on two things, that is net force and the acceleration, mass and acceleration. After this, Newton's third law. Newton's third law is, now see, I am not moving fast. Where we were supposed to go really slow, we did. That was the time when we were talking about the free body diagrams, tension, normal. Now these things are theoretical and I think you can understand it. Like for example, as Newton's third law of motion, now we are talking about Newton's third law of motion, that every action, as in every action there is an always equal and opposite reaction, and these two action and reaction pair acts on different bodies, act in different opposite direction and equal in magnitude. So it's just not about this statement, although it comprises everything, equal and opposite, right. By the way, there is one very important thing. There is no cause effect relation. What do you mean by cause effect? It's not like one body has applied a force, then afterwards because of this force this body has applied a force. That's how we actually talk now sometimes. It's not something like, it's like instantaneous. Like it's not there is a time lag that this body is going to apply some force, then that body is going to, okay, let me also apply that force. No. If it's like that, if body has applied some force, instantly there is a reaction to it. There is no cause effect relation. Got it? Can we start some questions now? Can we start some questions quickly? Quick. Can we start some questions? Can we apply if there is let's say n number of particles of masses and moving with different velocities v's? Yes, Madhusudan, we can apply that. How we can apply that? If there are n number of particles, just assume it has got a center of mass. Not, I mean, what is there to assume? Just find out the center of mass using the center of mass of discrete particles, isn't it? Where mass and velocity, no, we are not going to apply that thing. You get it? How we are going to apply that? Because we have got another relation for when mass and velocity are not constant. Alright, a meter scale is moving with uniform velocity. This implies, alright, quickly going to start poll. 60 seconds is the time. So we have started questions, so please stay connected. After it, we are going to start work per energy. Really quick. So if you are feeling sleepy, just remember that just like you got to know what really tension is, how tension is acted upon. We are going to talk about work energy theorem. We are going to talk about lots of topics like that, right? So it's time that you should feel a little fresh and excited. Quick. A meter scale is moving with uniform velocity. If it is moving with uniform velocity, it means that its direction is not changing and its magnitude is not changing. That means the net acceleration on it is actually 0. Right? Now I mean, right now you didn't have actually understood what we really mean by, and the torque about the center is also 0. Absolutely. Good. So good. You haven't read torque, but still you are able to do it. The force acting on the scale is 0. Definitely if net force is 0, the net acceleration is 0. This implies that net force is also going to be 0. But a torque, now what do you mean by torque? Right now, since we have not studied what torque is, right? That means in this class, but you might know that, sir, you could please explain in a few Hindi language also. Buddy, I know Hindi and I really want to also I mean, I would want to convey all of these things in Hindi, but this is an English channel. That's the constraint, right? See, a torque is an effort which might bring some change in a rotational motion of a body. That's the best way to put it, right? So, I mean, even if a body is like rotating, the velocity of those points, the velocity of the body is actually changing. Like for example, if I am going to talk about this point, the velocity is changing, right? So, under rotation it is changing. So, that means net torque is also going to be 0. So, B option is absolutely correct. The force acting on the scale is 0 and the net torque acting about the center of the mass of the scale is also 0. So, B option is absolutely correct. Whoa, 100% great. Good. Let's move ahead. Let's see the next one. A cricket ball of mass 150 gram, please note the unit, has an initial velocity of 3 I cap plus 4 j cap in meter per second and a final velocity of minus 3 I cap plus 4 j cap meter per second, right? Going to start the poll. The change in momentum, you have to find out the change in momentum. Quick. Easy. So, if they are talking about the change in momentum is always final minus initial and momentum is mass times velocity. So, mass is 150 gram, that is 0.15 kilogram, right? After this, final momentum is minus 3 I cap minus 4 j cap, negative times of 3 I cap and negative times of 4 j cap, because we have got a negative sign outside of the bracket. Please don't do these kinds of mistake. So, this will be 0.15 times minus 6 I cap minus 8 j cap, right? Have you done the calculation part? Quickly. Is it all good? Quickly tell me. Done? B is the answer. C is the answer. C is the answer, right? Let me just calculate it. Quickly write down in the chat box what answer you getting. C is the answer, right? C, all right. Okay, why A? Why A, doston? Why have you opted for A? Can you tell me? Why you have opted for A? It's C. I think it was easy. Moving on to the next one. A body of mass 2 kg travels according to the law x of t equals to P times t plus Q times t square plus r times t cube, where q is 4, p is 3, r is 5. Find the force acting on the body at 2 seconds. I want better reaction from all of you. Quickly, quick. They have given us what the value of P, Q and R is going to be. So this is actually nothing but P is 3, so 3t plus Q is 4, so 4t square plus R R is 5, so 5t cube, and this is your x of t. And what they are asking is find the force acting on the body at 2 seconds. So they are asking force at 2 seconds. Quick. We know what mass is, huh? So force can be written as mass times acceleration. So let's find out the acceleration at 2 seconds. For finding out the acceleration, let's differentiate this equation to find out the velocity. That means dx by dt. So if we are going to differentiate it, we are going to get t plus 8t plus 15t square. And let's again differentiate it. So we are going to write dv by dt equals to a of t equals to, this will become 1. Sorry, this thing will become 3 and this thing will become 0. Is that correct? This thing will become 8 and 30t. Now at 1 second, this will imply that at 1, or it was 2, it was 2. At 2 seconds, it is going to be, this is going to be 68 meter per second square. Everything is in SI unit, by the way. Everything is in SI unit, right? By the way, please look at the units of these things, huh? P is in meter per second, and this is T is in meter of T is in seconds. So second can be cancelled out. That's how it is moving, right? Are you getting it? Quickly write down in the comment section if everything's clear in the chat box. Then after this, so we have found out what acceleration is. Mass is 2 kg, so 2 times of 68. Done? Why have you written D? That's just acceleration. We were supposed to find velocity. We were supposed to find force, right? So it's 136. Is it good? Madhu, is it good? Your answer was wrong. Good, good, good. Rupreksha, very good. So the correct answer is going to be A. 50% and half of have said C as the answer. All right, okay. Done. So with this, now I'll give you one question in homework. So take this one in homework, right? So you have got a body of mass 5 kg, you have got force, and you have got initial velocity. You have to find when this velocity will be along y-axis. So that's actually a good type of a question, right? Got it, got it, got it. So you have got your force, you have got velocity, you have to find when this will be along y-axis. What do you mean by this? This means that velocity along x-axis should become 0. So you can find it out, right? So this will be in homework. Done? After this, now let's talk about the conservation of linear momentum. Although usually what I do is I actually, you know that I explain conservation of linear momentum after learning. I think we did it in work power energy, but according to NCERT, it's in this chapter. Let's do it. We have no problem about this. it says the total momentum of an isolated system of interacting particles is conserved, and I have explained it to you. First of all, now see, this is very important. They are talking about the total momentum. This is one of the important thing. Then they are talking about the isolated system. You know what isolated system is? Like for example, as I talked about those two charged particles, those two charged particles is actually the isolated system. Alright, done. And of the interacting particles, you already know what interacting particles means, is going to be 0. But what is the condition for it? What is the condition for that? So the condition is, we know that net force acting on a particle is actually given as rate of change in linear momentum. This is for the system, right? So if net force is 0, if net force acting on the particle is 0, this means that the total momentum of the system will be constant. Is that correct? Quickly write down in the chat box. Why, if this is a constant, then only you are going to find the derivative of a constant, and that derivative will be 0, isn't it? That's how it's going to work. If net force is 0 and we write net force as differentiation of momentum with respect to time, that means that momentum is a constant. Momentum of the entire system is constant, and that too the total momentum, right? So this means that, and where are we going to talk about the net forces equals to 0? So net forces are equals to 0 means when there is no external force. Absolutely. So this is basically we are talking about when net external force is 0. Right? Got it? Done. After this, what we are going to do is, we are going to actually again come back to conservation of linear momentum, but when we are going to talk about the energy and potential energy, we are going to again come back to this topic. The reason is, when I am going to say that, let's say we were talking about this thing only, these two charges. Again, I'll use this as an example. Let's say this is Q1, this is Q2, both of them are positive, and right now they were being kept using an external force, right? They were kept using an external force, and then what I am going to do is, we are going to actually release them, and when we are going to release them, they are going to come close. That means they are going to start moving. So before releasing them, initial momentum of the system was 0. This is what I am talking about, the entire system, because both of them were at rest when we held them, right? After letting them go, they start moving with velocities, and let's say they start moving with velocities v1 and v2. So that means there is a kinetic energy that has come into picture. Where has that kinetic energy come from? That's what I said that we are going to get to know about this topic in detail when we are going to talk about energy itself. Are you getting it? Everything's clear? Quickly write down. Can we move ahead from conservation of linear momentum, which I have told you we are going to again come back to it. So it's not something like we are just learning it for once. Then after this, let's talk about the translational equilibrium. That's again it is a part of Newton's laws of motion. Again we are going to talk about it when we are going to talk about rotational motion, right? These topics usually comes in more than one chapters. So let's again break this topic into two words. One is translational and the another one is equilibrium. And now again I would like all of you to pay close attention, because again this is very, very important. Again this is very, very important, right? Translational. First of all, what do you really mean by translational? Translational basically means that it comes from translational motion. when we'll discuss rotational motion, we are going to talk about what are the different types of motion we have got over here. So, motion can be categorized in a way into translational motion that we have got over here, into rotational motion and rolling motion, right. Now, translational motion is something like this. Can you observe what type, what is the speciality about this motion, that this is a body which happens to be a rigid body, and we are going to talk about what rigid body is in rotational motion, but for now let us just consider that we have got a body, and each particle of this body is moving in a straight line with same velocity. I can just say that each particle of this body is moving with the same velocity. This is known as translational motion. This does not happen in rotational motion. If a particle is rotating, this point and this point has got different velocities because they are moving in different directions. Are you getting it? What I am trying to say? Their magnitudes can be also different, like for example, as this particle has got less velocity than this particle. Are you able to understand what I am trying to say? So, when we are going to talk about translational equilibrium, then what we are going to say? This word equilibrium basically means two things. One is net force equals to 0 acting on the body, and the another thing is net torque acting on the body is 0. So, because right now we have said that we are learning about the translational equilibrium, that is why we are going to just talk about the net force acting on the body to be 0. This is what the translational equilibrium means, and after this we are going to write that because of this the net acceleration will also be 0. Does it mean that the body will be at rest? Quickly write down in the chat box. Does it really means that the body will be necessarily at rest? If I am saying that the body is in translational equilibrium, does it necessarily means that it is at rest? Quickly write down in the chat box. Yes, so the answer that we are getting is yes, no, not really, yes. No, yes, alright. Let us see. So, that means you have got a doubt. So, the answer is, it's not a new thing. If you are really saying yes, that means that the reason is that you are not really understanding, you are not giving enough time to what we have got over here. What's written over here? Somebody has written that no, it will with small, that means it might have small velocity. See, that's not what we are saying. We are only saying that net force acting on a body just means that net acceleration is 0. Acceleration means that there is no change in velocity. There is no change in velocity, but a particle might move with uniform velocity and it can be anything. Are you getting it? A particle can move with any velocity, it should be uniform, then we will say that it is in translational equilibrium. The net force and net acceleration should be 0, that is it, right. So, it is not necessarily that the particle will be at rest, but usually what happens when we are going to actually look at the problems. What do you mean by problems? Problem I mean by, say, let us say I am talking about a problem like this. See, I am talking about a problem like this. So, this is actually at rest, I can see that. So, it will remain at rest. Why? Because it is in translational equilibrium. But if a certain body was moving and it is in translational equilibrium, it means that it is moving with uniform velocity. So, it is not necessary that for a body to be in translational equilibrium, the velocity must be 0. This thing is 0. Are you getting it? So, after this, if net force is 0, what we are going to imply from this is the summation of all the forces, and by the way this is vector of course, summation of all the forces along x axis will be 0, summation of all the forces along y axis will be 0, and summation of all the forces along z axis will be 0. So, this is what equilibrium means. This is what translational equilibrium means. So, rotational equilibrium is going to be the same thing. So, when I am going to talk about rotational equilibrium, I am not going to start it all over again, I am just going to start the questions. Are you getting it what I am trying to say? Is it all good? Quickly write down in the chat box. So, if we have to actually find out how to solve this problem, By the way, I've got one more problem related with graph, but first let's solve this one. Now they have told us that find the value of theta to keep this system in equilibrium. That's what they have told us. Are you getting it? Right? This is what they have told us, that to keep this in equilibrium, we have to find the value of theta. Alright, so I think let's start the poll. 60 seconds. Is your doubt clear now about that velocity and that thing? And what do you mean by system? System means that this block, these ropes and everything, that's why basically we are talking about. How to join in poll? Buddy, just write down your answer in the chat box, just with A, B, just that. Don't write anything with that, right? Great. Let's talk about this thing first of all. We have got a block. This is at rest. Why we are talking about rest? This is in equilibrium. This is in translational equilibrium. That's what they have told us. If this is in translational equilibrium, what are the different forces acting on it? Tension T2, 60 Newton. That means this is 60 Newton. Is it all good? First thing, I have just started, Sarika, don't worry. I have just started. This is 60, so this is going to be 60. Now let's talk about this point. I am drawing this point over here. For this point, again, now that's how you are going to use your basic concepts of tension and normal reaction. Right now we don't have any, we have to do anything with normal reaction, but we have to draw the direction for tension, right? So for this point, tension will act downwards. Are you getting it? So this is tension and this is T2 and that is equals to 60 Newton. Excuse me. We have got another 60 Newton over here. And we have got T1 over here. And by the way, we have got a vertical line like this, and this angle, that's what we need to know. This is theta and this is T1. And we don't know what T1 is also, right? So what we can actually do is we can break down these components and we can write that, okay, so this is actually equals to, this is T1. This is T1 cos theta and this is T1 sin theta. For anyone else who are still suffering in components, please don't do it. If this is theta, this is going to be T1 cos theta, that's it. If this is where you are not writing theta, that's sin theta, although this is the most basic trigonometry. So let's not divert from the topic. So that means T1 sin theta is equals to 60 Newton, T1 cos theta is equals to T2, that is 60 Newton, and we are going to divide it. That means tan theta will come out to be tan theta is coming out to be 1, that is theta is going to be 45 degree. Right? Can we move on? 87.5, very good. Very good. Done. Quickly write down in the chat box that, okay, now you are able to find out problems like this, that how to draw tension, how to draw forces and all. By the way, there is also a Lami's theorem related with these types of problems. You can also use that, right? But this is actually good. Can we start a new topic? That is friction. Can we start a new topic? Friction. Quick. Let's finish friction, then I'll give you a small break again. Very good. First thing first, before understanding what is friction, it comes under electromagnetic force. We have already done it. Sir, we will solve kinetic energy. Yes, Diya, definitely we will do it. We will do it, definitely. And by the way, this is all going to come in your tomorrow's exam, so stay tuned. Like any other forces of the force of nature, friction force also makes a pair of equal and opposite forces acting on the two bodies. Friction force is electromagnetic in nature. There is nothing written on the board which is actually new to you. I only told you that every other force in the universe makes action reaction pairs, right? And friction is an electromagnetic force in nature. That's also what I have told you in when we were starting this part, this chapter, that is force. Now the thing is, if you have ever, if you have ever seen in some books of a junior classes, you might have seen that friction is actually type of a force which actually happens to come into existence because something like interlocking of surfaces takes place, right? You might have seen diagrams like this. So this is not reality. This was a very old theory. This is the reality is actually quite far away from this. It's not like surfaces have rough, surfaces are rough. They might look smooth to you, but nothing like this kind of thing happens. It's again, we really don't need to care that what's happening in the microscopic level, right? Because that must be very complex. But as far as we are concerned, our study is concerned, we can say that again this is an electromagnetic in nature. That means there is actually the particles of different surfaces actually make bond with each other. And when I say bond, I really don't say it in a chemical sense, but it's kind of an attractive force they build towards each other. And when something tries to actually break that bond, they actually apply a frictional force. That's what we say. That's how you are going to actually make an understanding of this topic. But for us, what is friction force? I'm going to just say it in one sentence. Friction force is actually a force. It is a resistive force. Please understand, it is a resistive force, or I'll just say that it is a force which reduces the tendency of relative motion, So this is the main part. This is what we are going to, this is going to play a major role. Not like those interlocking and bond and anything else, right? Nothing like that. The important thing is that you must understand that this is where you are going to actually build your concept of friction. If you lose the definition of the friction force, you will not be able to apply it. You will not be able to draw the directions on different bodies. Whenever you are going to draw a friction force on any body, just think one thing. If I am drawing this friction force in a body, I'll repeat it again. I'll repeat it. If I am drawing a friction force on a body, is it reducing the tendency of relative motion or not? That's it. You know what relative motion is? Relative motion basically means when two surfaces are in motion with respect to each other. We are going to go deep into it. But for now, let's move. I've said I'll go deep into it. For now, let's move and let's consider this is what it is. By the way, it is a contact force, right? So friction force is a contact force. That means it comes into existence when surfaces are in contact with each other. It's not like electrostatic force or gravitational force, which are non-contact force, right? It is a contact force. Then we are going to say that it reduces the tendency of relative motion. Fair enough, right? All right. So now we are going to say what are the different types of friction. So for us, although there are three types of friction, but again, as far as numericals are concerned, we are going to be looking for the first type, that is known as static friction, and the second type is known as kinetic friction. Alright. So what do we really mean by static friction and what do you mean by kinetic friction, and why there are two types of friction, right? Why there are two types of friction and why, what's the need? The surfaces are same, so what is the need behind it? The need behind it is, again, let's just have a glance of what's happening behind it in a microscopic way. Let's suppose we have got two bodies like this. I said glance because again we are not going to go deep into this thing. When these two surfaces are in contact with each other and these two are at rest, these two are at rest. When they are at rest, is there any tendency of relative motion? Absolutely no. I'll explain it. Let's suppose this is one of the surface on which the body is kept and this is the another surface. This is something like this. Is there any requirement of friction force to act? I mean, are you going to draw friction force on these bodies? No. Why? Because there is no relative motion. If there is no relative motion, why would you make frictional forces? Now let's say something like this is happening. I mean, not like they are not oscillating, but it is moving something like this. Is it relative motion? No. Are they moving? Yes. You got it? So there is no relative motion. They are not in motion with respect to each other. They are in motion with respect to another frame of reference, right? They are not in motion with respect to each other. So again, there is no need for frictional force. But let's see it again. Let's suppose I am applying a force on this body. Hopefully you can see it clearly, right? I am applying a force on this body, right? So if I am applying, there is a tendency of relative motion, and what's that tendency? That this body is going to move in this direction. It has got a tendency to move. Are you getting it what I am trying to say? So now this body is quite small, that's why just one little force actually just pushed this body away. Now assume that we have got a bigger body, something like this. When it was at rest or when it was moving with uniform, when both the surfaces are moving, there was no friction. When we are going to start applying a force on it, then still you can assume that still instantly it's not going to come into motion. Are you able to understand it? Right? Got it? So instantly it's not going to come into motion. Let's suppose that we have got a bigger block. So what's happening? The thing that's happening is that because these bodies were at rest, the maximum amount of atoms and whatever you want to call them, the molecules were able to actually make bond with each other and they were tightly attracting each other. So that's why at the very start when the body is at rest, the friction that acts on the surfaces is known as static friction. Now please understand, is it moving? No, but there is a tendency of relative motion. If I didn't apply the force, there is no tendency of relative motion, so that's why there is no friction. Got it? Are you getting it? So now if you have applied a force in this direction and now the tendency has come into the picture, then we are going to draw a friction force. And in which direction we are going to draw the friction force? In this direction, on the block. And this is the friction force and we are going to write it as Fs. And this is the static friction force that we are talking about. Got it? Are you getting it? Right? So now, yes, this is not. Use chat for only asking doubts. So now the thing is, again I'll ask you to actually come back and again visualize a thing, that you are again pushing the bigger block and you start to actually applying the force and you are still it's not moving. It's a big box. You might have done it, right? It's not something that's very unique. You might have done it and now you're starting to increase that force and still the block is not moving. It means that this type of a force, that is a static friction, it is a self-adjusting friction. That's the next thing that we are going to talk about. It's a self-adjusting friction. So what are the different points we have got over here? First of all, it acts when surfaces are at rest, but that's not all. Are at rest and have a tendency of relative motion, that there is some force acting on it. So if friction force will not act, definitely it will start moving. Definitely there will be what we can say, there is going to be relative motion, right? So everybody is comfortable with this about the direction of static friction. See, now I am not moving too fast because this is the basic concepts. So we have got block of mass m, and the external force acting on this block, let's say, was F. This was the external force. Right? So I am talking about on the block. On the block, the static friction will act in the backward direction. Are we able to understand it? Write down, quickly write down in the chat box. Plus second point is, acha, much like any other forces, friction forces are also, they also exist in action reaction pair. So on the block it acts in the backward direction, and on the surface it acts in the forward direction. On the surface it acts in the forward direction. Right? Clear? Everything's good? Quickly write down in the chat box. The next thing that we are going to write over here is that it is a self-adjusting force. It is a self-adjusting force, and we can actually really observe it, and we can really understand it from our own experience, that yes, when we push a block for some time it doesn't move while we are increasing the force. So that means there is something which is actually increasing its value. The friction force is increasing its value, but only up to a limit, and that's why we call it as a self-adjusting force. So static friction force in itself doesn't have a formula. Are you getting it what I'm trying to say? Static friction in itself has not got a formula. The thing is that it actually, its value falls into a range which is the maximum friction and a minimum value that can be 0. Quickly write down in the chat box. So when we are going to talk about the maximum friction, this is called as limiting value of friction. This is called as limiting value of static friction. Right? And its formula is, so again I'll write it as, this is sometimes also written as, acha, by the way, instead of writing as Fmx, I'll write it as Fl. It would suit, I mean it is the better representation. This formula is actually mu s into the normal reaction, and this is actually 0. Alright, done. What is this? This is mu s is, you might have seen something like this, that they write it as like this, mu s. This thing is known as coefficient of static friction. It tells you about the surface. It is an information given for the surface, right? And what is n? N is the normal reaction, right? So if let's suppose I am the limiting value of a static friction is, in a particular case I am giving you this information that limiting value of a static friction is 20 Newton. We have got a block, we have got a surface, and the limiting value is 20 Newton, and I am applying 0 Newton of force. I am applying 0 Newton of force. So there is F external force and there is friction force. Right? I am applying 0 Newton of force. Can you tell me what is the value of static friction? Quick. What is the value of static friction? If I am applying 0 Newton of force, what is the value of static friction? You are going to say, sir, 0 Newton. I mean, if there is no tendency of relative motion, why would there be any friction force? Now, if I will apply 5 Newton of force, external force, what is the value of static friction? Well, what you are going to do is, I will tell you what mistake you are going to do. Let's suppose this is actually 20 kg and this mu is actually 0.1. So, the mg is going to be 200, the normal reaction is going to be 200 and the limiting, if you are going to say, sir, friction value is actually mu mg, that is what you told us, and mu is actually 0.1 times 200, which pretty much makes 20 Newton, and you are going to write 20 Newton over here. And after this, you are going to say that physics is tough. Are you getting it? What things you should avoid? The thing is that there is no need of 20 Newton. 20 Newton was the limiting value. It was the maximum value up to which the static friction can take its value, right? But it's not necessarily that it will apply. If 20 Newton is applying over here, that means friction force will actually take this block in this direction or in whatever direction it wants. It's some sort of magic. Cheen tapak tham tham, right? So that's not possible. So the thing is that if you are applying 5 Newton of force, static friction will be also 5 Newton, because it is a limiting value of it, because it is a self-adjusting force. Then again, if you are going to apply, let's increase it up to like 20 Newton. So this is the limit. Now if you are going to apply even after this, let's say you are applying 30 Newton. Now kinetic friction will come into picture. Now even the 20 Newton will not act. Now the kinetic friction will act. And again recollect some of your memory. As soon as you have started to push that block, now pushing that block is easier than it was to make that block into motion. Are you getting it what I am trying to say? It is easier to push a moving block than to make that block from rest into motion. The reason is that the next type of friction that we talk about, that is the kinetic friction, its value is less than the, now it has got a constant value. It's not a self-adjusting value, it has got a constant value. It is denoted by Fk, it is written by mu k into n, and this thing is always less than the, the limiting value of static friction. I mean, just don't write static friction, because static friction can be anything, it could be 0 also. The limiting value of static friction, right? It's always less than the limiting value of static friction. Is everything good? Clear? Quickly write down in the chat box if everything's clear. Right? So when we are going to talk about kinetic friction, again, kinetic friction is written as mu k into n, where mu k is coefficient of kinetic friction and mu k is less than mu s. So if you are going to actually, there is a very famous graph between external force and friction force. Alright, between external force and friction force, and the graph looks something like this. So this proportionality, this linear relationship basically tells that we are talking about static friction. This is static friction. As the external force is increasing, static friction is increasing, right? And this is the limiting value of static friction. This is the limiting value of static friction, right? Everything's perfectly clear, sir. Really, really good. Good, 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 good. Now, after this, this is the limiting value. After this, it will drop down and then it will be like a straight line, something like this. And this is going to be the kinetic value of friction. This is going to be a kinetic value of friction, Fk. Alright, done. So, we have done kinetic friction, we have done static friction, and again let us talk about some of the important points, although we have finished everything. Fk is less than limiting friction, absolutely. Then how will body move? Because external force is getting more, na dear? External force is getting, we are increasing the external force, that's how. Got it? Clear, clear, clear? It's a self-adjusting force. I have explained each and everything. You can pick any maximum value of static friction is called limiting value. Numerical value of static friction is equal to the external force tendency to generate the relative motion of the body. Is it correct? Right? It's a self-adjusting force. It adjusts its value according to the requirement, right, of no relative motion. That is the requirement of no relative motion. Everything is done. We have also done kinetic friction. Then the thing that you were asking about for quite long, Kevin was I think also asking about it, that please let's talk about the kinetic friction should be more than the limiting friction. No sir, no, it's not, absolutely no. As soon as you have actually started to move the body, now to actually to make that body into, to actually make that body to stay in relative motion is actually quite easier. That's actually it's a fact, that's a scientific fact. You can also observe it, so it's nothing to really worry about it. Now we are going to talk about rough inclined plane, and we are going to also talk about the free body diagrams of rough inclined plane. Now please, how will body move? How body will move? Because of external force, my dear. External force will move the body. It's not friction force. Friction force resists it, right? So we have got an inclined plane, something like this. And the angle of inclination is theta. And we have got a block kept like this. We have got a block kept like this, right? Block of mass m. Block of mass m. If this is theta, quick, huh? By the way, this thing has coefficient of static friction as mu s. Let's not talk about mu k, let's talk about mu k. Sir, when will you teach? Let's not talk about all of Madhusudan, I'll teach you. Let's stay with this one. We have got mass m. Now easiest thing, if this is theta and I am just drawing mg from here, although I should draw it from the center of mass, but you can understand this thing. I am drawing mg from here, so if this is mg and this is theta dosto, then can you please understand that this is going to be also theta? You have to just understand this for one time, and after that please remember it. And when I say remember it, I mean to say that you have to be really quick. Okay, so this is theta, this is m, this is mg, then this is going to be mg cos theta. You have to be really quick. And I am going to write mg sin theta over here. So this is actually technically wrong. I should draw it something like this, and I should also draw it something like this. And now I can draw mg sin theta like this. Everybody is okay? This is mg sin theta. This is the mg sin theta, because of which when you are actually, when you are on an inclined plane, you feel that something is pulling you down, na? That this is the component of your weight, that's mg sin theta. Got it, dosto? Right? Now you tell me, if we are not talking about, right now we are not talking about friction, in which direction this block has a tendency to slip. Now we are going to use some more technical terms. Instead of just talking about like relative motion, let's say the block is not moving anywhere, the block is fixed, right? Now I am going to say to you that in which direction the block has got a tendency to slip. So are you going to tell me the block has a tendency to go up? Is there any force? No. Is there any force with which the block can move up? Absolutely no, right? So there is only one force because of which the block might come down, that is mg sin theta. So on the block the friction force will act in the upward direction. On the block the friction force will act in the upward direction, and that's going to be the static friction for now. If let's say if somebody doesn't write what type of friction it has got, then just assume it. Just after completing it friction, I am going to give you another break, then please come back, alright. Else you will demotivate me that there is no point of keeping all of these one shots, right. So I will give you a little bit of break, but till then let's complete this thing. Everything's okay. What else we have got over here? Can we please write the normal reaction? So the normal reaction on the block is going to be perpendicular to the surface. So this is the surface that we are going to talk about, right. So this is going to be the normal reaction. This is the normal reaction that we are talking about. Alright, done. Everything's clear. Also, if you are going to ask me that, sir, although we are not really concerned with the components of normal reaction, but we are going to talk about it in circular motion, I mean banking of road. Everything's clear till here? Alright. So now I am going to say to you that let's suppose this is mg sin theta and this is the limiting value of friction or Fs. I am going to say then, since the block is not moving down, since the block is at rest, that means the static friction will be equals to mg sin theta. That's it dosto, that's it, nothing more. Static friction, right, done. After it, just one more thing. If I am going to increase this inclination, if theta is increased, sin theta will increase, obviously sir. If theta will increase, sin theta will increase, and before writing equations, think about it. Yes, normal reaction is equals to mg cos theta, absolutely buddy. Normal reaction is actually equals to mg cos theta. Always, this is always. I mean, unless there are no other forces, right? Got it? What I was saying? Think about it. If you are going to increase the angle of inclination, the block will come down at a certain angle. You might assume it like, you might also like see it like this is the body, this is the thing. It is some sort of a, it is at a certain angle, I have inclined it but it is not moving. At a certain angle it starts to move. Is that correct? So let's find out at what angle it will actually, the friction force will have its maximum value. When you are going to increase this angle, this mg sin theta will increase, this sin theta will increase. Because of that, this friction force will increase itself because it is a self-adjusting. So at a critical angle, that is known as mg sin theta c, this will be actually equals to the limiting value of static friction. After this angle, if you are going to increase the angle further, then the static friction will not be able to adjust it. The static friction will say, jao, go, move on, that was my limit, move on now. Can you relate? Right? So that means this will be actually equals to mg sin theta c is equals to mu s mg cos theta. We can cancel out m, we can cancel out g. That means tan, and by the way this is also theta c, tan theta c will be equals to mu s, and which means that this angle theta c is that I was calling it as critical angle, that will be tan inverse mu. This thing is known as angle of repose. This thing is known as angle of repose. Correct? Got it? Quick. After this, again small break, although we were supposed to stay till 10, then I should have given the break but because it's a dinner time, so you can take a little bit of break. Although if we can actually complete it, but circular motion we can start afterwards, no issues with that. So a particle of mass 1 kg rests on a rough contact with a plane inclined at 30 degree to the horizontal, is just about to slip. Find the coefficient of friction for you. सर आपने UC लिख दिया, UC लिख दिया, म्यू सी लिखना था मुझे तो, I had to write mu c. This is mu s. Alright, mu c लिख दिया मैंने, very bad. This is mu s. What an observation, buddy. Chalo, let's move. Quick. Quick. Easy. 1 kg, we don't have to do anything with 1 kg. The coefficient of friction is going to be actually, you know what, na? Tan 30 is actually equals to mu s. So mu s will be 1 by root 3. This is how simple it is. I mean, obviously. Now the only thing is to remember all of these things. This is the challenge. The challenge is not to actually apply the formula after remembering it. The challenge is to remember it. What else do we have got over here? Acha, let's do this one. Let's do this one. I'll do one thing. I'll state. Okay, state whether the block will move. If yes, then what acceleration? All right, chalo. Let's start this one. By the way, what was the answer for that one? A. 100%. Wow. Let's solve this one. Quick. W. Who's W? W means great. How come W means great? All right. First of all, let's do simple stuff. Even if I don't have to draw the friction force and all, first what I'll do is I'll first of all find out the limiting value of friction. Limiting value of friction is going to be mu s into mg cos theta. So mu s is actually equals to 0.4 times mass is actually 2 times g times cos 37 is 4 by 5. So this is going to be 2, right? Clear? So this is going to be actually 4 and this is going to be 16, this is going to be 6.4 Newton. Is it correct? Is it correct? Quickly write down in the chat box what it is. What it is? Quick, correct? All right. So 6.4 Newton is the static friction. Sorry, the limiting value of static friction, and the tendency and the static friction will now act in the downward direction. So it's not like always on an inclined plane friction only acts in upward direction. It depends on the tendency of a relative motion. Now again please understand that what is this mg sin theta over here. Let's write mg sin theta also. This is mg sin theta, and what is the value of mg sin theta? Mg sin theta is actually, mass is again 2, g is 10, and sin theta is actually 3 by 5. So this is actually 2, this is actually 4, this is 12 Newton. Oh, sorry. So mg sin theta is actually 12 Newton. So actually there is 12 Newton of force acting in this direction. So friction force will act in opposite in this direction only, right? Friction force will act in that direction only. Find the force on the friction acting on this one. So there is 12 Newton acting over here, there is 4 Newton acting over there, right? And there is only 6.4 Newton acting over here. So this is the limiting value. So limiting value can't actually resist it. So we are going to again find out the kinetic value of kinetic value. So kinetic value is actually 0.3 times mass times g times cos 30, that's 4 by 5. Is that correct? Everything's correct. So let's find it out. This is going to become 2. This is going to become 8. 8 times 2 is 16. 16 times 3. 16 times 3 is 48. 4.8 Newton. So this is 4.8 Newton. Everything's clear? Quickly write down in the chat box. Everything's clear? Quick. See, I'll again tell you. There's 12 Newton. Here's 4 Newton. That means the net force acting over here is, net force right now acting over here is, this is the net force, that is actually 8 Newton, and friction force will definitely act in this direction, but the maximum value of friction is 6.4 Newton, and we require 8 Newton. We require 8 Newton to keep that block at rest, right? We require 8 Newton, but we don't have it. So what will happen? Kinetic friction will act on the block, and what is the value of kinetic friction? That is 4.8 Newton. Are we doing anything wrong? Because after applying 4.8, it will actually 6.4 and no, sorry. This is 12 na, huh? Everything's cool. There's no problem. I think there's no problem. Correct? Is it correct? Clear? Everything's clear? This is 6.4 Newton, that is maximum thing, right? Maximum value that can act. So we cannot apply that thing over here, because even if we'll apply 6.4 to this one, 6.4 plus 4 will be actually 10.4, right? 10.4. So this is 10.4 in this direction, and there is 12 Newton in this direction. So we don't have that, right? So static friction will not take place. The body will start to move, and there will be kinetic friction, right? And after having kinetic friction, we have got 12 Newton over here. The net force, I am going to write it something like this, that we have got 12 Newton over here, and I have got kinetic friction, that is 4.8, and minus I have got 4. Is everything okay? So I have got 12 minus 8.8. So this is the value, and equating it to mass of the block is actually 2 kg times acceleration. So find out the acceleration. So first of all, the value of friction will be 4.8, and it will have certain acceleration, so it must be A according to me. A is the correct answer. Quick, tell me if everything's clear. Quickly tell me if everything's clear. A is the correct answer. Didn't we had poll for this one? That's bad. So A is the correct answer. Let's move. Now we have completed friction. I think I have given you sufficient information about friction as well. We haven't skipped anything, we haven't skimmed through anything, We have done each and every concept. Now, one thing is we can either start circular motion and then we can take a break, or we can take a break right now and then we can start circular motion. What you guys want? Please ask if you have any doubt, and what do you want? Please, you can ask your doubt, Sajan. Alright, alright. So 10 minutes of max break, right? I'll come back after 10 minutes. Alright, 10 minutes of break. Alright, max. Take a break of 15 minutes, then we'll come back. No break. Alright, so no break. Let's have no break. No break, no break. One student has said no break, so we'll have no break. Let's start circular motion. Well, block system, again I'll have to explain this thing that see, I'll have to explain that again. Block system is part of NEET syllabus, but today we are focusing on completing the midterm course. So although I have actually explained each and everything, so let me just explain this short part, then we'll have a break, right? 10 minutes of break. Please, let's quickly, one of the student has asked about the block system. It's very easy. See, even if you have got like two block system, na, even if you have got a two block system, let's suppose we have got a one block over here, we have got one block over here, they are connected by a means of a string, and we are pulling this block with a certain force F. Now it can become a little bit of on a trickier end, but let's say the force is of let's say 20 Newton. All you have to do is you have to find out the value of limiting friction for all of these things. This is M1, this is M2. On M1 there is going to be tension acting in this direction, which is equals to force. There, sorry, not tension, there is just going to be force acting in this direction. In this direction there is going to be tension acting and friction acting. On this M2 there is going to be tension acting in this direction and friction acting in this direction. That's it. So just figure it out that whether this friction, whether we need to have a static friction. If there is static friction, then the block will not move. And if let's say this force is actually greater than the static friction, then kinetic friction will act, and just apply the equation of just apply the Newton's second law of motion, that is F minus T plus friction force equals to m1 into A, and same acceleration this block will also have A. So T, and by the way it will have a different friction, T minus F equals to m2 into A. So it's not like if I haven't talked about a particular case you cannot do it. That's what I said, that I am going to complete each basic concepts in detail, so that even if you have got something like this, you know how to do how to write friction, you know how to draw tension, you know how to write this equation. So what's stopping you to do any problem, right? So with this positive note, I am going to give you a 10-minute break, and after that we are going to start circular motion. Is that okay? Quick, be quick, don't waste any time, and come with more energies because we need to complete some more topics, right? Let's start. Your time starts now. Welcome back, welcome back, welcome back, welcome back, welcome back. Are you ready? Are you all ready? Shall we start? So now we are going to talk about circular motion. Alright. So gather all of your energy. Let's start. Let's start this chapter, which is actually part of this. Some part of this comes in laws of motion, some part of it comes in work per energy, and some part also comes in kinematics, right? So we have opted to do it in middle of Newton laws of motion and work per energy. How are you going to define circular motion? First of all, before starting defining circular motion, again, yes, after this we are going to quickly start work per energy, right? Let me explain something to you. What do you think, what type of a motion this body has got? It is moving something like this. What do you think? Write down in the comment section, in the chat section. What do you think, what type of motion this body has got? Quick. Is it a straight line? Is it a straight line? Is it a rectilinear motion? Well, it depends on, it also depends on the frame of reference. For example, let's say, what I am talking about is, let's say we have got two types of frame of reference. One is A. One frame of reference is A. With respect to frame of reference A, if you are going to talk about the angle, the d theta by dt, what is this d theta? This d theta is actually the angle at which the observer is observing the motion of that body. It's the observer is looking like this, right? And the angle is not changing, and moreover the angle is 0 over here. But even that angle is not changing with respect to time. That's all we can say. Now let's take a look from another frame of reference. That's what we call as, let's change our perspective, right? For a frame of reference B, we can see that right now the angle with the vertical is theta, or let's say phi, and this phi is going to change constantly. That means for person B, d phi by dt is not equals to 0. For this there was no change, but for this it is not equals to 0. So first of all, before starting any chapter, let's clear our basics, right? This is very important. So again, the frame of reference is going to take a very important role. This is a very basic concept, you must know it. The definition of circular motion in itself is not of a difficult thing to understand. It's quite easy. If a particle moves in a plane, so this is a very important thing, that it should move in a plane. It is a two-dimensional motion, that its distance from a fixed or a moving point, that we called as a center, right? So the distance from a fixed or a moving point is constant, right? Remains constant, then this motion is called as circular motion, right? So now when we are going to talk about the different aspects of circular motion, we are going to actually first, let's draw a body which is moving in circular motion, and then I am going to talk about all the other things. Let's say this is a body, and just so that we can actually have we can actually draw vectors clearly, I am just drawing these dotted lines just so that these are just x-axis and y-axis, nothing else, right? And let's say the body is actually moving in anti-clockwise direction. The radius of this circle is r, I mean the circular motion, the radius at which this body is moving is at r, and the body's velocity is, let's say, at this particular point it is v, alright. So body is moving, after some time it will actually come to this point, let's say. It will come to this point. So that means now the body has come to this point. Initially the body was at here. Let's say at t equals to 0 the body was at this point. At t equals to 0 the body was at this particular point. So we have started to judge the motion of this body at this point. And at t equals to t, you might have seen this t equals to t, right? Nothing to worry about. The body has come up at this point and the direction will always be given as, the direction of velocity will always be tangential to this, right? Are you getting it? So now after this, if you are going to closely see to this diagram, we have got two things. One is the body has actually covered a displacement. It has covered a displacement, or what I can say is it has actually the point, this line has rotated. This line, are you getting it? This is all, you can also call this as a radial vector because this is along radius. It has actually rotated by a certain angle, right? The angle by which it has rotated is going to be called as angular displacement. It will be called as angular displacement. And this angular displacement, that is del theta, you know that del theta can be actually written as, and this is something that you might have learnt in like grade 9th or 10th, that we also talk about this arc length, isn't it? We talk about this arc length, right? So let's say this arc length is, delta S. Is that correct? The arc length is delta S. So delta theta can be actually written as arc length divided by radius. Let's go really quick because these are some of the important plus easy things. Delta theta is the unit is going to be in radians, it is dimensionless, this is in meters, this is in meters, right? This will be calculated in radians, right? Because of this, obviously we can write it as arc length equals to, from this we can imply that arc length can be actually written as theta, which is in radians, times radius. You might have seen this quite many times, right? After this, what I am going to do is, let's differentiate this equation. Let's differentiate it also. If this is actually small, this is small angular displacement, then this thing can be written as something like this. Is that all good, na? Everything's good. So now if I am going to actually differentiate it, this will be written as ds by dt equals to, r is constant, this will be written as d theta by dt, right? And if you are going to ask me, sir, why didn't you differentiate this one? Well, we can differentiate this one as well, but let's not differentiate it, let's divide it by delta t, because this is average. Hopefully you can understand it. So this is actually, well, what I am going to write it, this thing is going to be called as the V average and delta theta divided by delta t will be known as average angular velocity, and this thing will be known as instantaneous linear speed. This is instantaneous speed, and linear, this thing is known as omega instantaneous angular speed or angular velocity. So that's how we are going to write. So now I am going to write, and I am going to actually distinguish between angular speed and angular velocity. What do I mean by that? Right now, for now, you just write it down as angular velocity. And this thing will be linear velocity. And when we are saying velocity, we mean to say that we are including the directions. But how to incorporate the directions over here, right? How to incorporate the direction? The directions are included over here using the right hand rule, not this right hand or that magnetic, no, right hand rule. What does right hand rule says? Right hand rule says that curl your finger. First of all, this is the plane in which the circular motion is taking place. This board is the plane, right? Curl your finger in the direction of motion of the body, that is in the direction in which the body is moving. So the body is moving in anti-clockwise, so curl your finger something like this. What is the direction of the thumb? Thumb is pointing outwards to the board. Thumb is pointing towards outwards to the board. So that means angular velocity, the direction of angular velocity is outward to the plane. Right now that is board, and this is for this case, obviously, right? I mean, I'm not saying that this is always, and we actually denote it by a dot, something like this. Got it? So if this is x axis, this is y axis, this is z axis, so omega will be written with a k cap. Clear? Whatever the direction of omega is, obviously theta will be in the same direction. So same for theta, same for theta. Is everybody fine? Everybody is fine with this one? Quick. I want quick answers. Everybody is fine with this thing, right? Show some response on chat box. Right? Alright. So this is an important relation, V equals to R omega. After this, let's look at some of the important points also. Right? Alright, great doston, great. This is regarding these points are regarding the angular velocities. These points are regarding angular velocity. What is the first point? It's an axial vector. What do you mean by axial vector? By saying of axial vector, we mean to say that this is how the angular velocity is going to be denoted. Outward to the plane. Right? So if you write, this is the axial vector sign. I mean, not necessarily not this, it could be cross also, but this is the axial vector. Right? So first thing is, it is the axial vector that we are talking about. Second, with the dimensions of t raised to the power minus 1, very easy thing. Why are we saying this? Because the angular velocity is written as v divided by r. Sorry, let me, yeah, we can write it like this also, no problem. This is actually meter per second, this is actually meter, so it is in per second, that is t to the power minus 1 or d theta by dt. Both the things are same. Infinitely small angular displacement is a vector quantity. This is actually something important. I mean, you're not going to see a lot of questions from this, but this is actually important, that d theta is a vector quantity. Directions of small angular displacement is decided by the right hand thumb rule. I have explained it to you. When the fingers are directed along the motion of the point, then thumb will represent the direction of the angular displacement. So if it was anti-clockwise, you have to use your right hand, thumb will tell you the direction. If it is clockwise, again thumb will tell you. So in the clockwise, it will be towards the board, into the board. Everything's fine? Quickly tell me in the chat box, everything's fine? Now after this, when we are going to talk about again, let's say I am going to discuss this diagram again, right? And I've made a copy so I can remove all of these things, because I don't want to make the diagram all over again. So I'll use this diagram. Now please see over here. Again, going to clear all of your basic concepts of circular motion. This is the diagram. Also, I don't need this linear velocity, I mean this arc length. That's it. This is sufficient, right? Now what I am trying to say is that at this particular point, the velocity, the linear velocity was at this in this direction. The linear velocity was in this direction. Got it? After some time, the velocity has changed its direction. Done? The velocity has, not velocity has changed the direction, the particle has changed the direction, or velocity has changed. There is direction inside the velocity. So we are going to say the velocity has changed. Now please understand. If you have got velocity, and please understand, velocity was written as, the linear speed was written as r omega. If you are going to again differentiate it, so this was one of the equation. If you are going to again differentiate it, you are going to get dv by dt equals to r d omega by dt. And after this thing will be actually known as the tangential acceleration, and this thing will be known as angular acceleration. I'm going to write it everything for you, and also I'll summarize each thing. So don't worry. See, I am not tired. You should also not feel tired. Stay connected, because I am explaining each concept from the start, right? Got it? So this thing is actually known as This thing is actually known as tangential acceleration. This thing is known as angular acceleration. Now, what is tangential and what is angular? Now, please understand. There are how many things are there? Let's break it down. There is linear velocity, and there is angular velocity. Let me give you some confidence. This is my style of teaching, so you're not going to find it anywhere, and trust me, this is the I'm breaking it down in the simplest form, so you're not going to have any doubt after it. If the only condition is if you are going to look and learn all of this with some concentration, right? We are talking about linear velocity and we are talking about angular velocity. We have two types of velocity. Angular velocity was in this direction, by the way. So it means that if you are talking about either increasing angular velocity or decreasing angular velocity, that means change in angular velocity. So for change in angular velocity, we would require an acceleration which is known as angular acceleration. Is that okay? Now you are going to tell me, sir, what is the direction of angular acceleration? So the direction of angular acceleration could be either clockwise or either it could be anti-clockwise, could be anything. So either it could be anti-clockwise, it could be clockwise. So I'm not going to write anti and clock. I'm just writing it as dot means and cross means. Are you getting it? Done? And you can remember it, and this is not my trick. I actually heard it from someone else. This is actually if the thumb is pointing towards the out of the board, like me, it's coming towards you. So assume it like an arrow. So arrow has got a point in. If you see arrow coming to you, which is not a good scenario, but if you see a arrow coming to you, you will just see the point of it. And if you see an arrow going from away from you, you will see a cross on it. So it's a little, right? So you have got an angular acceleration whose direction can be anything. I mean, the direction of angular acceleration is independent of angular velocity. Its job is to change the angular velocity, and it is denoted by alpha. It is denoted by alpha, and the formula of it is AT by R. Right? After this, the linear velocity, what do you mean by linear velocity? Linear velocity formula is V equals to R omega, but it has got more things inside it. What are those things? One, we are going to talk about the magnitude of the linear velocity. And the another thing that we are going to talk about is direction of linear velocity. All right. Now hear me out. If you are talking about direction of linear velocity, direction is always changing for a circular motion. Are you getting it? For a circular motion, this is always changing. This is always changing for a circular motion. For a circular motion. And the acceleration which is responsible for this thing is known as centripetal acceleration. The acceleration which is responsible for this is centripetal acceleration. So if we are talking about a circular motion, there is one type of acceleration which will be present, and that is centripetal acceleration. No matter what happens, there is centripetal acceleration always acting on the body, and this centripetal acceleration is always acting on the body towards the center. So if the body is over here, centripetal acceleration is acting like this. If body is over here, centripetal acceleration is acting like this, right? If body comes to this place, centripetal acceleration will be something like this. Write down in the comment section AC. Are you getting it? So for a circular motion, this is actually very necessary. Now the formula for it has got a derivation. Obviously we can't do it right now. The reason is that derivation is actually, first of all, there are two types of derivation for centripetal acceleration. One is that we call in Hindi is 𝐿𝐶, the another one is the absolutely correct derivation, right? But absolutely correct derivation will take a lot of time and it is not being asked anywhere, even in schools it's not asked, right? So the formula for centripetal acceleration is AC equals to V square by R or omega square R. So this is the formula of centripetal acceleration. Although what I'll do is I'll make another video for finding out the correct way to centripetal acceleration. Soon you will get it. If I'm commenting it, I'll make a video of it. Alright, it's nothing like something that's very hard to do. It's just like change in velocity. So when we were looking at this diagram, this is V, a little bit of trigonometry we'll have to do. Final velocity minus initial velocity divided by time will be converted into the arc length and S, and that's how it's going to be done, right? So we are not concerned with that right now. Right now, please understand, we talked about linear velocity, angular velocity. Okay, sir. If linear velocity we are going to talk about, it has got two things, magnitude and direction. Direction is ever changing in a circular motion. Yes. So that means there must be some acceleration which must be, if direction is always changing, this means that linear velocity is always changing. It is always changing. And what about angular? Angular velocity is not changing. It is just like this, anti-clockwise. It is in the same direction. It will change when there is an acceleration, angular acceleration. It will change it. The direction will change. Hope you are getting it. Come back. So this thing is always changing. Centripetal acceleration will always act. It is a radial vector. It will act towards the center always. Magnitude is V square by R or can be written as omega square by R. How I have written it? I have written V equals to R omega. That's how we have got it. Now let's talk about the magnitude. Again, for magnitude, we are going to talk about two things. We are going to say that now even magnitude, we can have two things, like magnitude can be constant. So that will be known as uniform circular motion. Uniform circular motion or UCM. In this case, what we are going to say is that the tangential velocity, the tangential acceleration will be 0. The tangential acceleration will be 0. There will be no tangential acceleration, and obviously it means that dV by dt is 0. It means that dosto dV by dt is 0. Alright, so I'll write it over here. dV by dt is 0. This is what it means, right? If magnitude is not changing, dV by dt is 0. Got it? Got it? Got it? Got it? Done? Everything's clear? Angular velocity denoted by its omega. Yes, of course. What's other than the magnitude, that it can be constant, it will be called as UCM, uniform circular motion. Other than magnitude, it can, other than be constant, it can actually change. So if it will change, that means we are going to talk about non-uniform circular motion. Non-uniform circular motion. Non-uniform circular motion. Please don't mind, I am writing in short, right? In this case, we have got certain AT. AT is not equals to 0. I have summarized everything for this one, right? Got it? Done, done, done. So now what we are going to do is, we are going to actually now summarize everything, and we are going to talk about three types of acceleration. See, one is tangential acceleration, one is centripetal acceleration, right? So now let me break it down in two things, in two parts. Those two parts are something like this. I have written everything over here, correct, right? And this is also all sorted. So for this one, I am going to say that when we are going to talk about acceleration of what we can say of a body in a circular motion, so we are going to say that there are two types of acceleration. We have got two types of acceleration. One is linear acceleration and the another one is angular acceleration. Right? So for linear acceleration again, we have got two components. Now this is actually something really important. Please understand. This is actually something important. For linear acceleration, now I am summarizing each and everything. It has got two components. And these components are tangential acceleration and centripetal acceleration. The reason that I am writing everything like this is so that you don't get confused with all the things. That sir, what is linear acceleration, what is angular acceleration, what does this thing do, what does that thing do, everything is sorted now. When you are going to talk about how many accelerations are there, now please don't do the vector sum of these two. I am not saying that, right? These are two different types of acceleration acting on a body which is moving in a circular motion. In the linear acceleration, it has got two components. One is tangential acceleration, which is denoted by at, right? Got it? This is denoted by at, and the another one is that is denoted by AC, right? So if we are talking about two types of components, this linear acceleration will be written as A net equals to, doston please see here, A net equals to AT plus AC. That is the vector sum of those two components, AT plus AC, right? For now, let me just complete this topic, this thing over here. So that means A net, the magnitude of net acceleration will be written as under root of AT square plus AC square. So this is something really important. If you want to find out what, I mean, first of all, let me explain it, how we are going to draw it. Is everything okay? Quickly write down in the chat box, then I'll move on. I'll also ask I'll answer some of your doubts if you have any. Quick. Is it making sense? Quickly tell me. All of this is making sense or not? Clear. Fantastic. Good. Getting clear? Great. Good. So now what we are going to say is, sir, please reply, sir, I am from state board, will this lecture help me? Definitely, whether you are from any board, if you have got centripetal, if you have got circular motion, you have got these chapters, obviously it will help you, definitely. Right? All clear? Okay. Now, when we are going to talk about this diagram, let me actually explain it and let me make a new diagram. Let me make a new diagram, something like this. So I've got a body moving in circular motion, and again going to make something like this, Why do I make these? Just so that I make a good diagram, that's it. Okay. Now please hear me. Let's say that this is V, okay, I think there's lots of physics for this board. Let's say this is velocity V. Now if tangential acceleration is increasing the magnitude of it, please understand, we were saying na, that magnitude can change. So again, if magnitude can change, there can be two possibilities, right? There was a long before there was a movie in which he will say ऐसा होगा तो फिर दो बातें हो जाएंगी. So it's like that. After this, again there will be two things. if it is changing, then either it can increase or it can decrease. So if it is increasing, that means that tangential acceleration is in the direction of linear velocity. I'm not speaking any new concept, dosto, right? It's all, this is all has been done, you all know it. I am saying if it is changing and if it is increasing, this means that ad has come, this means that the tangential acceleration is acting in the same direction. So let me make the tangential acceleration with this pink color. This is tangential acceleration. In this case, the magnitude of velocity is increasing. Got it? Other than this, centripetal acceleration always acts. It's no doubt about it. So this is what this is AC, centripetal acceleration. Now the vector sum of these two is going to be in this direction, and this is what I was talking about, that this is the net acceleration that we were aiming to find out. This is net acceleration. What net? Linear acceleration. It has got two components. All right, clear? You can find the theta as well, dosto. Let's say this is angle theta. So tan theta will be equals to, now this is all previous concepts, you can play with it. Theta will be equals to tan inverse AT by AC. Right? Clear? Anything else? Anything else that is being left? If AT is in this direction, net acceleration will be in this direction, and in that case, the speed will decrease, the linear speed will decrease. Alright. So, having said all of this, now the last part that is being left for this one is, if we are going to have some important notes over here, I think I have cleared each and everything. Angular acceleration is also a vector quantity, direction of alpha is also perpendicular to the circle, either parallel or anti-parallel to it, right? If angular speed of the particle is increasing, then alpha is parallel. What do I mean by it, dosto? If let's say angular velocity is in this direction, angular velocity is in direction, no, angular velocity is in this direction, particle is moving in this direction. Are you getting it, dosto? This is not angular velocity, this is the direction of angular velocity. Got it? After it, now again, if this is the direction of angular velocity. Now if this is the direction of angular acceleration, then angular velocity will increase. If this is the direction of angular acceleration, then angular velocity will decrease. Simple thing, right? And having said all of these things, we can also now relate the circular motion with the normal linear motion. What I mean by that is, I can write, so we used to write equation something like this, that V equals to U plus A into T, S equals to U into T plus half A into T square, V square equals to U square plus 2 A into S, right? Also you can write it for the nth formula also. So now what I am going to do is, please quickly write down in the chat box if circular motion is all sorted now for you. In 3 slides I have completed the kinematics portion of circular motion, not the dynamics of circular motion. So instead of V, can I write final angular velocity? I am talking about this is the angular motion, or what you can call as the, I'll just write it as angular, right? So final angular velocity equals to initial angular velocity plus, instead of alpha I'm going to instead of A I'm going to write alpha times T. Instead of displacement, I am going to write angular displacement times angular equals to angular velocity times T plus half alpha times T square. Omega f square equals to omega I square plus 2 times of alpha into theta. Just like this. Clear? Everything's clear? Great, dosto, great. Good. So with this, we can solve some of the questions also, right? Let's not be in hurry. Let's not look at the watch. Let's look at the concepts, right? That's what important is. Let's look at the concepts. So quickly solve this one. Quick. I'll start the polls. Single choice, start poll. Easy. Sir, one mistake. What is one mistake, buddy? Quick. Particles moves in a circle of 0.5 meter at a speed that uniformly increases. Find the angular acceleration if its speed changes. They are saying speed and they are asking angular acceleration, but still it's easy. So first of all, we'll find out the tangential acceleration. Tangential acceleration is dv by dt or del v by del t. You can also, if you're going to talk about again average tangential acceleration. So this will be 4 minus 2 divided by 4, that is 0.5, right? Is that correct? That is 1 by 2. What's going to be the unit? Meter per second square. Now if you are going to talk about alpha is going to be at divided by r, right? So at is 1 by 2 and the radius is 0.5, right? Radius is 0.5, that means this is going to be 1 radian per second square. So 1 radian per second square is option C. C is correct. Let's see. 83.33, not bad. Good. So now let's move to this one. The speed of a particle moving in a circle of radius r with time t as v equals to t square, where t is in seconds and v is in meter per second. Find the radial, tangential and net acceleration. Let's do one question this and then we'll move to the next topic. Is that correct? Everybody is fine? Can we move? Alright. 60 seconds, start poll. Let's start. So you have to find 3 values. First of all, v is equals to t square. So if v is equals to t square, at will be actually 2t. And they are asking at, find the tangential at t equals to, oh sorry. No, sorry. Sir, time, we don't have got time. We don't have time. Yes. Okay, let me figure it out. What time it should be. That's okay. That is a wrong question then. Okay, I'll fix it up. No issues. So at is 2t, right? And alpha is going to be at divided by r. So it's going to be 2t divided by radius, that is 2. So it's going to be equals to t. So AT is 2t and alpha is equals to t, and AC is actually equals to v square by r, and v at any particular time is actually t square. So this is t raised to the power 4 upon r. Now let me check it. First let me check it with, I can see that it is 2 na. I can so what I'll do is I'll check first. Let's check it with 2 seconds. So this is all right. Let's figure it out. This is the answer, by the way. So you can just put the values. So if it is 2, then it is 2 times 2, it is 4. Then this is going to be just 2 radian per second square. So AT will be 4 and alpha will be 2. So that's not a possibility. So this is not 2. But let's not waste our time. I think let's move ahead. It could be anything, right? I think it could be 4 maybe, right? It could be 4. It could be 4. If I last check for 4, then this is going to be 8 meter per second square, because I've got 8 over here, and in that case this is going to be 4 meter per this is going to be 4 radian per second square, and this is going to be 4 raised to the power 4 upon 2, right? So that's 64 divided by 2. Is that correct? No. Whatever that could be, please check the answer. I mean, I don't have time for this one, right? And then net acceleration is going to be, I'll just write each and everything for you. Net acceleration will be, we know what AC is, just add them and find it out, right? So let's move it. No issues with this. So I think it could be A. It could be A, right? Radial, they have first to talk about the radial acceleration. Radius is this. Could be A, maybe, right? Let's move ahead. Let's move. T is equals to 2. Okay, whatever it is, let's move. Now the thing is, let's talk about the circular turnings, which is actually important for your school exams, right? Generally, you must be also knowing that this things comes in your school exams. So this is actually something that is important. Can we start talking about circular turnings? Before that, let me just give you a little bit of idea of, we have talked about centripetal acceleration, right? We have actually discussed this thing in detail, that what do we really mean by centripetal acceleration. This is the centripetal acceleration, right? If there is centripetal acceleration, there must be some force which will provide that acceleration, because of which that acceleration is going to come into picture. So the centripetal acceleration, the force because of which there is acceleration, is known as centripetal force. Right? And the value of that centripetal force is going to be mass of the object times AC, or mv square by r, or m omega square r. Clear? Everything's clear with this one? Yes, Pawan, you can ask your doubt, buddy. Quickly write down. Are you talking about the previous one? Let's leave that. It's just a numerical. I think I have explained each and everything regarding that particular problem. So it's just about time. Timings, I think 2. That's what one of my students is saying. Time is 2, right? So substitute the value of time and find out the answer. Come back to this one. This is actually really important. This is the centripetal force. Now again, we are talking about a basic concept. So please understand. The basic concept is that when we are going to actually talk about let's say circular motion, we haven't actually discussed it, that how the particle is moving in a circle. Okay, there is acceleration acting on it, but how this particle is moving in a circle? So the particle is moving in a circle because some sort of a force. Let me explain it. What's the reason behind it? let's say that I have got a rope like this. Let's suppose I have got a rope, something like this, again just for the sake of scale, and then this is my rope, and at this particular point I am holding it, and there is a stone or there is a mass attached to it. See, right now what do you know what I am trying to do? I have started dynamics of circular motion. Now I have started to talk about mass, now I have started to talk about force. Till now I was talking about the kinematics of the circular motion, right? So now if I am talking about the dynamics of the circular motion, now I am going to ask, are you getting it? How actually beautiful it is, or you might not feel that this is beautiful, but how good this is that till now when we were talking about kinematics, none of you actually asked me, sir, how it is moving, because that's what the role of kinematics is, that's what kinematics means, that we are going to talk about the motion but we aren't going to talk about the cause of motion. Now in dynamics we are going to talk about the cause of motion. So cause of motion is going to be centripetal force, but who is providing that centripetal force? Some force is going to provide that centripetal force. In this case, that's going to be tension. Are you able to understand it? In this particular case, it is going to be tension. So tension will be actually equals to mv square by r, and there is linear velocity in this direction, v. We might think that it is moving with constant speed. Clear? Everything's clear, right? So now we are going to say that in this case it is tension. Let's say that a particle is moving in around a planet. So in that case we are going to say, see how we use the terms. We are going to, in this case we are saying tension is providing the necessary centripetal force. In gravitational we are going to say that gravitational force is providing the centripetal force. So there is going to be always a force which is going to provide the centripetal force. So centripetal force is just a type of a force. Somebody is going to provide it, right? Pawan, mass, I also don't know what's the definition of mass, buddy. Please let's discuss what we are discussing right now, right? So now as I have told you that we have talked about tension, now let me again tell you, and now let me tell you that this is a free body diagram. Is it correct? We are talking about this, let's say this is moving in a horizontal plane, right? And you know what horizontal plane means, right? Like we are just, or horizontal plane or a vertical plane, anything. So this is a free body diagram. The reason that I was saying horizontal plane is I have not drawn the mg right now over here. So this is the free body diagram with respect to the mass. Are you getting it? We are drawing the free body diagram with respect to the mass. If I am going to draw the free body diagram, this is FBD, this is FBD with respect to the ground, not mass. This is FBD with respect to the ground. I will tell you what's the reason. The reason is that the ground is the inertial frame, so that I can apply the equation of kinematics over here, right? Got it? If I am going to not apply this, if I am not going to actually use the FBD with respect to the ground, and I am going to say that let me draw the free body diagram with respect to the body, then see how I am going to draw it. There is going to be velocity, no doubt about it. Now there is tension acting on this body. Yes, absolutely tension is acting, but with respect to the body we are going to make a pseudo force whose value is going to be mass times acceleration, that is v square by r, and the direction is going to be in the opposite direction to which the acceleration is really acting along, right? Got it? So acceleration is acting along this direction, so the pseudo force will act along opposite direction. So this is free body diagram with respect to the body. Now please understand that whenever you are going to refer any book, and sometimes you might see something like this, now you understand that okay, this is actually free body diagram with respect to a body. Why? Because body is right now a non-inertial frame. It is a non-inertial frame right? And ground is an inertial frame. So for inertial frame, we don't have to draw it. We can just write the correct force. We don't have to write the pseudo force. Got it? Everything's clear? Clear, clear, clear? Quickly tell me, now we are coming to the circular turnings. Now we are coming to the circular turnings. Quickly tell me in the chat box, doston, if everything's clear till here. Done? So when we are going to talk about the circular turnings of on roads, let me actually see. It's something like this. Are you able to understand how I am drawing? What we are actually trying to do is, you are actually seeing a top view diagram. In reality, you might see something like this. Now, I might look funny, but I'll just explain it to you. The road, you often have seen the road something like this. Now, it is a flat road. I'm not talking about a banked road, right? I'm talking about a flat road, right? A flat road is looking something like this. So, here's the center of the road. Here is the center of the road. Let's just suppose that there is center. And we are seeing the car. It is a car moving. We are seeing the top view diagram of the car. Everything's okay now, right? Everything's okay. Got it, got it, got it, got it, got it, got it. Please again understand, you might have seen this is a flat road which has got a turn. So it has got a turn something like this. So a car must be traveling something like this and we are seeing it from top, right? So you're going to say to me, sir, if we are judging the motion of this body from the ground, I'm going to say, sir, there is going to be centripetal force acting in this direction. There is going to be centripetal force acting in this direction, and some another force is going to be providing this centripetal force. That's what we are going to say. Is that correct? All right, sir. What I'm going to tell you is, let's suppose we are drawing the free body diagram with respect to the car. So this is a one thumb rule. We are drawing the free body diagram with respect to the car. So what I'm going to do is, if we are drawing free body diagram with respect to the car, and let's suppose at this particular point car is moving with some velocity v, so mv square by r will act on this direction. This is the centrifugal force. I'll write it for you so that you don't get confused. This is a centrifugal force. This is a centrifugal force, right? All right. Acha, there is also friction. Now, try to understand, if the car is moving like this, based on the free body diagram of this car with respect to this car, the friction force will act in this direction. Why is that? There is one reason. I'll tell you that what that reason is. The reason is, first of all, the friction force will resist the tendency of slipping of car. So car has got a tendency to slip outwards of the road. So friction force will act in this direction, or friction force is going to provide that necessary centripetal force. Got it? Friction force is going to provide that necessary centripetal force. So this is the friction force that we are talking about, and let's suppose that this is the maximum value of friction. So what we are going to say is that, so this is the case for a flat road. This is the case for a flat road with friction. Flat road with friction. So I'm going to write that maximum value of friction should be greater than or equals to the mv square by r. So that means mu mg, which is normal reaction, should be greater than or equals to mv square by r, right? So m can be cancelled out. So the maximum value of velocity that a car can safely turn around is mu rg. It is mu rg. So this is the maximum velocity. If let's suppose on this road the coefficient of friction is mu, and the radius is r. So the maximum speed with which the car can take a turn is under root mu rg. That's it. Everything's okay? Quickly write down in the chat box if everything's fine till here. Quick. After this, after having the circular turnings on a road, on a flat road, we are going to talk about the banking, right? We are going to talk about banking. Now, you can now understand this thing. The road was something like this, right? The road was perfectly flat. Now, I am going to turn it like this, right? Now, I am going to turn it something like this. So, this is actually known as banking of road. Why do we use banking? We'll get to see, right? So, now let's talk about the second case, that is the banking of road. So, now to describe that banking, let me draw it like this. I'll explain it. See, now this is the road. This is the road and you are just seeing it, now you are seeing the front view. Are you getting it? You are seeing the front view of the road. This is how the car is going to come. Are you able to understand it now? This is the bank, this was the flat road. Now I would make it bank, the car is moving something like this. Here is the center, right? Here is the center of the circle, of the circular road. Got it? Everything's clear? So now instead of drawing the car, let me just draw the mass. Let me just draw that this is, let's say this is point mass m, right? So this is angle theta. So here I am going to draw mg. Here I am going to draw mg. On this part I am going to draw mg cos theta. Over here I am going to draw mg sin theta. Right? Everything's clear? Clear? Alright. Now please see. Where is the center of the circle, dosto? Center of the circle is somewhere over here, right? Center of the circle is somewhere over here. Are you getting it, right? Center of the circle is over here. So if I have to draw the centrifugal force, so I will draw it over here. That means on this body, the mv square by r will be drawn something like this. mv square by r, something like this. I am not moving fast. You please ask any doubt in the comment section if you have any doubt. Quickly. Quick. No more doubts? Now please see. If this is angle theta, this is also angle theta. Right? So I can I break this mv square by r to this point also? So this will be mv square by r sin theta. Right? Correct? If this is mv square by r, this is theta, this is mv square by r sin theta, you are going to tell me, sir, also draw mv square by r cos theta. I can draw it, but there is really no need of it. I mean, no need of drawing mv square by r sin theta, although you can draw it, it will be somewhere over here only, right? If you have wish, you can just draw it, you can just write it, but we don't have any use of it. I'll tell you. Now please understand. Think like you are in that car. Sit on that car and the car is making a sharp turn of radius r. Over here, this is the car, right? Down the inclined plane, the force is mg sin theta. Is that correct? Down the inclined plane, the force is mg sin theta. Up the inclined plane, the force is mv square by r sin theta. Right? Now please understand the case 1. Case 1 is that if mv square by r sine theta is actually equals to mg sine theta. By the way, are you guys really very good, Shiba? Very good. I was about to tell it. That's what I was saying, that if this is not theta, dosto, this is theta, right? This is theta, so this is theta, so this is going to be cos theta. That was my bad, right? Right? So this is going to be mv square by r cos theta. So m can be cancelled out, all right. Then v square can be written as r g sine theta divided by cos theta. That means this implies that if velocity is under root rg tan theta, then there is no need of friction. Please try to understand this point. I am not saying that this surface is smooth. You might ask me that, sir, isn't friction present over here? Friction is there. But if mg sin theta is equals to mv square by r cos theta, then I'll say that according to this condition, there is no tendency of slipping. There is no tendency of slipping. I mean, there is no tendency for the car to either slide down or slide out of the road. See, two things can happen. This is the road. So either the car can fall down the road, fall down the slope, or it can fall out of the road. Mostly what happens is, usually people out of heat, they drive so fast, they make a turn, and in reality basically topples also happens, and in physics also we discuss topple, but that's not in our course, right? So what happens is that mostly what happens, that speed is so high enough that they fall off the road towards the other side. Got it? So this is how it is. So this is the case 1. Now let's talk about the case 2. So if the car is going to take a turn with a speed of under root of rg tan theta, there is no need for friction. All right. Moving on, case 2. Case 2 is, if mv square or if mg sin theta is greater than mv square by r cos theta. There can be 3 cases, dosto. Show some interest on chat box here. Quick. Am I alone or what? Quick. Is chat working? Yes, it is working. Okay, great. Are you able to understand all of these things? Quickly write down in the chat box. If mg sin theta is greater than mv square by r cos theta, it means that, okay, smell some coffee. Here is, well, I've got a good, it's not coffee, it's tea, but it's good. All right, don't feel sleepy, have some coffee. If mg sin theta is greater than mv square by r cos theta, it means that car has a tendency to slip down the road. Is everything clear? How simple it is, right? Car has a tendency to slip down the road. That means the friction force will act up the road. Here's the friction force will act, and I'll write this thing as F, friction force F. Quick. Done? Now see, then I'm going to say, if I'm going to even decrease my speed, how when a driver is going to fall down, when a car is going to fall down a road, think about it. When the speed is very less, then it will fall down. If the speed is too high, the car will actually fall outwards of the road, right? The car will actually fall in this direction. But right now what we are saying, that speed is not sufficient enough to match mg sin theta. That's why friction is acting on this one. Please give me some thumbs up on this thing if everything's clear over here, because I don't want to just like teach, and if you're not able to understand, then I'll teach again, right? I'll repeat again. Everything's clear? All right. So if friction force is acting in this direction, now I am going to say, if I am going to decrease the speed further, if we are going to decrease the speed further, then what will happen? Then friction will increase. Friction will say, okay, I am here, so if I am here, so there is nothing to worry about. Friction will say that I am here, because of me you will not fall, right? Even you, I know that friction will say that I know you are slowing down and there is a risk of you falling down the inclined plane, down the road, but I am here, so I'll increase my value. So friction force will increase its value. Friction force will increase its value. But again, friction force has got a limitation, right? Friction force has got a limitation. So when friction force is maximum, that is the case when velocity is minimum. You cannot decrease your velocity after this. If you will decrease that, if you decrease the velocity of car after this, friction will say bye bye, tata, goodbye, right? Are you getting it? And what's going to be the case 3? Case 3 is going to be just opposite of this, right? Let's make case 3 as well. And by the way, if you are going to solve this one down, this is going to be this is going to be m. We can cancel out this m, and obviously, I mean, just write it down that v should be less than under root rg tan theta. This is the case. All right. Anamika, we have been doing NCERT question. I had included some of the NCERT question. I still have got some NCERT question, but this is actually the derivation that comes in your exam, right? So it is important for both the students who is in school as well as who is who's appearing for NEET or any sorts of competitive exam in which physics comes, right? So this is important for both of them. So please let me summarize everything. If velocity is under root rg tan theta, there is no need of friction. If velocity is less than under root rg tan theta, then there is a requirement of friction and the friction force will act in the upward direction, right? Then what will happen? What is the minimum velocity? That's another case. We are going to solve it. But not right now. Done. Then next is, let's talk about the case 3. Let's talk about the case 3. So case 3 is when mv square by r cos theta is greater than mg sin theta. So if this is greater than mg sin theta, then the body has got tendency to slip in this direction. Are you getting it? So in that case, I am going to say that the friction force will act in this direction. Clear, right? And that's going to be the case when velocity is actually greater than rg tan theta. let me derive one of the case for the velocity, then the next case I will give you in homework, and please derive it, sincerely derive it with all the honesty, because this is very important. I have done almost everything in this derivation, but I haven't derived the what is going to be the maximum or minimum velocity, right. See, again I will explain it. If you are going to keep on increasing the velocity, if velocity is increasing, then friction will increase, but only up to a maximum value. Are you getting it? So if you are going to keep on increasing the speed, that means we are talking about that those what we can say, the negligent drivers, right. If you are going to keep on increase the speed, friction will say, okay, I am saving your life, right. Your life is pretty much in my hands, I am saving your life, but even if the driver doesn't slow down and he'll again increase the speed after a maximum value, then the car will fall off the road on the other side. Got it? Not towards the center, to outwards of the center. So the answer is, first we have to find out what is this maximum value, what is this minimum value, right, because velocity should be less than, so how much less it should be. Got it, got it, got it, everything's clear till here. So let me just make one of the cases. So let me make the case for anything, let's not worry about that. So this is the body. Now see, what I am going to do now is, now I am going to actually, because I want to find out the mv square, I want to find out the velocity. So now I will actually break the components along these axes. This is actually the pretty much, this is the only way to find out these values. So now what I am going to do is, I am going to say that this is mg. So mg is acting along this direction, that's very good. That's what we wanted, right. I am doing for case 2. Well, both the cases are exactly the same, it's just about a change of inequality, isn't it? So I am doing for case 2, case 3 is in homework, right. What else, dosto? We know that mv square by r is acting in this direction. mv square by r is acting in this direction. All right. Done. In the case 2, do you remember friction was acting in this direction? And this is, by the way, maximum friction. If this is maximum friction, that I am going to write it as just F. But please remember, I am talking about maximum friction, right? And this is the case for the minimum velocity. If you will even decrease the velocity after it, the friction will say, bhai, are you sleeping or what? Press that accelerator, else you will fall down the road. Right? Got it? Done? So we are trying to find out that minimum velocity. What else do we know? We know that there is a normal reaction acting like this. Is that correct? There is mg, there is mv square, there is f. So this is the normal reaction that we have got over here. By the way, this is angle theta. Let me explain this a little bit of trig over here. This is angle theta. If this is angle theta, this is angle theta. That means this is angle 90 minus theta, so that means this is angle theta, right. So this means that this is n, this thing is n sine theta, and this force is n cos theta. Wait. There is something more. We have got friction also. This is angle theta, and usually I always draw friction with this thing so that we don't have any confusion. So this thing is friction. So plus F cos theta, right? We have got F cos theta. Is that correct? Dosto? And then I have got plus f sine theta. I have completed the free body diagram. Now this is the thing. What do you think? If you are able to draw the free body diagram like this, then that means you are prepared for the exam, right? That this means this, that you are prepared for your exam. This is the case, this is the thing that I was saying, that this is really important for everyone. Now obviously if you are doing it the first time, or if you haven't really, if you have thought, okay, friction na, banking road na, that is just for the schools, and what I'll do is before the exam I'll just memorize the formula, I'll put the values and I'll get it. So what's going to happen is, first of all, these formulas are, I mean, these are not that easy to remember. Second of all, although remembering the formula is a good idea any day, but if you are skipping this part, it is going to take a toll on your preparation, right? That is a fact. So don't do that. It will take 3 times, it will take 4 times, it will not take more than 5 times. If you are going to do this derivations 5 times, let's say every day, or let's say every 2 days, after every 2 days, you will just take out a copy and pen, you just try to do it, and you will come back. If you have any doubt, come back to this video. After this, after a time you will get it, right? And after a certain time you will never forget it. So that is the journey that you must travel. Got it? Coming back to the question, after this, please write down in the comment section that if you have got any doubt over here. This was theta, this was theta, this was f, this is f cos theta, this is f sin theta, this is n, this is theta, this is n cos theta, this is n sin theta, this is mg, right? Got it? Sir, when will we get the time to do the derivation for 5 times? You will get the time from taking out, from playing less games, right? So coming back, so according to this, if we have got a stable car, then I am going to say that n cos theta, now I will write the equations. So we are finding for minimum velocity, I will write it as n cos theta plus f sin theta equals to mg, great. This is the first equation that we have got over here, right? Next equation is dosto, what I'll do is, this is the first equation. This is the first equation. Second equation is mv square by r plus f cos theta equals to n sin theta. Instead of that, what I'm going to do is, I'm going to write n sin theta minus f cos theta equals to mv square by r. Is that correct? Is that correct? Quickly tell me in the chat box. Is that correct? Quick. Is that correct? What's the reason behind like writing, see, mv square by r f cos theta equals to n sin theta. So I have said that let's do one thing, let's write n cos theta and sin theta together. Isn't it correct? Now I'll do again one thing. You know what I should do? I should write this line over here. So I'll again write it. I'll write it as n sin theta minus f cos theta equals to mv square by r. And I'll remove this one. So this happens to be my first equation and this my second equation. Quickly tell me if you have any doubt, else we'll move on. Quickly. By the way, the maximum value of friction is, F, and that is actually mu mg cos theta, right? That is actually mu mg cos theta, if everything's clear over here. Now it's just that we have to just divide it, that's all. So let's just divide these two equations. Let's just divide these two equations, like for example as equation 1 divided by equation 2, and then we'll have we'll have tan theta, we'll have minus sorry, let me do it like this, n sin theta minus f cos theta whole divided by n cos theta plus f sin theta equals to, if I'll divide it दोस्तों, m will get cancelled out, this is v square by rg, right? This is the thing that we have got over here, no doubt, very good, very good. This is the equation that you have got over here. There is a little bit of manipulation over here. What's that? Divide everything with cos theta and it makes sense. How? If I'll divide everything with cos theta, I'll get, by the way, दोस्तों, can I write instead of this, see, instead of, if I'll divide everything with cos theta, I'll get n tan theta minus f divided by cos theta, so this is just n plus f tan theta, right? What I was trying to do, I'll tell you, and I've got v square by rg over here. F is nothing but mu mg cos theta, right? And mg is the normal reaction, so again see over here. Obviously it's a big derivation and I am explaining each and every point, that's why it is taking a time. Instead of, I'll write it as just normal reaction, tan theta. Instead of friction force, I'll write minus mu n cos theta divided by n plus mu n cos theta tan theta, right? So now you can also cancel out this n and this, that's how you're going to get your v square from here. Just that, and just write v equals to whatever the answer you're getting, write everything in root form. That's it. Got it? Done? So it was a big derivation, no doubt about it, but we have successfully completed it. All right. Any more doubts? Quickly tell me in the chat box. Everything's clear? Can we move to the next chapter? So case 3 is in homework. The derivation of case 3 is in homework, although I have explained each and everything from that as well, right? I have explained everything, it's just that you have to find out the maximum velocity. So this was the minimum velocity. All right. So this chapter, work, energy, power, in this chapter the main things are potential energy, the main things are work energy theorem, and other than that elastic potential energy and numericals, that's it, right? And obviously the work is actually the simplest of all. So if you are going to talk about this thing, that is, what do you mean by work done, right? What do you mean by work done? So we are going to define it something like this. Let's suppose, and one more thing, the importance that these definitions require, please give them those. I mean, what we call as the due credit, the due importance, not credit, the due importance is very important towards these definitions. It's not about formula, it's not about numericals, it's about the whole thing. Everything is important, right? So let's suppose we have got a body like this and it has got mass m, right? And on this body we are having a force F acting, which is acting at an angle of theta, over here, and the value of this force is F. And because of this force, or I should say because of the component of a force acting along this is actually F cos theta, the body displaces by s meters. The body displaces by s meter. So I am going to say that the work done by the force is the product of force and displacement in the direction of force. Force and displacement in the direction of force, right? So this thing can be written as, work done can be now written as F dot S. So this is about when they are going to tell you that this is the total displacement, that S is the total displacement. And what about if you are going to talk about what's the normal reaction, sir, over here? This is going to be F sin theta. There is going to be mg acting downwards, right? There is going to be mg acting downwards. So the normal reaction in this case is going to be mg minus F sin theta. I mean, right now in work done you are not going to use it, but let's suppose if friction comes into this. If friction comes into this, then what you need to do, you will need to apply also friction force in this direction. So you will say that friction force is, sir, mu into n. So what is n? N is mg minus F sin theta. Just don't remember that n is actually mg. Got it? Got it, right? Everything's clear till here? Or if you are going to talk about a small displacement, then for a small displacement, work done will be written as dw, and that will be written as, if force is constant, F times dx, right? F times dx, or F dx cos theta, F, or I'll just write it as F dr, that would be best, right? F dr, F dot dr, and then if you want to find out the total work done, if you want to find out the total work done is going to be the integral of all the work done and the integral of this thing, that is F dot dr. And from there is going to be certain limits like Ri to Rf, something like this. All right, done. After this, after having work done, we are going to talk about work done by a constant force. I have already discussed what do you mean by work done by constant force. I have got certain important points over here which are very, very important. Again, whenever these types of slides come, tell yourself that these are going to be really, really important for you. The first one says the tension in the string of a simple pendulum is always perpendicular to displacement. So work done is, so work done by the tension is 0. All right. So see, when we were talking about work done was, well, if the force is constant, work done was F dot S, isn't it? So this basically means that we can have 3 cases. What are those 3 cases? Those 3 cases can be positive work done, 0 work done, or negative work done. So we have got like positive work done, 0 work done, or negative work done. So these are some pretty simple things. So positive work done basically means when angle between these two is actually less than 90 degree or an acute angle. If theta is actually equals to 90 degrees, so this is what we are actually right now talking about, that tension thing. And if theta is greater than 90 degree or obtuse angle, then we are going to say that we are talking about a negative work done by the what? By the force, right? So for the case of simple pendulum, let's say this is a case for a simple pendulum. This is a metallic bob kept, that is force is mg, and well, right now it is not at this point. Let's say right now it is at this point. It is swinging, right? And the angle is theta. So tension is T is acting over here, mg is acting at this side, right? If you are going to closely see, this is going to be mg cos theta, this is going to be mg sin theta, this is going to be mg cos theta, this is going to be mg sin theta, and this is the driving force that we usually call, right? This is the driving force, this is the restoring force. This is because of which the pendulum is actually moving. This is which is bringing this pendulum towards its mean position, isn't it? This is the mean position. So this is the force, and right now if you are going to ask me, let's suppose that this pendulum is moving in this direction, right? So right now the displacement is in this direction. Is that correct? Right now the displacement is in this direction. Now tell me, this is the tension that we were talking about. This was the tension that we were talking about. And this is the direction of displacement. What is the angle between tension and displacement? 90 degrees. So work done by tension is 90 degree. Much similar to like every other force. Also, this is the part of circular motion. I mean, not circular motion, but this is a small part, right? A particle which was not able to complete a circular motion. Got it? Now, what we are going to say is this is similar for every circular motion as well. So for any circular motion, I also talked about this thing, that this is, let's suppose velocity is at this point, this is the linear velocity. So this is the direction in which the displacement is taking place, and the centripetal force is acting in this direction. So what is the angle between the centripetal force and displacement? 90 degree. So the centripetal force will do no work done. Now whenever in future you are going to hear about the centripetal force, that some force is providing the centripetal force. Let's suppose somebody says magnetic force is providing a centripetal force on a charge. You are going to talk about in magnetism, right? Or you are going to talk about gravitational force. Gravitational force is providing the necessary centripetal force. Then these forces are not going to do any sort of work done. Work done by these forces is 0. Got it? So work done by centripetal force is 0. Reason is I have already explained it. Work done defined for an interval of displacement, there is no term like instantaneous work done or similar to instantaneous velocity. There is nothing like that. Got it? There is nothing like instantaneous work done or average work done. Well, dosto, I am all good. I am all fine. Let's complete it. For a particular displacement, work done by a force is independent of type of motion, whether it moves with a constant velocity, constant acceleration or retardation. Is that clear? Because work done basically depends on force and displacement. That's it, right? So that's all, and obviously the angle between them. That's also very important. The angle between them. Got it? After this, well, I have got some questions. So, for example, is this one. Let's do some questions. Quick. And I'm going to also start the poll. 60 seconds. Let's start. Just write down the answer in the chat box. The poll will take it from there. See, they are saying that the bike cyclist comes to a skidding stop in 10 meters. During this process, the force on the bicycle due to the road is 200 Newton. And it is directly opposed to the motion, right? So they are basically talking about the friction. So work done by friction is actually 200 Newton times 10 meter times cos 180. So the answer is going to be minus 2000 joules, but the answer is for work done by friction. They are not asking for work done by friction, they are asking for work done by the cycle on the road. Now the road is not moving, although the force is being applied on the road as well. It's something like this. So if you are talking about a cycle like this, so on the cycle the friction force is acting like this, and on the road the friction force is acting like this, right? Got it? But road is not moving, no? There is no displacement for road. So the answer is going to be 0. Got it? Clear? Can we move to the next one? Let's solve this one. For that one, I think the answer was C. Nobody has done C, okay. So, alright, let's move to the next one. quick. Going to start the polls. Quick, quick, quick. This is easy, right? Work done. So work done is basically the integral of f, in this case that would be f dx, right? So force is just acting in x direction, so we have got no problem. So this is from 0 to 2. So this is going to be 0.5 x plus 10, and the integral of this from 0 to 2. So this is going to be 0.5 x square by 2 plus 10x from 0 to 2. So let's just substitute the values over here, right? So this is going to be 1 or what, right? This is going to be 0.5 times 4 divided by 2 plus 20, right? So this is going to be 1. So the final answer is going to be 21 joules. If you have got this one, A is the correct answer. All right, A. Great. Let's move ahead. Kinetic energy and potential energy. All good? All good? All good? Done. So now when we are going to talk about kinetic energy or potential energy or any sort of energy. So the thing is, whenever a force does some work on a body, whenever a work has been done on a body, then that work is converted into or stored into a body, or see, let's not talk about it if it is stored or not. What we are trying to say is that a amount of work done can be, I am saying can be stored in the body in the form of energy. What do you really mean by energy? If a body has got certain energy, we say that it has the ability or it has the capacity to do work. It has the capacity to do work, right? And if let's say a body is moving, if a body is in motion, then the energy that is possessed by a body by virtue of its motion is known as kinetic energy. I'll again repeat it. If a body is moving, if let's say suppose you have done some work done and the body is started to move, then the energy that is possessed by the body due to its motion is known as kinetic energy. So if a body is moving at a particular point, when it has got a velocity of v, velocity is v square is just speed, and it has got mass, then kinetic energy is half mv square. So kinetic energy is the most easiest thing to understand. Nothing really difficult about it. Got it? And SI unit is going to be again joules, scalar quantity, work done was also scalar quantity. By the way, what the dimensional formula of all of those things, figure it out, quickly do it, right? When we are going to talk about potential energy, that is actually quite important. Potential energy is not as simple as kinetic energy, right? There is there are a lot of things about potential energy. Thank you so much. Thank you. First of all, first point is that potential energy is only associated with conservative forces, Now this is a new thing, that what do we really mean by conservative force. What do we really mean by conservative forces? Right? So let me explain in the simplest of the terms, right? Conservative force means that if you are going to do work, when I say you, I mean to say the external force. When an external force is going to do work against these conservative forces, then the work done will be stored in the form of potential energy. That work done is completely recoverable. We can recover that work done, right? Are you getting it? See, I am not saying that if it is a non-conservative force, the energy is destroyed. The energy is dissipated. For example, is friction. So let's consider for some conservative forces. Let's discuss some conservative forces. So some of the conservative forces that we have got over here is, well, these are, first of all, we are going to start with spring force. Spring force is a conservative force, and it is quite easy to understand. If you stretch a spring, you have the external force have done a work, and that work is converted into the elastic potential energy, and that work done we can recover that much work, right? Are you getting it? Or gravitational potential energy. Gravitational force. Right now I am talking about conservative force, that is gravitational force, or spring force, gravitational force. We can talk about many other force, gravitation, electrostatics force. Right? There are many more ways to define conservative force. The best way is that conservative force is actually a force we are going to write that if the work done against a conservative force is recoverable. And there are more things, like for example, as it is what we can say is that it is path independent. It is not path dependent, it is path independent, right? I'll explain it. I'll explain each things over here. Let's start about potential energy. Very important topic. It is very important for your basic concepts, right? What happens is that students actually move to grade 12, they move to their drop year, but their basic concepts about potential energy is not clear. Now, how you're going to actually able to solve different chapters, like for example, you have got electrostatics potential energy, then you have got elastic potential energy, then you have got gravitational potential energy. So it is a recurring topic. Now, if your concept is not clear for a potential energy, a problem will arise. The problem will also be recurring, right? So let's finish it. So when we are going to talk about potential energy, let's take an example of gravitational potential energy, or let's take an example of elastic. I'll give both. So if we are going to talk about example, gravitational potential energy, let's find it out. Let's say that we have got, this is a ground, we have got a block of mass m, right? We have got a block of mass m and force mg is acting downwards. Alright, this is force mg, this is the gravitational force that I am talking about. Now, what I am going to say is, let's say there is an external force acting over here. This is an external force. Alright, done. I'll explain the work energy theorem in the easiest way. Just stay for the whole lecture, but work energy theorem is going to get started in less than 10 minutes, right? So this is the external force, and this is let's say this is actually equals to mg. Now many students actually, after this, many students have this doubt, sir, if this is mg, this is actually not going to move. Please understand that when I am saying that we are actually moving it up, and when I say that we are moving it up to a height of h, and we are moving it this block to, let's say, this height, right? Then many students think that how are you going to lift this block if you are going to apply a constant force, sorry, an equal force of mg. So I'll answer it, right, because this is a common question amongst students. First of all, dosto, if I'm going to apply a greater force than mg, that means this body is going to accelerate. That means this body will also have kinetic energy, and what I want is I want to find out the potential energy. So what I say is we apply an mg force, and it loses the contact. When we are going to apply the mg force, it will lose the contact, and we are going to say that we are moving it upwards. We are moving the block upwards with infinitely small speed. That's very important to say, right? After this, if I'm going to tell you that what is the work done by external force, so you are going to tell me a simple thing, sir, work done by external force is mg acting upwards, displacement is acting upwards, and that is mgh. That is mgh, right? Got it? Everything's clear? Hi Kevin. Hi. All right. So work done by external force is mgh. Well, thank you for all the compliments. Thank you so much. Let's get back. Work done by external force is mgh. This work done will get stored in the body. This work done will get stored in the body, in the form of gravitational potential energy. Now hear me out. The thing is, if I said to you that let's suppose I'm choosing a different path, and that different path is, right now I actually chose a path which was something like this, a straight line, right? Next is I'm choosing a path something like this. The body is moving, it has moved something like this, then the body has moved something like this. After this, the final position is this one. Do you remember something like this you have learnt in the grade 9th, that still the work done by the external force will be mgh, because easy thing, there is no work done in the lateral displacement, because displacement is in this direction and the external force is acting over here. So at least this external force is not doing any work. We are not concerned with any other forces. This external force is not doing any work. Is that correct? After this, what I am going to say is that let's take any other path. So if you are going to talk about any other path, these were two paths, the third path can be this, the fourth path can be this. So for every other path, the work done is going to be just mgh. That means if I am going to say that, let's say this is a reference point, and over here I am choosing the potential energy of the body to be 0, and at this particular point it is becoming mgh. So for every path the work done is same. That's why we have written that it is it is path independent. Got it? It is path independent, right? After this we are going to state one more important fact, and that is, what about work done by mg force, because mg is actually the conservative force that we are talking about. All right. Clear? Everything's clear? Quickly write down in the chat box. So work done by mg will be, mg is acting downwards, displacement is in the upward direction, so we are going to write a negative sign. So this is going to be minus mgh. Minus mgh. Got it? So now this thing can be actually written as change in potential energy, and if you are going to closely see, I am going to write it over here. I am going to write that work done by a conservative force is equals to negative times of change in potential energy, delta minus delta U. Delta U is change in potential energy. How? See, change in potential energy is final potential energy, that is mgh, minus initial potential energy which was assumed to be 0, which is mgh. So that is minus times of mgh. This is the most important thing. Are you getting it? Clear? Everything's clear? For conservative force, this is the most important thing. If you are not able to understand this thing, when we are going to talk about work energy theorem, there will be some problem, right? Because this is very important. Same thing will happen for the elastic force also. For elastic force, now I am not going to draw each and everything, it will take too long. But for the elastic potential energy, you know that the total work done will be actually, total work done by what dosto? Total work done by external force will be kx times dx, and let's say the extension has been from natural length to some extension x, right? So this will be half kx square. So this is the potential energy, right? This is the elastic potential energy that we are talking about, half kx square. Done? Quickly write down in the chat box if everything's clear. Do I need to draw the diagram for elastic potential energy? Alright, now let's start the work energy theorem. Let's talk about the work energy theorem, right? First, tell me if everything's clear, then I'll move on. Quick. Everything's clear till now? Alright. Done. So let's suppose now we are saying that we have got a body on which an external force is being applied, a net force, right? On this body we have got a net force is being applied on it. And I am not saying an external force, I am saying net force, right? So the work done by this net force will be actually written as F net dot dx. This is actually F net, and let's suppose the magnitude of this force is F. Alright, magnitude of this force is F. Yes, important part. It has started now. Can I write, instead of force, can I write it as mass times acceleration? Can I write it as mass times acceleration? Right? I can write it as mass times acceleration, right? Times dx. And I actually, this is something that I told you when we were talking about kinematics, that acceleration can be written as v times dv by dx, isn't it? V times dv by dx. Do you remember this thing? So let's put the value of this acceleration over here. It's not a value, it's an expression. So m times v dv by dx times dx. Let's not cancel them out. This thing will become m times v times dv. And now we are going to integrate it, let's say, from initial velocity u to final velocity v. Is that correct? From initial velocity u to final velocity v. What are we going to get? We are going to get work done by the net force is going to be m integration of v with respect to v, it's going to be v square by 2. So half m v square from u to v, and we are going to get half m V square minus half mu square. You have, this is your work energy theorem, that work done by net force is equals to change in kinetic energy, right? Just take a look. I'll change the slide. Everything's clear. Hopefully everything's clear. Derivation is important for your school exams. For your midterm exams, derivation is also important for a better understanding of this concept, right? Moving on. So what I have written is, I have written that work done by a net force, by the net force, is actually equals to change in kinetic energy. That's what we have written. This is very, very important. Is that correct? Now what is this net force? That is the point. Do you remember, I didn't wrote it as external force. I wrote it as net force. I have written it as net force because work done by net force basically means that we are talking about all sorts of force. That means work done by external force obviously, plus work done by conservative force, plus work done by non-conservative force, plus work done by internal force. Every type of force I have written it as net force, right? That net force, inside that net force everything has been covered. Now try to understand that usually what happens. Usually if let's suppose there is, I am going to take some cases. The case is, let's say if this is the case, I am going to say if there is no internal force, there is no non-conservative force, these are all, if these things are 0, I am taking these as cases. Okay? Then after this what I am going to do? I am going to say, okay, we have got external force, we have got conservative force, and these two are 0. And we know one more thing, just now we have done it, that we also know that work done by conservative force is actually equals to minus times of delta U, isn't it? That is change in potential energy, right? So now I am going to rewrite the equation something like this. I am going to write that work done by external force plus work done by conservative force. Instead of writing conservative force, I will write it as negative times of change in potential energy equals to change in kinetic energy. So therefore the work done by external force will come out to be change in kinetic energy plus change in potential energy, and this is your energy conservation. Alright, this is the energy conservation that we often talk about. So energy conservation is only talked when we don't have any dissipative forces, when we don't have any non-conservative forces. So if you have got non-conservative forces, you can't say that the energy is conserved. Then we are going to say that the energy has been lost. We don't have an account of it. Like for example, as heat, energy is lost in heat, energy is lost in light as light energy. So we don't have account for all of those things. So this is the conservation of energy. All right, done. And what was the other case? The other case is if we have got everything over here. The other case, if these are not 0, so usually internal force is 0. So we are going to write that work done by external force plus work done by conservative force. So for conservative force, I can rewrite that thing. So plus work done by non-conservative force is equals to change in kinetic energy plus change in potential energy. That's it. This is your work energy theorem, and now I am going to give you my trick for it, right? And what's the trick? My trick is I am going to explain it using a question. So we have got a question as well over here, right? We have got a question. The question says an object of mass 5 kg falls from rest through a vertical distance of 20 meter and attains a speed of 10 meter per second. See what the question is about. we have got a body which is an object of mass 5 kg, 5 kg that falls from rest. So this is at rest and this is at actually at a height of 20 meters, right? So this is at a height of 20 meters. So this means that at this particular point it has got gravitational potential energy as mgh, that is 5 times g times h, and that is going to be, this is going to be dosto, this is 200 times, this is 1000 joules, 1000 joules of energy that we have got over here, correct, right? Now see, what's my trick? Now they are saying how much work is done by the resistance of the air on the object if it attains a velocity of 10 meter per second. An object falls from a rest through a vertical distance of 20 meter, and so let's suppose that this is not the ground. Let's suppose this is not the ground. Ground is somewhere over here, but at this particular point we are talking about it, right? And at this point the particle has gained 20 meter per second of velocity. Are you ready for the trick? Alright. See, whenever, money trick, yes, whenever they said that this is the initial condition of the body, just write the total energy that the body has got. Just like, let's suppose you have got 1000 rupees. You have got 1000 rupees in for you. You have 1000 rupees in your wallet. Now you have got some expenses. What are those expenses? Let's write them down. What are those expenses? So, and see, so when we have got some rupees, some of them are expenses and some of them are investment. But in and all, we just spend our money and we buy something, isn't it? So right now I have got gravitational potential energy. This is my total money. Besides this, I don't have anything. Got it? After this, at this particular point, what I am going to say is that at this particular point, I have got kinetic energy. I have got kinetic energy. And by the way, the money that I have got over here, I am writing this as this, I am assuming this to be ground. So that was actually right to assume that this is at ground. Kinetic energy plus work done by the resistive forces. And what are those resistive forces? That means the resistance of the air. Because this is my expense and this is my investment. Right? Are you getting it what I am trying to say? So work done by the resistive forces will be equals to 1000 minus half m, what is mass? Mass is 5 kg times what is V base square of 20, that is 400, right? This will be 20. Everything's clear? Have we done anything wrong? Quickly see. Quick. Half m V square. I think everything's correct. How much work is done by the resistance, right? Hopefully we have done everything correct. There is nothing that we are missing. You tell me in the chat box if you have got any problem. Yes, everything's correct. MGH is absolutely correct. V is 10. V is 10. V is 10. That's what the problem is, dosto. V is 10. I wrote that. The board is shining, right? So this is 10 meter per second. This is 10 meter per second. Trick is all good, dosto. Don't have a doubt on my trick. So this is actually square of 10, right? So if it is square of 10, this will be actually 50. So this will be 250. So this will be 750. So this is 750 joules, right? Now the work done by the resistance force on the object. So the object is falling down and the air friction will act upwards. So it will be minus 750 joules. it will be minus 750 joules. Done? Everything's clear till here? Quickly tell me. Quick. No. Against means it's not negative. The body is falling down, air resistance is acting upwards, it is moving down, so the work done will be negative. That's it. Let's look at the another question. We must have got another question over here. See this. We have got a body which has got mass of 0.5 kg that is moving with 1.5 meter per second, and it collides with a nearly weightless spring of constant 50 Newton per meter. What is the maximum compression? Again let me explain it using the trick. At this particular point, write all the energies that body has. It is only kinetic energy, body has got only kinetic energy. This is the total money that you have got. That is half m, what is m? 1.5 times v square, right? No, we did it, no, I didn't start the poll. So times v square, by the way, v square is 1.5, mass is 0.5. So mass is 0.5 times speed is 1.5. So this is the total amount of money that we have got, right? All right. Well, just let me just solve this one. This is the total amount of money that I've got, and there is no friction. So I'm going to say that the total kinetic energy will get converted into, or what I'll say is, I'll use the work. See, there's work energy theorem and my trick are same thing. Work energy theorem says work done by the external force, by the conservative force, by the non-conservative force, everything that is actually equals to change in kinetic energy plus change in potential energy, right? So there is no external force, nothing as such, right? So that means change in kinetic energy will be equals to negative times of change in potential energy. So change in kinetic energy is what? Half mv square minus 0 equals to negative times of final potential energy is actually equals to half kx square xm square minus 0. And please understand why we are writing it like this. The answer is that when the spring is going to be at the maximum compression, when the spring will be maximum compressed, at that particular point the block will be at rest. Got it? And now you can do it in the otherwise also, that you have got this is the total amount of money, and all of this will be converted into the elastic potential energy. So you can directly find it out. So find it out. This is your homework, right? Got it? Done? All right, let's move ahead. So I have completed this thing also, right? After this, let's move to a motion in a vertical circle. Now tell me how many of you are still following it. Acha, let me explain one more example for work energy theorem. For work energy theorem, it could be something like this. Let's suppose there is a spring in its natural length, a box is moving towards it with, let's say, velocity v, and we have got friction also over here, right? We have got friction also over here. Now what I am going to say, the total money that I have got right now is kinetic energy. It will be spent into two things. One is half kxm square, that is the maximum compression when it will come to rest, plus work done by friction. This is also an expense. Is that correct? Now let's talk about vertical circle, दोस्तों. we have got some time. It's not, still it's not 12. Still it's not 12. See, what do you mean by vertical circle? I'll explain it to you. Let's suppose that we have got a rope and we have tied a stone to it and we are circling like this. This is a horizontal circle, right? This is a vertical circle. Are you getting it? This is a vertical circle, right? So for a case of a vertical circle, we are going to say that there are going to be 3 cases possible. Those 3 cases are, and again I'll do one thing. I'll do one thing. I'll derive one and I'll give you homework, the other ones. You do it in homework. If you have any doubt, ask in the comment section. I'll come back to the comment section afterwards. Alright, I'll do that. So let's suppose what we are trying to say is that we have got a rope attached over here. Rope is attached to this point and there is a particle of mass m. All good, right? We have given a velocity at this particular point. We have given a velocity at this particular point. Let's say this velocity is v or this velocity is u. Clear? Please get back. It's not, see, you know what happens? What's the difference between a person who's going to have marks something like 170 out of 180 or 180 out of 180 in physics NEET. The only difference is you actually, if you are able to solve, like, let's say 10 derivations very easily, then you will take a break and you will give yourself a gift, a reward. That's how the human brain works. If you do something good, instantly you give yourself a reward, and that reward might be a music break, a snacking break, a TV break, a video game break, right? But a person who's really driven towards getting into a best of the best college, he or she will do, okay, I have done 10 but still I have got 30 more. That's the problem. So I've completed less than 50%. So I'm not demoralizing you, but have that mindset if you want to get into one of the best college, right? So still till I am teaching, I want your concentration over here. All right. We have got mass m, we have got a rope attached to this point. At this particular point, there is velocity u. Got it? Then what we are trying to say is here are the 3 cases. The 3 cases are, one of the first cases that, and this is actually why I'm deriving this, is because this is most commonly used and most asked question in all sorts of exam. This is when this particle is going to complete the circle. This is the thing, that tell me the minimum velocity of this particle at this point, so that this particle completes the circle, completes the loop. So this is the first case. Case 1, that particle completes the loop. Particle completes the loop. Alright. And what are the other 2 cases? The other 2 cases are, first one is the particle will actually, we have thrown a particle, let's suppose that it reaches at this point. Let's suppose it reaches this point and it falls back and it starts to swing like a pendulum. It starts to swing like a pendulum, right? The another case is it clears this point and it reaches at this point and then it falls back. That means it clears this quarter circle but is not able to complete the loop. So are you able to understand the 3 cases? The first case is that it clears the circle, the second case it swings like a pendulum, the third case is it's clear this point but it is not able to complete the circle, so it will fall after this point. Got it? Everything's clear? Now see, I'm going to actually draw a general case for all of you. So this is a general case, I'm not talking about that pendulum case. So this angle is theta. This particle is, this initial velocity is u. At this particular point it has got velocity as v, right? What do we know till here? This distance is actually radius, right? Doston, this distance is radius, and what is this distance? If I'm going to ask you, that what is this distance? This distance, this is r cos theta. Please write down in the comment section, chat box. This distance from here till here, it is r cos theta, because this is radius, so this is r. So the base is going to be r cos theta. If base is r cos theta, that means this thing is going to be r minus r cos theta. It means that it can be written as r into 1 minus cos theta. Why we are doing it? We are doing it because at this particular point, the particle has gained some potential energy, and that potential energy will be written as mgh. So we must know what this h is, right? This is that h, na? So that h is r into 1 minus cos theta. Got it? Please quickly write down in the chat box if everything's clear till here. Right? And one more thing, if this is mg, then this is going to be mg cos theta. This is going to be mg cos theta. Do I have a need to draw mg sin theta? No. Alright. This is mg cos theta. This is tension T. What else? What else are we missing? We are missing the centrifugal force, because right now I have been drawing these diagrams with respect to the body. So if we are going to draw with respect to the body, the centrifugal force will be drawn something like this, and I will write it something like this, that this is mv square by r. Please write down in the chat box if you have any doubt. What about centrifugal? That's what. Good, good, good. So we have written it outwards to the center. Is that correct? Why? Because we are drawing the free body diagram with respect to the particle. If in any book you are going to see that there is force, this force is written in this direction, that means they are drawing the free body diagram with respect to ground, nothing else. Now see how many equations I can write. I can, first of all, I am going to write that tension will be written as mg cos theta plus mv square by r. That's how we are going to write tension. This is one of the first thing. There are many ways of deriving it. What I feel is the best way to derive this equation, these types of questions, is use the kinematics also. How to use kinematics? What I am going to tell you is that, or you can use the work energy theorem also, right? It's up to you. What I am going to say is, if you are going to use the kinematics over here, I am going to write that v square equals to u square minus 2gh. This is something that we can write, right? This is something, these are the two equations that you are going to use most often. So please make a note of it. All right, done. After this, what I am going to say to you, that the first case was that the particle completes the circle. Now, can anyone tell me in the chat box that what do we really mean by that particle completes the circle or particle completes the loop? What do we mean by this? What do we really mean when we say that particle completes the loop? It means that at the highest point also, when the particle has reached the highest point also, when the particle has reached the highest point, at this particular point, the mg was acting downwards, the tension was acting downwards, and mv square by r was acting in this direction. At the highest point, if I will say that tension is not zero, that tension is not zero at or before highest point, Please try to understand this concept. This is the only concept that's important. If at the highest point also the tension is not 0 or before it is not 0, then the particle will complete the circle. What happens if the tension becomes 0? The string will slack and the particle will fall down. It's tension because of which the particle is moving, right? I mean tension and mg cos theta up to this point, right? Clear? So if tension is not 0 up until the topmost point, then we are going to say that particle will complete the circle. So at the topmost point I am going to say that at theta equals to pi, that is we are talking about the highest point, I am going to say that let's suppose at the highest point tension becomes 0. There is a difference, don't get confused. At the highest point also if the tension will become 0, then what will happen? Due to inertia it will fall back and it will complete the circle, right? So I am going to substitute this thing as 0, this thing is going to be mg cos pi, and this is going to be plus m v square by r. Doston, this v is this velocity, not this velocity. Over here we have also got velocity, na? So this is that v. Is it all good? Is it all good? Is it all good? Right? Clear? So mg cos pi is minus 1. So that means we will write it as mg equals to mv square by r. So that means m and m can be cancelled out. From here we will derive it that the energy at the topmost point, that is the velocity at the topmost point is under root rg. This is under root rg. So this is under root rg. But hang on, we wanted to know what this is going to be. So just find it out. Either use energy conservation or you use kinematics. It basically the same thing, right? Use this equation. So now we want to find out the u minimum, because we know that what is v minimum. So u minimum square is going to be v square plus 2gh. It is so simple. V square is rg plus 2gh is 2r. H is 2r obviously. So let me write also 2r. So that means this will become 5 rg and v minimum will be under root 5 rg, and this is by the way u minimum. So this is u minimum. This is your answer for the first derivation, right? So the u minimum must be under root 5 rg, and you must remember all of these things, right? Got it? Please quickly tell me in the chat box, in the live chat box, quickly say if everything's clear till here. Is it good? Clear? Now for the other two cases, as I have told you, do it in homework. We'll move on, right? The other two cases are, so I have completed the first one, that the particle completes the loop. So this is the minimum velocity. That means if u is greater than under root 5 gr, then the velocity will be the particle will complete the circle and the velocity will also be greater at the highest point, right? After that, if the particle is leaving the circle. So particle is leaving the circle basically means that something like this is happening. I'll also explain that how it is possible. This is possible when velocity becomes 0. Tension becomes 0. Tension becomes 0 before velocity becomes 0. It might sound a little silly, but this is exactly what's happening. At this particular point, still the particle has certain velocity, but tension becomes 0. So if tension becomes 0, what will happen after this? The particle will actually follow a parabolic path, something like this. It will be a projectile motion after that, and many questions comes that it reaches to a height h, after that it leaves the circle. So find out this velocity. This is the velocity that you want to find out. After this, apply the projectile motion for the competitive exams, I'm telling. All right, clear? Everything's clear? So this is the case. By the way, this is going to be the, for condition of leaving circle is less than under root 5 gr but greater than under root 2 gr. This is actually very important. And if the velocity is even smaller than this, then we are going to say that it will actually swing like a pendulum. Then we are going to say that now velocity becomes 0 first. Velocity becomes 0 before tension. This is the case. See, velocity becomes 0 but still there is tension, so it will swing. All right. So, although I have some questions, but what I'll do is I'll give you some in homework. Let's solve this one in homework for you and write down your answers in the comment section, right? Do that. Write down the answers in the comment sections. All right. For now, let's move to the collision concept. Let's move to the collision. And with this, we'll complete work per energy. With this, we are going to complete. No, it is not escape velocity, and the escape velocity is related with gravitation, not over here. So now, when we are going to talk about collision, first of all, it is related with, first we must understand what do we really mean by impulse and collision in one dimensions. Now, so see how the collisions in one dimensions are happening. I am drawing ground over here, although ground is not necessary. Let's suppose we have got two bodies. Two bodies, something like this, and they are moving it in this direction. So let's say this is body A, this is body B, this is initial velocity UA, this is initial velocity UB, and for collision it is very necessary that UA must be greater than UB, right? So some of the easier some of the most basic things about collisions, I am going to start it, and then there's nothing really difficult about collision, especially for one dimension. First of all, why it is known as collision in one dimension? The reason that this is called as collision in one dimension is this situation was before the collision. This situation was before collision, right? Now let's talk about during collision. So if you are going to talk about during collision, let's say again we have got two bodies, but now the bodies are something like this, that during collision what will happen, that for momentarily they will actually deform. Something like this. So this is your body A, this is your body B, and this is the direction in which body A is imparting impulse on B, that is it is applying impulse on B. So we are just going to write it as F force on B due to A, and this is the force on A due to B, right? Now why it is known as one dimension? The reason is the direction in which they are imparting impulse, the force that they are exchanging, this direction is actually known as line of impact. Please understand, this direction is known as line of impact. along which they impart impulse or force, right? Good morning, good morning. All right, 8 hours complete, no worries. Still we have got collision left, right? No worries. So if both the bodies have the velocities along the line of impact, see what's the point. We have got UA and UB, both of the velocities of the bodies are along the line of impact. That's why it is known as collision in one dimension. If any one of them has any of the velocity or any of the component of velocity, right, any of the component of velocity which is not along the line of impact, that will be called as oblique collision or collision in two dimensions, right? Easy things. It's not that difficult. The only thing is, if you have got forces along this axis, only the velocities which are along this axis will get changed. If you have got any velocity which is perpendicular to this line of impact, that will not be changed. Why? Because of course we have studied it, forces can't change the velocities which are perpendicular to them, right? So with this, now we are going to talk about types of collision. So when we are going to talk about types of collision, I think I've got it over here, that collisions are classified on the basis of impact. So it's not like everything I have to write. I have got some notes over here. We can take some help of this. First of all, we are going to divide the types of the collision on the basis of the line of impact. I have told you. So first one is head-on collision. So these are also known as head-on collisions, right? These are also known as head-on collisions. So if the velocities of all the colliding particles are along the same line before and after the collision, this is also a case. So does it make sense? Is it exactly the same thing that I was saying? Yes, because if you have got, this is the line of impact, these forces are just going to increase or decrease the velocities in magnitude. It's not going to change the direction, it can't, right? And what about oblique one? If the velocities of the colliding particles are along the different lines before and after the collision, that is an oblique collision, right? Next one, on the basis of energy. So for elastic collision is that collision when the energy is conserved, when the particles collide and they regain their shape and size. So there is no dissipation of energy in form of, what we can say, in form of deformation energy. The particles are not getting deformed, right? So this is what is called as elastic collision. Please understand, when we are going to talk about collisions, the net force acting on the particles, the net force acting on this system is 0. Is that correct? Well, there is FBA acting in this one, there is FAB acting in this one. They are action reaction pair, their magnitudes are equal, they are acting in the opposite direction. So that means the net force is 0. So if net force is 0, it means that the momentum of the system is the total momentum of the system is conserved or constant. So momentum is always conserved, no matter what type of collision you are going to talk about. No matter what type of collision you are going to talk about, momentum is always conserved. So in the first one also, elastic, it is obviously momentum is conserved. Along with momentum, energy is also conserved, right? So no fraction of mechanical energy remains. What do you mean by mechanical energy? Sum of kinetic and sum of potential energy. No fraction of mechanical energy stored as deformation potential energy in the bodies. Thus kinetic energy of system after collision is equal to the kinetic energy of system before the collision. E equals to 1. What is this E? E is, by the way, this might not be in NCERT. E is known as coefficient of restitution. E is known as coefficient of restitution. So this is actually velocity of separation divided by velocity of approach. So this is a very important thing. If you are going to talk about elastic collision, E is going to be 1, right? E will be 1. After this, it's inelastic collision. So for inelastic collision, as you can assume that over here only momentum will be conserved, only the momentum of the system is conserved and the energy is not conserved. Why is that? Because some amount of mechanical energy is being wasted, or it's being used in changing the shape and size of the body. That is the deformation energy, and we don't have an account of that, right? Some fraction of mechanical energy is retained by the colliding particles in the form of deformation potential energy. Thus, the kinetic energy of the particles no longer remains conserved, right? In this one, energy of restitution, coefficient of restitution is between 0 and 1. This means that velocity of separation is less than the velocity of approach. Quickly write down in the comment section, chat, quick chat, tell me if everything's going good till here. Quickly tell me in the chat box if everything's going good till here. Are we in the right direction? Can we rewrite everything that we have got over here? Shall I rewrite the equations over here? What do you mean by this? Let's suppose this is before collision, this is during collision, and let's say this is after collision. Let's suppose this is the case for after collision. That after collision, these particles are going to have velocities as VA. Now I'm not suggesting that they are in a particular direction. I'm just writing it could be in any direction. I'm just writing it is VA, it is VB. These are this is VA, this is VB, right? So the momentum conservation, that's applicable always. It will be written as initial momentum of the system, mass of A times velocity of A. Velocities will be put with sign. So if you are taking this as a positive sign, both of these velocities will be put with the positive sign, right? So MA plus UA plus MB times UB equals to MA times final velocity VA plus MB times VB. So this is applicable and this is always applicable, right? This is always applicable. You can write this equation always. What about A? Coefficient of restitution, दोस्तों, coefficient of restitution in this particular case is velocity of separation, the velocity with which they are separating. So that is actually VB minus VA. And what is the velocity of approach? So velocity of approach is actually UA minus UB. This is coefficient of restitution. This is another information. So for elastic collision, you have got information as E is also 1, right? Although you don't have any problem with the elastic collision. Other than that, this is conservation of momentum. This is conservation of linear momentum. And then we have got something that is called as conservation of energy also. Conservation of mechanical energy. Why? Because we are talking about elastic collision right now. If you are going to talk about inelastic collision, you cannot write conservation energy equation, right? This will be written as half MA UA square plus half MBUB square equals to half MA VA square plus half MB VB square. That's it, right? Now please hold on. Are we going to write all of these equations in exams? No. So we have some short formulas for these. Now this is your homework. Find out the equations for VA and VB in terms of UA and UB using these three equations 1, 2 and 3, right? Find it out for both elastic collision and inelastic collision. For inelastic collision, don't use this equation, just use this equation and this equation, right? So this is your homework. All right. Other than this, I have explained each thing over here. Completed. Collision in one dimension is completed. There is one special type of collision that is known as perfectly inelastic. What happens with perfectly inelastic collision? For perfectly inelastic collision, after the collision, the bodies get combined. They get stick with one another, right? They get sticked with one another. So now what we are going to say that they have got a common velocity. So writing an equation is very easy. So we are going to write ma ua plus mb ub, because initially they were moving, right, equals to ma plus mb times u times v, that is the common velocity. All right, that is E will be 0 because there is no velocity of separation. Coefficient of restitution will be 0. Done? Everything's clear? Quickly tell me in the chat box. Now let's talk about oblique collision. Then we are going to start the last chapter. Then we have got also units and dimension. And then we'll end the class. Will that work? Will that work? Quickly write down in the chat box. Will that work? Oblique collision. All right, all right. So I think there's something else written over here. No issues. I'll take another slide and I'll explain what do we really mean by oblique collision. Oblique collision basically means, let's say that we have got a body which is moving in this direction, and we have got another body somewhere over here. Something like this, right? And this body right now it is at, let's suppose it is at rest, right? It is at rest or it can move. What I really mean is when they are going to collide, I am going to actually make them collide for you. So for that I am going to remove this thing. I am going to make them collide. So that's how they are going to collide, the collision, right? Then this is the line of impact along which they are going to share the, this is the line of impact that I was talking about, right? This is the line of impact. Now they might have velocities in different directions. If they have velocities in this direction, dosto, if they have velocities, if they were moving like this was moving like this, and this velocity, this particle was moving like this, then we don't have any problem. This was a one-dimensional motion. But what we have over here is that let's suppose that this particle is moving towards this direction, right, and this particle is moving something like this, in this direction. All right. So this is the case. So let's say this is UA, let's say this is UB. This is the case for the oblique collision, right? Now what we are going to do is we are going to just say one thing. We are going to actually find the components of these velocities along the line of impact, right? So only the velocities, please understand, only the velocities or only the component of velocities, components of velocities which are along the line of impact, will get changed, right? And the velocities which are perpendicular to the line of impact, they will remain constant. Other than that, everything is similar. I mean, again, we are going to talk about the same equation, same momentum and everything else. Now quickly write down in the comment section, can we start the new chapter? Do you want 1 minute break? How many of you are still present? Give me some attendance. How many of Yakin NEET are present over here? Quick. Yakin NEET English batch. Okay, Ramya, good. Mishti, good. Great. Kirti, good. Thank you, Rupreksha. Hi, Kunal. Hi, Shiba. Hi, Kevin. Hi, Sandy. Hi, Karuna. All right, Rupreksha. Good, good, good. Subhash is also here. Great. All right. Kunal, you're still here. Good. Great. Now we are going to start motion of system of particles and rigid body. Again, we are going to talk about two chapters in this one. One is center of mass, the other part is going to be rotational motion, right? Now, first of all, what do we really mean by center of mass, right? And there is also something called as center of gravity. In our class also we were about to discuss it, but I think we were not able to discuss it. So let's first define center of mass. So center of mass can be defined as that it is the point, it is the point where the entire mass of the body or system of particles is supposed to be concentrated. Alright, done. So after this we are going to actually find out the center of mass of different types of body. So first we are going to talk about center of mass of discrete particles, that is system of discrete particles. What do you mean by discrete particles, by the way? So discrete particles basically means that we are going to talk about point masses. Point masses basically means that let's suppose I have got 1 kg over here. So this 1 kg is actually at a specific location. This 1 kg is not distributed among any length, it is not distributed among any breadth, it is not distributed among any height. It is at a single point which is a zero dimensional entity, right? So think it like that. So this is at a specific position. Other than this, after talking about discrete particles or discrete distribution of mass, we are going to talk about continuous distribution of mass. We are going to talk about continuous distribution of mass. Alright. So in continuous distribution of mass, we are going to talk about a rod. Let's suppose this is a pen of no thickness. It has just talk about its, let's talk about its length, right? It has got no thickness, it has got no width. Same thing. Now the thing is, I'm going to tell you that this has got 1 kg of mass. Same thing, 1 kg was over here as well, it was at a point. Now 1 kg is distributed among length. So that is what is called as that is what is called as continuous mass distribution, right? So we are going to talk about rod and every sort of things. Well, the thing is that in NCERT and in CBSE, only what we can say is that only rod is there, right? So we are going to just talk about rod, but I am going to tell you the center of mass for every other body as well. Got it? So let's move. So first let's talk about system of particles. So for system of particles, again we are going to draw AC. So again we are going to talk about a simple thing. Let's say this is an x-axis, this is a y-axis, and we have got some point masses. We have got M1 over here, we have got M2 over here, we have got M3 over here, and so on. We have got like n number of particles over here, right? We have got n number of particles. Got it? Then we are going to say that let's suppose that this is the position vector of R1, this is the position vector of R2, this is the position vector of R3, position vector of M3, this is the position vector of Mn. All of these are from obviously from origin. So this is R1 vector, this is R2 vector, this is R3 vector, this is Rn vector. We have got n number of particles. Now are you able to understand that what do we really mean by R vector, position vector, right? What do we really mean by position vector? Is everything clear? So we are going to write, let's suppose the center of mass of all of these things, I am going to remove one of them. Let's suppose the center of mass of all of these particles is somewhere over here. This is the center of mass. Let's just suppose that this is the point where the entire mass of the system is supposed to be concentrated. Got it? So we are going to draw up another position vector, something like this, from origin, from this, and we are going to write that this is RCOM. Everything's okay? This is RCOM. So now I am going to write RCOM equals to M1 R1 plus M2 R2 plus Mn Rn whole divided by the total mass, that is M1 plus M2 plus Mn. That's how we are going to write it, right? Next thing is, if we are able to write this thing as a position vector, and of course, see, you might feel that how actually you are able to write this formula. How do we know that? You are going to derive sense out of this formula after, when we are going to talk about two particle system, right? This will make sense. For now, please try to understand that we are actually trying to do nothing, but this is actually, at least this is dimensionally absolutely correct. How? I'll tell you. I can write RCOM as summation of Mi Ri, where I is from 1 to n, whole divided by the total mass m. So the dimensionally, if I am going to check it out, the RCOM must have dimensions of length. This has mass, this is mass will be cancelled out, the dimensions are going to be cancelled out, and I have got Ri. But still, how we are able to write this formula and why we are writing this formula? The answer lies in the definition. Do you remember what we said? That we are assuming that center of mass is that points where the entire mass is supposed to be concentrated. So what we are doing is, everything's okay? No, it is not similar to midpoint, Kevin. It's not similar to midpoint. It's similar to from where the entire mass is supposed to be uniformly distributed, right? Where what we can say is that from there, instead of having different masses, we can just say that we have got just one single mass, that is m, right? After this, similarly, we are going to say that this is actually applicable for all the other coordinates. This means that RCOM is actually nothing but it is XCOM I cap plus YCOM J cap plus ZCOM K cap. What is this? XCOM is the center of mass of the x coordinate. YCOM is the y coordinate of the center of mass. ZCOM is the z coordinate of the center of mass. Got it? Got it? Got it? Everything's okay? Fine? Clear? Now after this, if you are going to talk about two particle system, position of center of mass of two particles, let's find it out using this same formula. So we have got two particles, something like this. Let's suppose we have got M1 and we have got M2, and they are at separation of let's say they are at separation of R, right? They are at separation of R, or let's say they are at separation of D. First thing first, we were using the basic concepts of Cartesian plane. So let's make a Cartesian plane over here, and here comes the easy thing. Usually what we are going to do is we are going to assume this particle to be at origin. So let's say that we have got, and for that I'll just, this is y axis, this is x axis, right? So this is M1, M1 is kept over here. So the coordinates of M1 are 0, 0. The coordinates of M2 are D, 0, right? Absolutely good. Okay, so if I'll have to write 𝐿𝐶𝐂𝐻, I'll use the formula of 𝐿𝐶𝐂𝐻 as m1 times x1 plus m2 times x2. I have not written 𝐿𝐶𝐂𝐻 in the previous slide, by the way, right? I just suppose that you will get it, divided by the total mass, that is m1 plus m2. So according to this, 𝐿𝐶𝐂𝐻 will be x1 is 0, so m1 times 0 plus m2 times d divided by m1 plus m2. So this is the position of center of mass. By the way, �Ｙ𝐶𝐂𝐻 is 0 because the mass is not kept along �Ｙ𝐶𝐂𝐻 or ZCMs, right? So don't worry about these things. Even if we are not going to write it, let's not worry about it. The formula is m2d divided by m1 plus m2. Hang on. This center of mass is from where? You tell me. This center of mass is from where? Where are we finding it? From m1. Are you getting it? We are finding it from m1. So let's suppose that the center of mass is over here. Now specifically I am not drawing it at the midpoint. Please don't think that we actually draw the center of mass at midpoint only. Nothing like that. I mean, there is no concept like that, right? So this is the center of mass and this is the 𝐿𝐶𝐂𝐻, and let's say this is actually r1. So the remaining distance is going to be d minus r1, right? So this is basically r1 is actually equals to m2d divided by m1 plus m2. And if you are going to talk about this whole thing as r2, if you are going to talk about r2, then r2 will be actually d minus r1, which will be actually m1d divided by m1 plus m2. Now if they both have equal mass, yes, the center of mass will be at midpoint. What I am trying to say that if they are equal in mass, then they will have the center of mass at their midpoint, the line joining them, right? Everything's clear? Quickly write down in the chat box if everything's clear till here. Done? Let's check some questions. Let's do some questions. Quick. Two particles of mass 1 kg and 2 kg are located at x equals to 0 and x equals to 3, right? Find the position of center of mass. So if I'll have to find out using the r1, that is from 1 kg, I'll just write m2 times d, that is the distance, divided by m1 plus m2, and I'm going to just assume that this thing is at m1 is at origin. So I'm going to write 2 kg times 3 divided by 2 plus 1, that is 3, that is 2 centimeter from 1 kg. So if it is 2 centimeter from 1 kg, that means it is at 1 centimeter or it is at 1 centimeter from 2 kg. And it makes complete sense. It makes complete sense. What is it? That center of mass lies to the body which is in greater in mass. Center of mass is nearer to the body, which has greater mass. So it's a checking point for you. So if you have got your answer, just check that is your answer whatever the position of your center of mass is it closest to the heavier object or not, right? Are you getting it, dosto? Quickly tell me. So either 1 centimeter from 2 kg or 2 centimeter from 1 kg. This is actually meter, not centimeter. So 2 meter from 1 kg. So C option is absolutely correct. Clear? Can we move to the next one? You are going to solve it. Are you going to solve it? starting the poll. Let's solve it quick. Quick. Yes, 4 months are more than sufficient. So we have got 4 kg and 2 kg located as shown in the figure. Find the position of the center of mass. Done. So it's a quite an easy one. Just find out this position of this one. So this is 5 meter, na. So if this is 5 meters, then we are going to say that this coordinate, this coordinate is going to be 5 cos 37, that is 4 by 5, comma 5 sin 37, that is 3 by 5. After it, this is actually nothing. So this is actually 5 and 5 can be cancelled out. So the coordinates are actually 4 comma 3, right? Coordinates are 4 comma 3. Now you can just solve it. So just write the particle something like this. So you have got 4 kg over here. You have got 2 kg over here. The coordinates of 2 kg are 4 comma 3. The coordinates of this 4 kg is 0 comma 0, right? So let's find, obviously we know that the center of mass will lie over here. So this is the center of mass. So let me write it R1. So this is R1, this is R2. So if I'll write it as R1, what's the quickest way to solve it? R1 will be written as 2 times of 4 divided by the total mass, that is 6. So this is 3, this is 4 by 3. What unit are we getting over here? We have to find out the 𝐿𝐶𝐶m and the 𝐌𝐶𝐶m, right? So yes, so this is the 𝐿𝐶𝐶m, this is the 𝐿𝐶𝐶m. So just a second. So if we are finding out the 𝐿𝐶𝐶m, this is absolutely correct. Now let's find out the 𝐌𝐶𝐶m. Again, for finding out the 𝐌𝐶𝐶m, I'm going to write 2 into 3 divided by 6. So it is 1. So 4 by 3 comma 1. So A is the correct answer, right? 50%, exactly 50% of you have solved it correctly. Is there anything to look for? So please tell me. Is it all good? Chalo, let's move to the next topic, and that is continuous mass distribution. And for this, again, I am going to derive a formula that is for center of mass for a uniform rod. Now again, this will require a certain what you can say a knowledge of integration, right? It's 12:43. It's not good for vacha. Okay. So we have got a rod. By the way, we usually draw a rod something like this, right? And in all the books you are going to come across the diagrams of a rod something like this, but please understand that the width of the rod is not considered, right? So this rod has just got length, there is no width. Although we are drawing it so that we can take an element out of it. I'll just explain, right? First of all, it has got no width. The total mass of this rod is m. So the total mass of this rod is m, mass of rod. And what do you mean by it is a uniform rod? So by saying that it is a uniform rod, it means that mass per unit length is constant all along the rod. It's not like I'm deviating from the topic. Have you seen a baseball bat? A baseball bat is a non-uniform distribution of mass, although it's a 3-dimensional case, but you can understand it, right? The next thing is over here, the mass in the unit length over, let's say we are taking a unit length of, let's say, 1 meter, mass is 5 kg. If you are going to select a 1 meter at any point, the mass will remain 1 kg, remain 5 kg, right? That's what we mean by uniform distribution. Got it? So mass of the rod is m, the total length of the rod is L. So L is the total length of the rod. After this, what we are going to say is, we are going to again use Cartesian plane, x-axis, y-axis, and this coordinate, this point has got coordinate as 0, 0, this point has got coordinate as 0, as L, 0, right? Can you once tell me about the this? All right. Everybody's concentration is over here. All, let's say this is the rod. Now what I am trying to say is that this rod is made up of infinitely small zero dimensional point masses. That's what I am saying. This is a one dimensional object. Everyone has got this point, right? I am saying that this one dimensional object is made up of infinitely small zero dimensional objects. And how we are going to actually assume that? Let's just suppose any one of it. So let's go at a distance of x. Let's go at a distance of x. Let's mark an infinitely small point mass. So obviously it doesn't look like an infinitely small point mass because I am exaggerating the diagram, right? So this is an element. That's what we call as element, which has got a length of dx. Now you will say to me, but just now you said that it is an infinitely small point. It is a point, that's what you said. So here's the logic behind it. We are saying that yes, it is a point mass because we are saying that dx is so small that it is tending towards 0, right? It is a way of taking out elements. This is what you need to learn. So the length of this what we can say element is dx, right? And the mass of this element is dm. Got it? Done, right? After this, we are going to say that let's suppose we have got something that is called as lambda, that is called as linear mass density. It is basically total mass divided by total length, or I can say that it can be also written as dm by dx. Well, if the total density of this, if the density of this rod is lambda and it is a case for a uniform mass distribution, then can we say that in this case lambda will be constant? So we can also write for lambda, we can write m by l, also we can write it for dm by dx. Is that correct? So now what I am going to write, please see over here. I am going to say that just now we studied for a discrete particle, we studied that 𝐿𝐶𝐿 will be written as summation of mi xi divided by the total mass, isn't it? That's what we studied, right? Summation of mi xi divided by total mass. So now I am going to say that for a continuous mass distribution case, 𝐿𝐶𝐿 will be written as integral of x dm divided by the integral of dm. Similarly, 𝐌𝐶𝐿 will be written as integral of y dm divided by the integral of dm, and 𝐿𝐶𝐿 will be written as integral of z dm divided by the integral of dm. I'll explain it. I'll explain each formula for you. And that's why I have actually written the formula for the discrete particle as well, so that we can compare this with that. Just tell me one thing, if I was to write m1 x1, what do I really mean by this m1 x1? Can anyone of you can write this in the chat box? What do we really mean by m1 x1? Well, m1 is the mass of the body, which we are just naming it as 1. So it is just m1, mass of the body, times what is x1? So x1 is the x coordinate of m1. So m1 must be kept at certain point, na? So x1 is the x coordinate of that m1. So and what do we have over here? We have got a sigma sign, that means summation, right? So instead what we are going to do is we are going to write, because we have got like this is a continuous mass distribution. So we are writing that let's take some element, something like dx, which we are saying that this whole rod is made up of infinitely small elements, and then instead of using the summation sign, because these are continuously distributed, we are going to say that 𝐿𝐶𝐿 will be written as integral of x, or let me first write dm, that is the mass of this point, times the position at which it is present, right? So dm times x and then summation, because what we want is we want to integrate all of these masses, all of the point masses from these x equals to 0 to x equals to L. So we are going to put the limit as x equals to 0 to x equals to L and then divided by what we used to do earlier, divided by the total mass. So that's what we are going to do here as well. Is that clear? The formula is all good. I hope you don't have to mug it up, right? All right, all right. But there is a practical problem over here. The problem is that if we are to see in this formula, the function is in x, obviously, because if you are going to change the point, if you are going to actually, this is movable, na? If you are going to integrate this thing from x equals to 0 from x to x equals to L, basically the things that's changing is x, but you are trying to integrate, it with respect to mass m, right? You are trying to integrate it with respect to mass m. So this is the practical problem. So what we are going to do is we are going to change from using this equation. I'm going to write dm can be written as lambda times dx. So this is the thing that we'll use. This is a substitution, that dm can be written as lambda times dx. So let's now substitute it. So 𝐿𝐶𝑢𝑚 will be written as integral, instead of x, we don't have any problem with x, instead of dm I'm going to write lambda times dx divided by again lambda times dx, and then we can put out the limit that from 0 to L we want to integrate it. All right, everything's clear? Clear? Please see. Because it is uniform, it means that lambda is constant. Again, lambda is the linear mass density. Lambda is the linear mass density. All right. So if lambda is constant, then we can cancel it out. If it is not constant, then we'll have to write the function for lambda, whatever the function is present. So this will be actually x square by 2, upper limit is L, lower limit is 0, times, in the denominator we are going to integrate 1 with respect to x, that will be 1 and that will be x, and then again 0 to L. So finally the answer will come out to be L by 2, right? So since the mass was only along x axis, our 𝐿𝐶𝑢𝑚 is coming out to be L by 2, and it's, I mean, there is no surprise, right? Why? Because if you have got a, you tell me, if I would have asked this question to a 6th grade student or even a smaller child, and I would have said that I have got a rod whose length is L and it is perfect rod, where is going to be the center of mass? He or she is going to tell me that it's at the midpoint, that is the L by 2. That's the case, but it's what, just the only thing is that we wanted to find out this answer by integration. So this is for your schools, right? Very important, not just for your schools, even for all of you who are preparing for NEET and mains and all. All right, clear? We have completed one more derivation. It's 12:45. Can we move? So like this, now you can actually you can find out the center of mass of many more things. I have already told you that in NCERT for CBSE, this will only come, right? So ring, disc, semicircular ring, semicircular disc is not the part, so we are not going to discuss that, but I have a sheet for you, I have got a table for you, so you can look at here. By the way, if we have got a ring, ring is a one-dimensional object. If we have got a ring, the center of mass will be at center, 0, 0. If we have got a disc, the center of mass will be at 0, 0. If you have got shell, a hemisphere, sorry, a sphere, hollow sphere, center of mass will be at 0, 0. The problem is when you have got something like semicircular ring, right? So what's it about? That let's suppose this was the ring, and now you are deleting the half part. Are you getting it? So if you are deleting the half part, if you are like deleting this much amount of part from the ring, what will happen? The center of mass will shift in upward direction, because now the heavier mass is on the upside, right? So center of mass will shift upwards by how much? By 2r by pi. That is for a ring. Got it? So I mean, I'll derive it afterwards. In this class we are just concerned with the midterm questions, so that will be all. Right now, again, one of the last topics for today's class, that's the types of motions of for a rigid body. Right now, again basic stuff, but you must understand it. When we are talking about types of motion of a rigid body, first try to understand what do we really mean by rigid body, right? What do we really mean by rigid body? So a rigid body is a type of a body. Let's suppose I'm saying that this is a rigid body, and we have got some particles over here. This is particle A, this is particle B, something like this, right? The distance between these two particles must not change. Any particle, I mean there are infinite many particles, right? So the distance between these two particles must not change. For example, is my hand rigid or what? No, my hand is not rigid. Why? Because the distance between the fingers can change. Is this pen rigid? Yes, this pen is rigid, because the distance, if this is going to move, the distance between any of the two particles is not going to change. So it is a rigid body. That's what the definition for a rigid body is, right? So for a rigid body, we are going to write in a rigid body, distance between any 2 points of the body does not change. Done. So now we are concerned with three types of motions. Those three types of motions are translational motion, rotational motion, and rolling motion. These are the three types of motion that you are going to come across in this chapter. So I have already explained what do we mean by translational motion. But again, if we have to define it, I'll just draw a diagram so that you can understand it. So if you have got a body something like this, and we are saying that this body is in what we can say is moving in translational motion, right? So it means that it has got infinitely many particles. It is made up of infinitely many particles. It is a continuous mass distribution case, but it has got infinite particles, right? So some of which I am going to draw it for you now, and it has got also center of mass, by the way. What I am trying to say, let's suppose the center of mass is traveling with a velocity of v/c/m. So for a translational motion, if a body is moving under translational motion, it means that every other particle v1, v2, v3 and v4, every other particle will have same velocity as that of center of mass. That's what we mean to say by translational motion. So it looks something like this, right? That's what we have said. It is the case for translational motion. Then comes rotational motion. Now in the case for rotational motion, instead of talking about that every particle will have a constant, will have a same velocity as that of center of mass, we are going to say that each particle, let's suppose I've got a body, and let me not make a very, what you can say, a definite shape of a body. Let's say again we have got like M1, M2, M3 and Mn body over here, and this body is actually rotating about an axis something like this. So I'll with some angular velocity omega. Now we are going to say that each particle will have a same angular velocity, same omega. It's a pure rotational motion. This was a pure translational motion. So this is a rotational motion, right? Every particle has a same angular velocity. This is a translational motion. If you are going to combine these two, you are going to get rolling motion. That is translation plus rotation. So in this type of a motion, what happens is a body is rotating about an axis. So right now, let's say this is the axis, it is rotating about this axis, right? And the axis starts to move. The axis starts to move in a translational motion. So this is something that is called as rotational motion. Everything's okay, fine. It just some of the two more concepts, then we'll wind it up. Got it? Quickly tell me in the chat box how many of you are still present. Let me take a quick reply. How many of you are still present? Kevin and Kirti are still here from the batch, right? All right. So now something that we are going to talk about is rotational motion, because actually in reality, all right, many of you are still here. In reality, we have been talking about translational motion so long. I mean, when we went, okay, Ramya, hi, Kirti, hi, Sandy. When we were talking about all those kinematics, all those things, we were talking about translational motion. So we have given translational motion enough attention. Now it's time for rotational motion. And when we are going to talk about rotational motion, again we are going to talk about those kinds of things. That means again the particle is rotating, right? When we are going to talk about rotational motion, again we are going to talk about those equations, like for example as omega f equals to omega I plus alpha into t. Same thing. Now the system is rotating at that particular point. The point was rotating about another point. A mass was rotating about a point. Now a system is rotating about an axis. That's the difference. Are you getting it? Good, right? Hi Tanishq, hi. So now what the equations are going to be same. That's not for a concern, right? So similarly, we are going to write each and every equations of motions for rotational motions. The important thing over here is, again, we are talking about a particle which is about a body which has got like m1 mass, m2 mass, m3 mass, and so on, mn, so on, right? And let's suppose this is the point about which it is rotating. Got it? Quickly write down in the chat box if everything's clear. Also, you know that V can be written as R omega. So hopefully you don't have any doubt over here. Quick. Yes. The kinematics is going to be same. There is going to be no change in the kinematics. We are going to have no change in the kinematics. Every equation is going to be same. I have already explained you that what is the difference. The difference is that we are going to say that instead we are not going to talk about a point. We are going to say that the point, the rigid body is rotating about an axis. That's the thing. Got it? After this, every equation is similar. V equals to R omega is similar. What we need to know is that kinetic energy of the system will be actually written as half m1 v1 square plus half m2 v2 square plus half mn vn square, right? And we know that V can be written as R omega. We know this. So after this, I am going to write that this means that the entire kinetic energy of the system is going to be written as half. For V1, I am going to write R1 into omega square, right? So omega square is constant. So I will write it as M1 R1 square plus M2 R2 square plus m3 and so on. So I'm going to write mn Rn square and times omega square. Now please tell me if you have any doubt in this formula of kinetic energy, right? Do you have any doubt in this formula for kinetic energy? What I have done, I have written the kinetic energy of each individual particles, half mv1 square, half m2 v2 square, half m3 v3 square and so on, right? Done. So after this v1 can be written as r1 omega square. By the way, each particle has got same angular velocity, that is omega. That is the case for pure rotational motion. Got it? After this, what I have done is I have taken out omega square as constant. I am going to now write this thing as half I omega square. So this is the kinetic energy of the system, and this I is known as moment of inertia of the system. I is known as moment of inertia of the system. Done? Everything's clear till here? Quickly tell me in the chat box if this is all good. Quick. So we have mathematically derived it, that what is moment of inertia, and that too we have derived it for individual particles. And can you see a relation between rotational motion and translational motion? There is a relation. There is an analogy that, see, these were the kinematics equation. We can now write it in for rotational motion as well, right? This was kinetic energy for translational motion. Now we have converted into a purely rotational motion form. Similarly, we were talking about mass in translational motion. What is really mass? Mass is actually it basically tells you about the inertia of the body. A greater the mass of a body, greater is going to be the inertia. That means the greater is going to be the resistance offered by the body for any change in its motion, right? Similarly, moment of inertia is basically the resistance offered by the body or a system of particles. Are you getting it? It is the resistance offered by the body or the system of particles for any change in rotational motion. For mass, it was any change in translational motion. For moment of inertia, it is any change in its rotational motion. Got it? So that is what moment of inertia is. Moment of inertia gives a measurement of the resistance of a body to change in its rotational motion. So greater the moment of inertia of a body is, it will be more difficult to bring that body into rotational motion, and then simultaneously we are going to say that if it is already in rotational motion, it will be more difficult to stop that body or decrease its angular speed, because it has got greater moment of inertia. Alright, right? So if a body is at rest, the larger moment of inertia of a body, the more difficult is it to put that body into the rotational motion, Similarly, larger the moment of inertia of a body, the more difficult to stop its rotational motion. The moment of inertia is calculated about an axis. So this is very important. It's just not like that we'll say that moment of inertia of a body is let's say mr square by 2. First, you will have to define about which axis you are defining, about which axis you are finding out the moment of inertia. Got it? Done? So with this, we are going to actually first, now this is actually something very important, that on which things moment of inertia actually depends. So this is very important. Moment of inertia depends upon the density of the material. It depends upon the size and shape of the body, right? So it is not something that you will be able to look at the formula and you will be able to get it. Shape and size of the body, and it obviously depends on the axis of the rotation. How does it depends on the axis of the rotation? So let's suppose this is the axis of the rotation, and about this we have got like different mass like m1, m2, m3 and mn, and all of these are actually rotating, and these are system of discrete particles, and this is r1, this is r2, this is rn, this is rn, this is r3. So I am going to say that entire moment of system of this the entire moment of inertia of this system will be summation of mi ri square I from 1 to n. So, this is going to be the entire moment of system. Got it? Right? The good part is for CBSE in NCERT, moment of inertia is only for discrete mass particles. It is not for what? It is not for continuous mass distribution. For NEET, obviously we will have to remember the continuous mass distribution case as well, right? And because of that, I think I have covered it. Because of that, for all of the NEET students or for all of the main students, you must actually, now you can remember it. The derivation is important. You can find the derivation exactly. How you are going to find out the derivation? Again, you are going to say that moment of inertia will be written as, for the continuous mass distribution, the integral of the it was m1 into r square, right? So, it will be you are going to write at r square times dm. Got it? Right? So, this is rod about perpendicular bisector is ml square by 12, plate about line parallel to edge, and other than that, still let me again tell you, there is nothing else in the NCERT. This is what we have got over here, right? Alright. Chalo, let's move to the next one. Let's complete it. We have got any topic left over here. Then we are going to talk about moment of a force, that is torque. So, for moment of a force or a torque, it is just similar to force in translational motion, that it may bring change in rotational motion. But what exactly it is? So, first of all, again torque is found out about a point, right? I am all good, thank you so much. We will just end it in couple of minutes, then I will take some rest, okay? Don't worry, thank you so much. So, now let us suppose that we want to find out the torque about okay, I will do one thing. Let us suppose I have got a point over here and there is a force acting on it, something like this. A force F is acting over here, right? And this distance is actually r and this angle is theta. And we want to find out the torque about point O. So, usually torque about any point is given as, by the way, it is in vector form, it is given as r cross f. It is given as r cross f. So, first of all, if it is a vector form, let me explain it how to find out the direction. So, the direction of torque will be found out by using cross product rule. Right? What is cross product rule? Let me explain. The cross product rule is, you have got this r over here, let's stretch it out over this point. This is angle theta. This is the plane on which everything is happening. Take out your right hand, place your palm something like perpendicular to this plane. Got it? You can do it with me. So, now what the idea behind this rule is that you need to place your fingers such that first of all your right hand is perpendicular to the plane and the fingers are along the first vector, that is r vector. So, this is the r vector, and then you need to curl your fingers such that the curled fingers touches the next vector, that is f, along the acute angle. So, the thumb is going to tell you the direction of torque. So, in this particular case, the torque is acting inside, that is cross, right? So, this is r cross f. So, the magnitude of torque can be written as r f sine theta. So, for this one, what we will do is, we will actually find that if this is f, then this is going to be f cos theta, this is going to be f sine theta. So, that is how we are going to do it. Got it? So, now if a question comes that we are talking about an equilibrium quotient, it is going to mean that from now on, it is going to mean that means that summation of net force is 0 along all axes. Also summation of torque or the net torque will be also 0. So there is going to be no change. Have I said that the particle is going to be at rest or it will be not rotating? No, I have not said that. I am saying that there will be no change in translational motion, there will be no change in rotational motion. That's what I am saying. Got it? Hi Ayush, hi. Right? That's what we are trying to say. Now let's do a question on this so that we can have a better idea. The question on this is something like this, and this is going to be the last question for poll, so attend it, right? Give it your best try. The question says determine the point of application of a third force for which the body is in equilibrium. So if the body is in equilibrium, it means that the net force acting on the body will be 0 as well as the net torque acting on the body will be 0. Got it? So 60 seconds, let's start. The last few minutes. bas hi kar diya. Although we were also supposed to complete unit, but theek hai, any which way that chapter is quite easy and there is nothing. I'll come up with another video for units for NEET. Quick. Again, equilibrium basically means that the net force acting on the body will be 0, the net torque acting on the body will be 0, and you will have to choose a point about which you want to find out the net torque, right? So let's suppose that we want to find out the net torque about point C. Why is that? So that at least this 20 Newton will not create any torque. Are you getting it? What I am trying to say? There will be no torque because of this 20 Newton. And the point, any point that you are going to choose, you can choose any point. The torque must be 0. So it's up to you. Let's come back. So first of all, the first condition is the net force acting on the particle must be 0. So there is 20 Newton acting over here, 30 Newton acting over here. There are no forces along x-axis, right? There are no forces along x-axis. That means summation of all the forces along y-axis should be 0. This means that if you have got 20 Newton over here, 30 Newton over here, there is a need of 10 Newton in this direction. This is simple maths. 10 plus 20 is 30 in the opposite direction of 30. Is that correct? And now let's say that this 10 Newton is at a distance of x from this point C. Again, let me explain why I have chosen point C, because I liked it. That's it. Got it? I have liked it. That was the reason I have chosen this point C. You could have chosen point A, you could have chosen point B, you could have chosen that 30 Newton point. It's up to you. So we are finding out the net torque about point C, that's our choice, and that is going to be, there is going to be no torque because of 20 Newton because the distance is 0. Now please understand. This is point C, this is 30 Newton. See how I am going to use the right hand rule. This is the plane at which the business is going on of rotation and everything. I am going to keep my palm perpendicular to this plane, like you give someone a, what you call as a chap, right? So now you keep your palm perpendicular to the plane. You go from this point C towards this 30 Newton. Either you can go it like this or you can go it like this. But the point is that you want to curl your fingers so that your fingers actually touch the 30 Newton. So you move from point C and then you touch 30 Newton. So thumb is pointing inwards into the plane. So now just assume one of the direction to be positive. So let's select this thing with a positive sign. So this will be denoted with a negative sign, right? Now 30 Newton times 20 centimeter, that is what R cross F is, right? Then again for this 10 Newton, so for this 10 Newton, Again, I'm going to now, if I'll put my hand like this, I won't be able to touch 10 Newton with my fingers. So I'll have to put it like this. So x times 10 Newton. So thumb is acting over here. So minus 10 times x, and this should be 0. So this is actually 60, not 6600. This is 10x. So x is 60 centimeter. So the position is 60 centimeter from point C. Let's check answer. Let's check answer. 60 centimeter from point A, wrong. From A, from here it is 60. So from A it will be 60 plus 10, that is 70. So option A is absolutely correct. So option A is absolutely correct. So okay, no worries. Hopefully you have got it, right? You have got it. Quickly write down in the chat box. That was all from tonight. That's all. Hopefully you have enjoyed it. And for all of those students who are going to watch it afterwards, please write down your doubt. If you have any doubt, write down that doubt in the comment section. I'll try to get back, right? Thank you so much for all of those students who were constantly live from the evening. Thank you so much. We were not able to complete the units and dimension. Any which way, it is quite easy. Got it? So we forgot to add 10. We did. we did add. See, we have added 10. 20 plus 10 is this one, and we have added it with a negative sign. All right. Thank you so much. Thank you. Bye. Signing off. Best of luck for your midterm exams. All of students who are in 11th grade, best of luck. Don't worry. Don't have bad feelings for this subject. This subject is all good. Start learning from the basic concepts, right? With this, I'll meet you again with a new live lecture very soon. Thank you so much. Bye bye. Take care. Good night. Good night. Bye. Okay.